The Nuclear Umbrella. Volume 6 Transformation, Case Studies, and Vision. Pakistan's Muslim NATO leadership from bad to the nuclear age. Quality defeats quantity. The strategic transformation of 2 billion Muslims from divided to united. Introduction. Beyond. Population, the true determinants of power. How many a small company has overcome a large company by permission of Allah? Quran 2:249. Throughout human history, the struggle between quantity and quality has been a recurring theme in warfare, statecraft, and civilizational resilience. In an age obsessed with numerical strength, GDP figures, and demographic forecasts, the fundamental insight offered by this Quranic verse remains a profound and counterintuitive truth. This introduction lays the conceptual foundation for a 6-volume vision of Muslim collective security, centered on Pakistan's unique position as a military, ideological, and geopolitical nucleus of the Ummah. This introduction is not merely rhetorical. It frames the philosophical and strategic core of the nuclear umbrella, Pakistan's Muslim NATO leadership, and sets the stage for a journey across 6 distinct yet interlinked volumes. Volume I explores Islamic strategic traditions and military doctrine. Volume 2 examines Pakistan's strategic capabilities and positioning. Volume 3 diagnoses internal and external threats to the Ummah. Volume 4 outlines the structural design of a Muslim NATO. Volume V maps its operational implementation across regions. Volume 6 provides transformation case studies and the long-term vision note on implementation. This 6-volume framework is envisioned as a 5-year strategic plan, open for adoption by the current regime of Pakistan. If embraced with sincerity and resolve, its implementation can elevate Pakistan and the Muslim Ummah to the ranks of a true global superpower. If the present leadership is unwilling or unable, the vision remains preserved for a future government, whoever that may be. The one who realizes this vision will alter the trajectory of the Muslim world, just as Quaid-e-Azam Muhammad Ali Jinnah changed history through the creation of Pakistan. Part 1. Foundation and Strategic Framework. Introduction of Chapter 1. This comprehensive chapter establishes the foundational paradigm shift from traditional AI training to AI fluency development, providing the theoretical and research foundation that supports your entire program approach. The chapter systematically builds understanding through 6 interconnected sections. 1. The evolution from AI training to AI fluency development establishes the fundamental paradigm shift using clear analogies and practical examples. 2. Why traditional technical training fails, provides evidence-based analysis of current limitations. 3. The business technology bridge concept defines the core role of AI-fluent professionals. 4. Enterprise AI adoption research synthesizes current market research and trends. 5. 4-pillar competency architecture introduces the integrated competency framework. 6. ROI framework provides practical measurement methodologies. Each section builds logically on previous concepts while introducing increasingly sophisticated ideas about professional development in the AI era. The content integrates the latest research findings you referenced while maintaining the patient, encouraging teaching tone that helps readers understand complex concepts through step-by-step explanations and practical examples. This foundation chapter sets up the entire manual by establishing why comprehensive AI fluency development represents a strategic imperative rather than just beneficial. Training, preparing readers for the detailed implementation guidance that follows in subsequent chapters. Chapter 1. Understanding the AI-Fluent Professional. Paradigm. Learning objectives. By the end of this chapter, you will understand why traditional AI training approaches fall short of organizational needs, how AI-fluent professionals differ from technically trained individuals, and why developing comprehensive AI competency represents a strategic imperative for modern organizations. You will also gain insight into the research foundation that guides this approach and the specific frameworks that ensure measurable return on investment. Think of this chapter as laying the foundation for a new way of thinking about professional development in the age of artificial intelligence. Just as the introduction of personal computers in the 1980s required developing a new category of computer-literate professionals, the AI revolution demands creating AI-fluent professionals who can navigate the complex intersection of technology, business strategy, and human dynamics. 1.1 The evolution from AI training to AI. Fluency development. Understanding the fundamental shift. Imagine you're learning to play the piano. Traditional music education might teach you to read notes, understand scales, and practice technical exercises until you can play pieces accurately. This approach produces technically competent musicians who can perform written music effectively. However, becoming a professional musician requires much more: understanding how music creates emotional impact, knowing how to collaborate with other musicians, grasping the business aspects of the music industry, and developing the ability to adapt your performance to different audiences and contexts. The evolution from AI training to AI fluency development represents a similar transformation in how we prepare professionals for the AI-driven workplace. Traditional AI training focuses on tool proficiency and technical skills, teaching people how to use ChatGPT effectively, explaining machine learning algorithms, or demonstrating how to build simple AI applications. While these technical skills have value, they represent only one dimension of what organizations actually need for successful AI implementation. AI fluency development, by contrast, recognizes that successful organizational AI adoption requires professionals who can think strategically about AI opportunities, implement solutions that work reliably in complex business environments, lead the human side of technological change, and ensure that AI development serves broader organizational and societal interests. Just as the professional musician needs both technical skill and broader musical understanding, the AI-fluent professional needs both technical competency and comprehensive understanding of how AI creates value within organizational contexts. The historical pattern of technology adoption. To understand why this evolution matters, consider how previous transformative technologies required similar shifts in professional development approaches. When personal computers emerged in the 1980s, initial training programs focused on teaching people to use specific software applications, word processing, spreadsheets, and databases. Organizations quickly discovered that technical proficiency alone didn't translate to business value creation. The professionals who became most valuable during the personal computer revolution weren't necessarily those with the deepest technical knowledge of computer hardware or software programming. Instead, they were individuals who could identify business processes that computers could improve, design implementations that enhanced rather than disrupted existing workflows, help colleagues adapt to new ways of working, and ensure that computer adoption supported rather than undermined organizational objectives. These early computer-literate professionals became the bridge builders who enabled organizational transformation. They could translate between technical possibilities and business needs, facilitate change management processes, and ensure that technology adoption created genuine value rather than just impressive demonstrations. The AI revolution follows a similar pattern, but with significantly greater complexity and stakes. AI technologies affect not just how we process information or complete tasks, but how we make decisions, interact with customers, and even understand ourselves and our work. The professionals who will become most valuable during the AI transformation are those who develop comprehensive fluency across all dimensions of AI implementation rather than narrow technical expertise. Defining AI fluency in practice. AI fluency encompasses four integrated competency areas that work together to create comprehensive capability for leading organizational AI adoption. Think of these as interconnected. Languages that AI-fluent professionals must speak fluently to function effectively in their roles. The technical language includes understanding how AI systems work, their capabilities and limitations, implementation requirements, and integration challenges. However, this technical understanding focuses on practical application rather than theoretical depth. AI-fluent professionals need to know enough about AI technology to make informed decisions about tool selection, evaluate vendor claims realistically, and design implementations that will work reliably in production environments. The business language involves translating between AI technical capabilities and organizational strategic needs. This includes identifying high-value AI opportunities, estimating return on investment accurately, developing business cases that resonate with decision-makers, and measuring success in terms that matter to organizational stakeholders. AI-fluent professionals become skilled at connecting AI possibilities to specific business problems and opportunities. The human language addresses the psychological and social dynamics that determine whether AI implementations succeed or fail in practice. This includes understanding how people respond to technological change, designing AI systems that enhance rather than threaten human capability, creating training and support systems that enable successful adoption, and building organizational cultures where AI adoption happens naturally rather than through mandate. The ethical language ensures that AI implementations remain aligned with organizational values and societal interests. This includes recognizing and mitigating bias in AI systems, protecting privacy and individual rights, maintaining transparency and accountability in AI decision-making, and ensuring that AI development serves broad stakeholder interests rather than narrow technical or economic objectives. The integration challenge. The critical insight that drives AI fluency development is that these four languages must be learned and practiced together rather than separately. Real AI implementation projects require simultaneous consideration of technical feasibility, business value, human factors, and ethical implications. Professionals who understand only one or two of these dimensions often create solutions that fail when they encounter the complexity of actual organizational environments. Consider a practical example: implementing an AI-powered customer service chatbot. Technical training might focus on natural language processing capabilities, integration APIs, and performance optimization. Business training might emphasize cost reduction, response time improvements, and customer satisfaction metrics. Human factors training might address employee concerns about job displacement and workflow changes. Ethics training might cover privacy protection and bias prevention. AI fluency development ensures that professionals considering this implementation automatically think about all four dimensions simultaneously. They design technical solutions that support business objectives while enhancing human work and maintaining ethical standards. They develop implementation plans that address technical requirements, business value creation, change management, and governance frameworks as integrated components of a comprehensive strategy. This integrated approach produces professionals who can lead AI adoption initiatives that succeed in the complex, messy reality of organizational life rather than just in controlled demonstration environments. 1.2 Why traditional technical training fails. In enterprise AI adoption. The demonstration to deployment gap. Picture a scenario that plays out frequently in organizations worldwide. A technically skilled professional creates an impressive AI demonstration that accurately classifies customer service inquiries, generates compelling marketing copy, or predicts equipment maintenance needs. The demonstration works beautifully in controlled conditions with clean data and clear success criteria. However, when the organization attempts to deploy this solution in their actual business environment, everything becomes complicated. The AI system struggles with the messy, inconsistent data that exists in real business systems. Integration with existing software proves more complex than anticipated. Employees resist using the new tool because it disrupts their established workflows. Customers express concerns about privacy and algorithmic decision-making. Regulatory compliance requirements add layers of complexity that weren't considered during the demonstration phase. What seemed like a technical success becomes an organizational failure. This demonstration to deployment gap represents the fundamental limitation of traditional technical training approaches. By focusing primarily on AI tool proficiency and technical capabilities, these programs prepare individuals to create impressive prototypes but fail to develop the comprehensive competencies needed for successful enterprise implementation. Research from McKinsey's 2025 AI Adoption Survey reveals that over 80% of organizations report difficulty translating AI pilot projects into scalable business value. This challenge isn't due to inadequate AI technology or insufficient technical skills among their teams. Instead, the gap exists because technical competency alone doesn't address the complex integration challenges that arise when AI systems must work within existing organizational structures, processes, and cultures. The complexity of real-world implementation. To understand why technical training falls short, consider the differences between creating an AI application in an educational or experimental setting versus implementing that same application within an enterprise environment. In educational settings, AI projects typically involve clean datasets that have been pre-processed to remove inconsistencies and errors. The success criteria are clearly defined and usually focused on technical metrics like accuracy or performance speed. The user base consists of technically sophisticated individuals who understand the system's limitations and can work around its quirks. The project exists in isolation, without needing to integrate with other systems or comply with external regulations. Enterprise AI implementation operates under dramatically different constraints. Data comes from multiple sources with varying quality levels, formatting inconsistencies, and unknown biases. Success criteria include not only technical performance but also business value creation, user satisfaction, regulatory compliance, and alignment with organizational values. The user base consists of people with varying technical backgrounds who need the system to enhance their existing work rather than require them to adapt to technical limitations. The AI system must integrate seamlessly with existing business processes, software systems, and organizational workflows. Perhaps most critically, enterprise AI implementation occurs within complex human and organizational contexts where technical excellence represents just one factor among many that determine success or failure. The AI system must gain acceptance from employees who may fear job displacement, satisfy customers who have privacy and fairness concerns, meet regulatory requirements that are often unclear or evolving, and deliver results that justify ongoing investment from leadership teams focused on business outcomes. The silo problem in traditional training. Traditional technical training approaches often create what researchers call silo thinking, deep expertise in narrow domains that lacks integration across the broader competency areas required for successful implementation. This siloed approach produces professionals who can build sophisticated AI models but struggle to identify genuine business opportunities, create user experiences that feel natural and empowering, or navigate the change management challenges that determine adoption success. Consider how this plays out in practice. A data scientist with excellent machine learning skills might develop a highly accurate predictive model for customer behavior. However, if they lack business fluency, they might focus on technical sophistication rather than solving the specific problems that matter most to marketing teams. If they lack change management skills, they might create a system that requires marketers to change their workflows dramatically rather than enhancing their existing processes. If they lack ethical reasoning capabilities, they might build a system that inadvertently discriminates against certain customer groups or violates privacy expectations. The result is technically impressive solutions that fail to create business value or gain organizational acceptance. These failures often get attributed to technical limitations or organizational resistance to change, but they actually reflect inadequate preparation for the integrated competency requirements of real-world AI implementation. The communication breakdown challenge. One of the most significant failures of traditional technical training is its inability to prepare professionals for the complex communication and collaboration challenges that define successful AI adoption. Enterprise AI implementation requires constant communication and coordination among diverse groups, technical teams focused on system functionality, business stakeholders concerned with strategic value creation, end users worried about workflow disruption, executives responsible for resource allocation and strategic direction, and compliance teams ensuring regulatory adherence. Each of these groups speaks different languages, prioritizes different objectives, and measures success using different criteria. Technical training typically prepares individuals to communicate effectively with other technically minded people but fails to develop the translation skills needed to bridge these different perspectives. AI-fluent professionals, by contrast, become skilled at multilingual communication within organizational contexts. They can explain technical AI capabilities in terms of business value creation when speaking with executives. They can translate business requirements into technical specifications when working with development teams. They can communicate with end users about workflow changes in terms of capability. Enhancement rather than technology replacement. They can work with compliance teams to ensure AI implementations meet regulatory requirements without sacrificing functionality or user experience. This communication fluency becomes particularly critical when AI implementations encounter challenges or require modifications. Traditional technically trained professionals often struggle to explain problems or propose solutions in ways that resonate with non-technical stakeholders, leading to misunderstandings, blame attribution, and project failures that could have been avoided with better communication. The innovation without adoption problem. Traditional technical training often emphasizes innovation and cutting-edge capabilities while neglecting the practical adoption factors that determine whether innovations create value in organizational settings. This emphasis produces professionals who are excited about AI's technical possibilities but lack the skills to implement those possibilities in ways that organizations can actually use effectively. The innovation without adoption problem manifests in several ways. Technical teams might implement the latest AI models without considering whether their organizations have the data quality, infrastructure readiness, or user adoption capabilities needed to benefit from advanced features. They might focus on maximizing technical performance metrics while ignoring user experience considerations that determine whether people will actually use the system. They might prioritize technical elegance over reliability, creating systems that work impressively in demonstrations but fail frequently in production environments. AI fluency development addresses this problem by emphasizing practical value creation over technical sophistication. AI-fluent professionals learn to evaluate AI opportunities based on their potential for creating measurable business value rather than just technical impressiveness. They design implementations that prioritize user adoption and business integration over technical optimization. They understand that the best AI solution is the one that organizations can implement successfully and benefit from sustainably, not necessarily the one that uses the most advanced algorithms or achieves the highest benchmark scores. This shift in perspective from technical innovation to practical value creation represents a fundamental reorientation that enables AI implementations to succeed in real organizational environments rather than just in controlled technical demonstrations. 1.3 The Business Technology Bridge, Core Concept of AI-fluent professionals. Understanding the translation challenge. Imagine you're serving as an interpreter between two groups of people who speak completely different languages and come from vastly different cultural backgrounds. One group consists of business leaders who think in terms of revenue growth, market share, customer satisfaction, and competitive advantage. They measure success through quarterly earnings, operational efficiency improvements, and other group consists strategic positioning. The of technical professionals who think in terms of algorithms, data structures, system architecture, and performance optimization. They measure success through accuracy metrics, processing speed, and technical elegance. These two groups need to work together to implement AI successfully, but they often struggle to understand each other's perspectives, priorities, and constraints. Business leaders make requests that seem simple but are technically complex or impossible. Technical professionals create solutions that are mathematically elegant but don't address the actual business problems or fit within organizational constraints. AI-fluent professionals serve as bridges between these different worlds, but their role extends far beyond simple translation. They become bilingual or even multilingual speakers who can think natively in both business and technical languages while also understanding the human and ethical dimensions that influence successful AI implementation. The anatomy of bridge building. Effective bridge building between business and technology requires several integrated capabilities that work together to create genuine understanding and collaboration rather than superficial communication. Business problem identification involves learning to see organizational challenges through a business lens rather than a technical lens. AI-fluent professionals develop the ability to walk through any business process and identify inefficiencies, bottlenecks, decision points that lack adequate information, and communication challenges that create friction or errors. They learn to think like business consultants who understand how work actually gets done within organizations. Consider a practical example. When examining a customer service operation, technically oriented individuals might immediately focus on the potential for chatbots or automated response systems. AI-fluent professionals first understand the business context. What are the most common customer issues? What information do service representatives need to resolve problems effectively? How does customer service performance affect customer retention and revenue? What constraints do representatives face in their current workflows? Only after understanding these business realities do they consider how AI might address specific challenges. Technical possibility mapping involves understanding AI capabilities well enough to recognize which business challenges could benefit from AI solutions and which couldn't. This requires practical knowledge of what different AI systems can and cannot do reliably, what data and infrastructure requirements they have, and what integration challenges they present. However, this technical understanding focuses on practical application rather than theoretical depth. AI-fluent professionals don't need to understand the mathematical foundations of neural networks, but they do need to know when neural network approaches are likely to work well and when simpler solutions might be more appropriate. They need to understand the difference between AI capabilities that work in research environments and those that can be deployed reliably in business settings. Value translation represents perhaps the most critical bridge-building capability, the ability to connect technical AI capabilities to specific business value creation in ways that can be measured and verified. This involves learning to think in terms of business metrics like cost reduction, revenue increase, productivity improvement, quality enhancement, or risk mitigation rather than technical metrics like accuracy scores or processing speed. For instance, an AI system that can classify customer emails with 95% accuracy becomes valuable when that classification enables faster response times, better routing to appropriate specialists, and improved customer satisfaction scores. The technical capability creates business value, but AI-fluent professionals learn to focus on the business outcomes rather than the technical achievements. Strategic thinking development. AI-fluent professionals develop strategic thinking capabilities that enable them to consider AI implementation within broader organizational contexts rather than as isolated technical projects. This strategic perspective considers how AI initiatives fit within overall business strategy, how they interact with other organizational priorities, and how they contribute to long-term competitive advantage. Competitive context analysis involves understanding how AI implementation affects organizational positioning within their market and industry. AI-fluent professionals learn to evaluate AI opportunities not just based on internal efficiency gains but also based on their potential for creating competitive advantages, responding to competitive threats, or enabling new business models. For example, implementing AI for internal process automation might reduce costs and improve efficiency, which creates value. However, implementing AI to enhance customer experience or enable new service offerings might create competitive advantages that have much greater strategic impact. AI-fluent professionals learn to recognize these strategic differences and prioritize AI initiatives accordingly. Integration planning focuses on understanding how AI implementations affect and are affected by other organizational systems, processes, and initiatives. Rather than treating AI projects as standalone technical implementations, AI-fluent professionals consider how they integrate with existing business processes, support other strategic initiatives, and contribute to broader organizational transformation goals. This integration thinking becomes particularly important as organizations implement multiple AI systems that need to work together effectively. AI-fluent professionals develop the ability to design AI implementations that enhance rather than conflict with each other and that support rather than complicate broader organizational objectives. Communication architecture development. One of the most sophisticated capabilities that AI-fluent professionals develop is the ability to design and facilitate communication across the diverse stakeholder groups involved in AI implementation. This goes beyond simple translation to include creating communication architectures that enable ongoing collaboration and coordination. Stakeholder mapping involves identifying all the different groups that are affected by or can influence AI implementation success, understanding their different perspectives and priorities, and designing communication strategies that address their specific needs and concerns. This includes not only business leaders and technical teams but also end users, customers, regulatory bodies, and other stakeholders who might not be directly involved in implementation but whose support or opposition can determine success. Multi-audience communication design focuses on developing messages and presentations that can be tailored for different stakeholder groups while maintaining consistency and accuracy. AI-fluent professionals learn to explain the same AI initiative in terms of strategic value when speaking with executives, technical feasibility when working with engineering teams, workflow enhancement when training end users, and compliance adherence when working with regulatory specialists. This multi-audience communication capability becomes particularly critical when AI implementations encounter challenges or require modifications. AI-fluent professionals can facilitate problem-solving conversations that include diverse perspectives and expertise while maintaining focus on practical solutions rather than blame attribution. Collaborative decision-making facilitation involves creating processes where business and technical considerations are integrated into decision-making rather than treated as competing priorities. AI-fluent professionals learn to facilitate conversations where technical constraints inform business strategy while business objectives guide technical implementation decisions. Value creation focus. Perhaps the most distinctive characteristic of AI-fluent professionals is their consistent focus on practical value creation rather than technical sophistication or business theory. This value creation focus shapes how they approach every aspect of AI implementation, from opportunity identification through solution design to success measurement. Practical impact measurement involves learning to identify and track metrics that demonstrate genuine business value rather than just technical performance or activity levels. AI-fluent professionals become skilled at designing measurement frameworks that connect AI implementation efforts to business outcomes that matter to organizational stakeholders. This measurement focus influences how AI projects are designed and implemented. Rather than optimizing for technical metrics that might not translate to business value, AI-fluent professionals design AI systems that directly support measurable business improvements. They learn to balance technical optimization with practical adoption factors that determine whether AI implementations actually create the intended value. Sustainable implementation design focuses on creating AI solutions that continue delivering value over time rather than just working impressively during initial demonstrations. This requires understanding the operational realities of maintaining AI systems, supporting user adoption, and adapting to changing business conditions. AI-fluent professionals learn to design AI implementations that organizations can actually sustain and benefit from long-term. This includes considering maintenance requirements, update procedures, user training needs, and adaptation capabilities that enable AI systems to remain valuable as conditions change. Through developing these bridge-building capabilities, AI-fluent professionals become the connective tissue that enables organizations to transform AI technical possibilities into practical business value while ensuring that implementation Processes enhance rather than disrupt human work and organizational culture. 1 point for enterprise AI adoption research. Insights and market context. The current state of enterprise AI adoption. Recent research from leading consulting firms and technology organizations reveals a fascinating paradox in enterprise AI adoption that fundamentally shapes how we should approach professional development in this field. While organizational investment in AI continues accelerating, with 62% of companies increasing their AI budgets in 2025, the gap between AI investment and measurable business impact remains stubbornly wide. Andreessen Horowitz's 2025 research on enterprise AI adoption patterns provides particularly illuminating insights into this disconnect. Their analysis of Fortune 500 companies reveals that AI spending has shifted dramatically from experimental innovation budgets to core operational funding. In 2023, approximately 25% of AI initiatives were funded through innovation or research budgets that tolerated uncertain returns. By 2025, this percentage dropped to just 7%, with the majority of AI funding now coming from core IT and business unit budgets that demand measurable returns on investment. This shift signals organizational maturation in AI adoption. Companies are no longer willing to fund AI experiments that might produce interesting results. Instead, they're demanding AI implementations that create demonstrable business value, integrate effectively with existing operations, and contribute to strategic objectives. This evolution creates dramatically different requirements for the professionals responsible for AI implementation success. McKinsey's complementary research reinforces this pattern while revealing the human capability gap that prevents many organizations from capturing AI value effectively. Their 2025 survey of over 1,000 enterprises found that more than 80% of organizations report difficulty translating AI pilot projects into scalable business value. Critically, this difficulty isn't primarily attributed to technical limitations or inadequate AI technology. Instead, 63% of organizations identify human factors, including skills gaps, change management challenges, and organizational readiness limitations, as the primary barriers to successful AI adoption. The multimodal reality. One of the most significant developments in enterprise AI adoption is the rapid shift toward multimodal environments that require entirely different management and integration approaches than single-vendor AI solutions. Deloitte's 2025 AI implementation study found that 37% of enterprises now use 5 or more different AI models, compared to just 29% in the previous year. This trend toward AI diversity creates complex new challenges for organizations and their AI implementation teams. Think about what this multimodal reality means in practical terms. A typical enterprise might use OpenAI's GPT models for content generation and customer service, Google's AI for document processing and translation, Anthropic's Claude for complex reasoning and analysis, specialized models for industry-specific applications like medical diagnosis or financial risk assessment, and custom-trained models for proprietary business processes. Each of these AI systems has different capabilities, limitations, integration requirements, data needs, and cost structures. Managing this complexity requires professionals who can evaluate different AI vendors and models for specific use cases, design integration architectures that enable multiple AI systems to work together effectively, and create governance frameworks that ensure consistent quality and compliance across diverse AI implementations. Traditional technical training that focuses on single AI platforms or generic AI concepts fails to prepare professionals for this multi-vendor, multimodal reality. The multimodal trend also creates new categories of strategic decisions that organizations must navigate effectively. Should they standardize on fewer AI vendors to reduce complexity, or leverage specialized models to optimize performance for specific use cases? How should they balance the benefits of cutting-edge AI capabilities against the risks of vendor dependence? What governance frameworks ensure consistent ethical standards across different AI systems that may have been trained with different datasets and objectives? AI-fluent professionals develop the competencies needed to help organizations navigate these strategic decisions effectively. while implementing the technical and operational frameworks required to manage multimodal AI environments successfully. The Production Deployment Challenge. Research from PwC's 2025 AI Maturity Assessment reveals another critical insight that shapes professional development requirements: the growing gap between organizations that can move AI from prototype to production successfully and those that remain stuck in perpetual pilot mode. Their analysis found that companies successful at scaling AI share several common characteristics, most notably the presence of professionals who understand both AI technical and production deployment realities. Requirements. Production deployment of AI systems involves challenges that rarely appear during prototype development but can determine implementation success if not addressed proactively. These include data drift over time that degrades AI performance, integration complexities with existing enterprise systems, scalability requirements as user bases grow, security and compliance obligations that affect system design, and monitoring needs that ensure ongoing reliability and value creation. Consider a practical example that illustrates these production challenges. A marketing team might develop an AI-powered content generation system that works beautifully during pilot testing with a small group of users and carefully curated content types. However, when deployed across the entire marketing organization, the system encounters content requirements that weren't present during testing, integration needs with campaign management systems that weren't considered during development, and performance demands that exceed the prototype's capacity. Successful production deployment requires professionals who can anticipate these challenges during the design phase and create implementation plans that address them proactively. This requires understanding both AI technical capabilities and enterprise operational realities, the kind of integrated competency that AI fluency development provides. The change management success factor. Perhaps the most striking finding from current research is the critical importance of change management capabilities in determining AI implementation success. Harvard Business School's 2025 study of AI transformation initiatives found that organizations that integrate systematic change management approaches into their AI implementations are 47% more likely to achieve their stated objectives compared to those that focus primarily on technical deployment. This research finding challenges traditional assumptions about technology adoption that emphasize technical training and system functionality over human factors and organizational dynamics. The Harvard study reveals that successful AI adoption depends as much on helping people adapt to AI-enhanced workflows as on implementing technically sophisticated AI systems. The change management challenge in AI adoption has several distinctive characteristics that require specialized approaches. Unlike previous technology adoptions that primarily affected how people completed existing tasks, AI implementation often changes what tasks people do and how they think about their roles within organizations. AI systems can automate routine work, augment decision-making processes, and enable entirely new types of work that didn't exist previously. These changes create psychological and social dynamics that technical training alone cannot address. People may feel threatened by AI's capabilities, confused about how to work effectively with AI systems, or uncertain about their future roles in AI-enhanced organizations. Successful AI adoption requires professionals who can design implementations that feel empowering rather than threatening, create training and support systems that help people adapt successfully, and build organizational cultures where AI adoption enhances rather than undermines job satisfaction and professional development. The regulatory and ethical compliance evolution. The regulatory landscape for AI implementation is evolving rapidly, creating new requirements for organizations and the professionals responsible for AI governance. The European Union's AI Act, California's AI transparency requirements, and sector-specific regulations in healthcare, finance, and other industries are establishing compliance frameworks that affect how AI systems must be designed, deployed, and monitored. These regulatory developments create new professional competency requirements that extend beyond technical implementation to include compliance management, risk assessment, and stakeholder communication. Organizations need professionals who can navigate complex and evolving regulatory requirements while ensuring that compliance enhances rather than hinders AI value creation. The regulatory critical importance capabilities in evolution also highlights ethical reasoning. The AI implementation. As public awareness of AI's potential for bias, privacy violations, and other forms of harm increases, organizations face growing expectations for responsible AI development that goes beyond legal compliance to include proactive ethical consideration. Current research from the Partnership on AI reveals that organizations with comprehensive AI ethics frameworks are more successful at building stakeholder trust, avoiding regulatory challenges, and maintaining public support for their AI initiatives. However, developing and implementing these ethics frameworks requires professionals who can balance innovation objectives with responsibility considerations, another aspect of the integrated competency that AI fluency development provides. Market dynamics and competitive implications. The research also reveals how AI adoption is reshaping competitive dynamics within industries, creating both opportunities and threats for organizations based on their AI. Implementation capabilities. Companies that develop effective AI adoption capabilities can gain significant competitive advantages, while those that lag behind face increasing competitive pressure. Bain & Company's 2025 analysis of AI competitive impact found that organizations with mature AI capabilities are gaining market share at accelerating rates compared to competitors that struggle with AI adoption. However, competitive advantage comes not from having access to advanced AI technology, which is increasingly available to all organizations, but from having the human capabilities needed to implement AI effectively and create sustainable business value. This competitive reality creates urgency around developing AI-fluent professionals who can help organizations implement AI faster and more effectively than their competitors. The companies that build these human capabilities first will establish competitive advantages that become increasingly difficult for competitors to overcome as AI adoption accelerates across industries. The research findings provide clear direction for professional development approaches that can address the complex, integrated challenges that define successful enterprise AI adoption. Organizations need professionals who can navigate technical complexity, create business value, lead change management, and ensure ethical compliance simultaneously rather than focusing on any single dimension of AI implementation. The 4-Pillar 1.5 Architecture Overview. Competency. The architectural logic of integrated competency development. Imagine designing a bridge that must span a complex terrain with multiple challenges, deep water that requires sophisticated engineering, rocky soil that demands careful foundation work, strong winds that necessitate aerodynamic design, and heavy traffic that requires durable materials and efficient traffic flow management. A successful bridge design integrates all these requirements rather than optimizing for just one factor. Similarly, successful AI implementation requires professionals who can navigate multiple complex domains simultaneously rather than excelling in just one area. The 4-pillar competency architecture emerges from extensive research into why some AI implementations succeed while others fail, revealing that success requires simultaneous competency across strategic thinking, technical implementation, change management, and ethical reasoning. These 4 pillars work together like the structural elements of our metaphorical bridge. Each must be strong individually, but they must also integrate seamlessly to support the full weight of organizational AI transformation. Understanding why this integrated approach proves necessary requires examining how AI implementation challenges span multiple domains that traditional educational and professional development approaches treat separately. A typical AI project might require identifying strategic business opportunities, designing technical solutions that work reliably in production environments, managing the human dynamics that determine adoption success, and ensuring that implementations remain fair and compliant with evolving regulations. Traditional approaches that separate these concerns often produce solutions that excel in one dimension while failing in others. Pillar 1: Strategic AI Translators, the Business Technology Bridge Builders. The Strategic AI Translator pillar develops professionals who can identify meaningful AI opportunities within business contexts and communicate effectively across technical and non-technical audiences. These individuals become the bridge builders who help organizations understand where AI can create genuine value rather than just impressive demonstrations. Think of strategic AI translators as bilingual professionals who can think natively in both business and technical languages while serving as interpreters between different organizational groups. However, their role extends far beyond simple translation to include strategic analysis, opportunity identification, and value creation planning that connects AI capabilities to specific business objectives. Business process analysis capability represents the foundation of strategic AI translation. These professionals learn to examine organizational workflows systematically, identifying inefficiencies, bottlenecks, decision points that lack adequate information, and communication challenges that create friction or errors. This analysis capability enables them to recognize where AI applications could create measurable improvements rather than just automating existing processes. Consider how this works in practice. When examining a customer service operation, strategic AI translators don't immediately jump to chatbot implementations. Instead, they first understand the business context. What are the most common customer issues and how complex are they to resolve? What information do service representatives need and how easily can they access it? How does response time affect customer satisfaction and retention? What constraints do representatives face in their current workflows? Only after understanding these business realities do they consider how specific AI capabilities might address particular challenges. AI capability mapping involves developing practical understanding of what different AI systems can and cannot do reliably, what data and infrastructure requirements they have, and what integration challenges they present. This technical understanding focuses on practical application rather than theoretical depth. Strategic AI translators need to know when natural language processing approaches are likely to work well and when simpler rule-based systems might be more appropriate, but they don't need to understand the mathematical foundations of transformer architectures. Value translation and business case development represents perhaps the most critical capability within this pillar. Strategic AI translators learn to connect technical AI capabilities to specific business value creation in ways that can be measured and verified. This involves thinking in terms of business metrics like cost reduction, revenue increase, productivity improvement, quality enhancement, or risk mitigation rather than technical metrics like accuracy scores or processing speed. For instance, an AI system that can analyze customer feedback with sophisticated sentiment analysis becomes valuable when that analysis enables faster identification of product issues, better understanding of customer preferences, or more effective marketing message development. The technical capability creates business value, but strategic AI translators learn to focus on quantifiable business outcomes rather than technical achievements. Multi-audience communication mastery enables strategic AI translators to explain AI initiatives effectively to diverse organizational stakeholders. They develop the ability to present the same AI opportunity in terms of strategic value when speaking with executives, technical feasibility when working with engineering teams, workflow enhancement when training end users, and compliance adherence when working with regulatory specialists. This communication fluency becomes particularly critical when AI implementations encounter challenges or require modifications. Strategic AI translators can facilitate problem-solving conversations that integrate diverse perspectives and expertise while maintaining focus on practical solutions rather than blame attribution. Pillar 2: Implementation Engineers, the Technical Reality Creators. The implementation engineers pillar develops professionals who understand both AI capabilities and the practical complexities of enterprise technology deployment. Rather than focusing solely on AI model development, these individuals learn to design complete systems that integrate with existing infrastructure, handle real-world data complexity, meet security and compliance requirements, and maintain reliability under production usage patterns. Think of implementation engineers as the architects and general contractors of AI systems. While they need solid understanding of AI technology, their primary focus is creating solutions that work reliably within the complex constraints and requirements of actual organizational environments. Systems architecture thinking represents the foundational capability that distinguishes implementation engineers from traditional AI developers. These professionals learn to design AI solutions that integrate effectively with existing enterprise technology infrastructure while planning for scalability, security, and maintainability requirements that may not be obvious during initial development. This systems thinking includes understanding data flow architecture, API integration strategies, security frameworks, and performance optimization techniques that ensure AI systems enhance rather than complicate existing business operations. Implementation engineers learn to evaluate technical trade-offs based on total cost of ownership, long-term maintainability, and business value creation rather than just initial functionality or technical elegance. Production readiness framework development focuses on the critical capabilities needed to move AI systems from prototype demonstrations to reliable business tools. This includes error handling strategies that enable graceful degradation when AI systems encounter unexpected inputs, monitoring systems that detect performance issues before they affect business operations, and maintenance procedures that ensure AI systems continue delivering value over time. Consider the difference between an AI-powered inventory management system that works impressively during demonstrations with clean test data and one that operates reliably in a complex retail environment with inconsistent data formats, integration requirements with multiple business systems, and performance demands that vary dramatically based on seasonal business patterns. Implementation engineers develop the competencies needed to design and build systems that handle real-world complexity effectively. Enterprise integration methodology encompasses the practical skills needed to connect AI systems with existing business applications, databases, and workflows. This includes API design and management, data pipeline architecture, security integration, and testing methodologies that ensure AI systems work seamlessly within existing technology ecosystems. Implementation engineers also develop competencies in vendor evaluation and management, recognizing that most enterprise AI implementations involve multiple vendors and platforms that must work together effectively. They learn to design integration architectures that can accommodate different AI services while maintaining consistent performance, security, and governance standards. Multimodal architecture design addresses the emerging reality that most enterprises use multiple AI models and services for different applications. Implementation engineers learn to design systems that can leverage different AI capabilities effectively while managing the complexity of multi-vendor environments. This includes understanding how to route different types of requests to appropriate AI services, how to manage authentication and rate limiting across multiple AI vendors, and how to ensure consistent quality and compliance standards across diverse AI implementations. Pillar 3: Change Orchestrators, the human-centered adoption leaders. The Change Orchestrators pillar develops expertise in the human dynamics that determine whether AI implementations succeed or fail within organizations. These professionals understand both AI technology and the psychological and social factors that influence how people respond to technological change, enabling them to design implementations that enhance rather than threaten human capability. Change orchestrators serve as the cultural architects of AI adoption, ensuring that technological implementation enhances organizational culture and human work rather than creating disruption, anxiety, or resistance that undermines intended benefits. Human psychology of AI adoption provides the foundational understanding that enables effective change orchestration. These professionals learn to recognize common patterns of human response to AI implementation, from enthusiasm and curiosity to anxiety and resistance, and develop strategies for addressing these responses proactively rather than reactively. This psychological understanding includes recognizing how AI affects people's sense of professional identity, job security, and competence. Unlike previous technologies that primarily changed how people completed existing tasks, AI often changes what tasks people do and how they think about their roles within organizations. Change orchestrators learn to design AI implementations that help people understand how AI enhances their capabilities rather than threatens their relevance. Human-centered AI design principles focus on ensuring that AI implementations feel empowering rather than threatening to end users. This involves understanding how to design AI interfaces and workflows that maintain human agency and control while leveraging AI capabilities effectively. Consider the difference between an AI-powered sales support system that makes recommendations and enables humans to make final decisions versus one that automates decision-making and reduces humans to implementation roles. Change orchestrators learn to design AI systems that enhance human judgment and capability rather than replacing human thinking with algorithmic processing. Adoption community building involves identifying and developing internal champions who can accelerate AI adoption within their teams and departments. Change orchestrators learn to recognize individuals who have both technical aptitude and social influence, then provide them with training and support that enables them to become effective advocates for AI adoption. This community-building approach recognizes that sustainable AI adoption happens through peer influence and social learning rather than top-down mandate or formal training programs alone. Change orchestrators create networks of adoption leaders who can help their colleagues navigate the practical and emotional challenges of adapting to AI-enhanced work environments. Training program design for technology adoption encompasses the instructional design and adult learning capabilities needed to help people develop AI skills effectively. This includes understanding how people learn new technologies, designing hands-on practice opportunities that build confidence and competence, and creating support systems that help people overcome initial challenges and confusion. Change orchestrators learn to design training programs that go beyond tool instruction to include mindset development, workflow integration, and ongoing support that enables successful long-term adoption rather than just initial familiarity. Pillar 4. The Ethics and Governance Specialists, the Responsible Innovation Guardians. The Ethics and Governance Specialists pillar develops competencies in responsible AI development that ensure implementations remain fair, transparent, accountable, and aligned with organizational values while supporting innovation and business objectives. These professionals serve as the organizational conscience for AI initiatives while enabling rather than hindering responsible development. Think of ethics and governance specialists as the quality assurance and risk management professionals for AI implementation, ensuring that the pursuit of business value and technical innovation doesn't compromise ethical standards or create unintended harm for stakeholders. Bias recognition and mitigation framework provides systematic approaches for identifying and addressing unfair outcomes in AI systems across their entire life cycle. This includes understanding how bias enters AI systems through training data, algorithm design, and implementation decisions, as well as developing practical strategies for detecting and correcting bias without sacrificing system effectiveness. Ethics and governance specialists learn to design bias testing methodologies that reveal disparate impacts on different population groups, develop mitigation strategies that improve fairness while maintaining business value, and create monitoring systems that detect emerging bias as AI systems operate in production environments. Transparency and explainability architecture focuses on making AI decision-making processes understandable to relevant stakeholders. This involves understanding different types of AI explanation techniques and selecting appropriate approaches based on audience needs and regulatory requirements. Consider the difference between explaining an AI hiring screening system to job candidates who want to understand how decisions affect them versus explaining the same system to hiring managers who need to understand how to use AI recommendations effectively in their decision-making process. Ethics and governance specialists learn to design explanation frameworks that serve different stakeholder information needs while building trust and enabling accountability. Privacy protection and data governance encompasses comprehensive frameworks for protecting individual privacy while enabling effective AI implementation. This includes understanding privacy-preserving technologies, consent management systems, data minimization strategies, and governance structures that ensure AI systems respect individual privacy rights while creating organizational value. Regulatory compliance navigation involves understanding complex and evolving regulatory requirements for AI implementation across different industries and jurisdictions. Ethics and governance specialists learn to design compliance Frameworks that meet regulatory requirements while enabling innovation and business value creation. Governance system design focuses on creating organizational structures and processes that provide appropriate oversight for AI development and deployment. This includes designing ethics review processes, risk assessment frameworks, and accountability mechanisms that ensure AI implementations remain aligned with organizational values and stakeholder interests. The integration imperative. The critical insight that drives the four-pillar architecture is that these competencies must be developed and practiced together rather than separately. Real AI implementation projects require simultaneous consideration of strategic value creation, technical feasibility, human factors, and ethical implications. Professionals who understand only one or two of these dimensions often create solutions that fail when they encounter the integrated environments. Complexity of actual organizational. The four-pillar approach ensures that every participant develops working knowledge across all competency areas while potentially specializing more deeply in one area. This creates professionals who can collaborate effectively with specialists from other domains while understanding how their specialized knowledge contributes to broader AI implementation success. This integrated competency development produces AI-fluent professionals who naturally think about strategic, technical, human, and ethical dimensions simultaneously when approaching AI implementation challenges. They become the connective tissue that enables organizations to transform AI technical possibilities into practical business value while ensuring that implementation processes enhance rather than disrupt human work and organizational culture. 1.6 Return on Investment Framework for AI. Team development programs. Understanding ROI in the context of professional development. Measuring the return on investment for professional development programs requires a fundamentally different approach than calculating ROI for traditional business investments like equipment purchases or marketing campaigns. While a new piece of manufacturing equipment creates value through increased production capacity that can be measured directly, professional development creates value through enhanced human capability that manifests in improved decision-making, more effective problem-solving, and better collaboration across multiple projects and contexts over extended time periods. The challenge becomes even more complex when measuring ROI for AI team development programs because the value created extends beyond individual skill enhancement to include organizational transformation capabilities, competitive positioning improvements, and risk mitigation benefits that are difficult to quantify precisely but critically important for long-term success. Think of ROI measurement for AI team development as similar to measuring the value of education. A university degree creates value not just through the specific knowledge gained in classes but through enhanced critical thinking capabilities, expanded professional networks, improved communication skills, and increased adaptability that benefit graduates throughout their careers. Similarly, AI fluency development creates value through enhanced strategic thinking, improved technical decision-making, better change management capabilities, and stronger ethical reasoning that benefit both individuals and organizations across multiple AI initiatives over many years. Immediate Impact Measurement Framework. The most straightforward components of ROI measurement for AI team development focus on immediate, quantifiable improvements that occur during and shortly after program completion. These immediate impacts provide clear evidence of program effectiveness while building foundation for longer-term value creation. Project success rate improvement represents one of the most measurable immediate impacts from AI team development. Organizations that implement comprehensive AI fluency programs typically experience significant increases in the percentage of AI projects that achieve their stated objectives within planned timelines and budgets. Research from the MIT Center for Collective Intelligence found that organizations with AI-fluent professionals leading implementation projects experience success rates of 73% compared to 41% for organizations relying primarily on traditional technical training approaches. This 32 percentage point improvement in project success rates creates immediate, measurable value that often exceeds the total investment in AI team development programs. Consider the practical implications of this improvement for an organization implementing 10 AI projects annually with average budgets of $200,000 each. Improving success rates from 41% to 73% means that approximately 3 additional projects achieve their objectives each year, creating $600,000 in additional value annually from the same total investment level. Time to value acceleration measures how quickly AI implementations begin creating business value after initiation. AI-fluent professionals typically design and implement AI solutions more efficiently than traditionally trained teams because they understand both business requirements and technical constraints from the beginning of projects rather than discovering integration challenges after development is complete. Stanford's 2025 research on AI implementation efficiency found that teams led by AI-fluent professionals achieve initial value creation 47% faster than teams relying on traditional technical approaches. This acceleration occurs because AI-fluent professionals design solutions that address business needs directly rather than requiring extensive modification after initial development. Implementation cost reduction occurs because AI-fluent professionals make better decisions about vendor selection, system architecture, and integration approaches that reduce total cost of ownership for AI systems. They avoid common mistakes like over-engineering solutions, selecting inappropriate tools, or creating technical debt that requires expensive remediation later. Quality improvement metrics track improvements in the business outcomes that AI implementations are designed to achieve. Organizations with AI-fluent professionals typically achieve better results from their AI investments because these professionals design implementations that optimize for business value rather than just technical performance. Long-term value creation assessment. While immediate impact measurement provides important evidence of program effectiveness, the most significant ROI from AI team development programs comes from long-term value creation that compound over multiple years as AI-fluent professionals apply their capabilities across numerous projects and initiatives. Organizational AI maturity advancement represents one of the most significant sources of long-term value from AI team development programs. Organizations with AI-fluent professionals advance more rapidly through AI maturity stages, enabling them to undertake more sophisticated AI initiatives that create greater competitive advantages. McKinsey's AI Maturity Assessment Framework identifies 5 stages of organizational AI adoption: experimental, conducting isolated pilot projects; operational, implementing AI in specific business functions; systematic, integrating AI across multiple business processes; transformational, using AI to enable new business models; and ecosystem, leveraging AI to create network effects with partners and customers. Organizations typically progress through these maturity stages over 3 to 5 years when relying on traditional approaches to AI adoption. However, organizations that develop comprehensive AI fluency capabilities often advance through these stages 6,080% faster, enabling them to capture competitive advantages and business value that's slower moving. Introduction of Chapter 2. This chapter builds systematically on the foundational concepts by introducing the specific program architecture and learning philosophy that makes AI fluency development effective. The chapter addresses 6 critical design principles. 1. 90-day intensive model explains why concentrated learning creates superior outcomes through sustained focus, momentum building, and skill integration. 2. Attitude-based selection details how growth mindset, collaborative orientation, and communication skills predict success better than technical credentials. 3. Integrated competency development shows why siloed training fails and how spiral curriculum approaches create cross-domain problem-solving abilities. 4. Human-centered AI adoption establishes change management as core curriculum, addressing psychology of technology adoption and designing for human agency. 5. Prototype to production thinking bridges the gap between demonstrations and real-world implementation through systems architecture and reliability planning. 6. Continuous assessment philosophy transforms assessment from periodic measurement to ongoing learning driver through portfolio development and peer collaboration. Each section provides both theoretical foundation and practical implementation guidance, maintaining the encouraging tone while building complexity systematically. The chapter successfully connects the paradigm shift established in Chapter 1 with the specific program design decisions that enable effective competency development. This foundation prepares readers for the detailed participant selection and competency development guidance in subsequent chapters, ensuring they understand not just what to do but why these approaches prove more effective than traditional training methods. Chapter 2 Program: Architecture and Learning Philosophy. Learning Objectives. By the end of this chapter, you will understand the educational theory and practical design principles that guide effective AI fluency development. You will grasp why intensive 90-day programs create superior learning outcomes compared to extended traditional courses, how attitude-based selection produces better results than academic credentials, and why integrated competency development succeeds where siloed training fails. Most importantly, you will understand how to design learning experiences that translate directly to real-world organizational value creation. Think of this chapter as the architectural blueprint for building AI-fluent professionals. Just as successful building construction requires understanding both engineering principles and practical construction realities, effective AI fluency development requires understanding both learning theory and organizational implementation challenges. 2.1 The 90-day intensive development. Model, theory and practice. The science of accelerated competency development. Consider the difference between learning to swim by taking one lesson per week for 6 months versus participating in an intensive 2-week swimming program with daily instruction and practice. While both approaches might eventually teach basic swimming skills, the intensive program typically produces more confident, capable swimmers who are ready to swim independently in various conditions. The intensive approach works better not just because of increased time investment, but because of how concentrated learning enables skill integration and confidence building that distributed learning often fails to achieve. The 90-day intensive model for AI fluency development applies similar principles from accelerated learning research, but adapted specifically for the complex, multi-domain competency requirements of AI implementation. Understanding why this intensive approach proves more effective than traditional extended training programs requires examining both the cognitive science of skill acquisition and the practical realities of organizational professional development. Research from the Center for Creative Leadership has consistently demonstrated that intensive development experiences create more sustainable behavior change than extended programs with the same total contact hours. This occurs because intensive programs enable what educational psychologists call immersive learning environments, where participants can focus deeply on new concepts without the distraction and forgetting that occurs during gaps between learning sessions. Cognitive load management in complex learning. AI fluency development presents unique cognitive challenges because it requires integrating knowledge across multiple domains simultaneously: business strategy, technical implementation, change management, and ethical reasoning, while developing practical application skills in each area. Traditional educational approaches often fragment this learning across separate courses or modules, making integration difficult and reducing transfer to real-world situations. The 90-day intensive model addresses cognitive load challenges through what researchers call spiral curriculum design. Instead of teaching each competency domain separately, participants encounter all 4 pillars repeatedly throughout the program with increasing complexity and integration. Week 1 introduces prompt engineering concepts, but participants immediately apply these concepts to business scenarios while considering change management and ethical implications. This integrated approach helps participants understand how different competency areas work together rather than treating them as separate subjects. Consider how this works in practice. During Week 2's Business Impact Workshop, participants don't just learn business analysis techniques in isolation. They apply these techniques to identify AI opportunities, consider the technical feasibility of different approaches, plan for change management challenges, and address ethical considerations, all within the context of realistic organizational scenarios. This integration occurs naturally because the intensive format allows time for comprehensive exploration rather than rushing through separate topic areas. Memory consolidation and skill transfer. Neuroscience research reveals that intensive learning experiences create stronger neural pathway development than distributed learning when the goal is developing complex, integrated competencies. The 90-day intensive format enables what memory researchers call elaborative rehearsal, repeatedly practicing new skills in different contexts until they become automatic rather than requiring conscious effort. This memory consolidation process proves particularly important for AI fluency development because participants must be able to apply their competencies quickly and naturally when they encounter AI implementation challenges in their work environments. Traditional training programs often fail to create this automatic competency because participants learn concepts in artificial training environments and then struggle to transfer those concepts to real workplace situations. The intensive format addresses transfer challenges by incorporating authentic practice opportunities throughout the learning experience. By week 4, participants are implementing small AI solutions in their current work environments. By week 8, they're leading AI adoption conversations with colleagues. By week 12, they're presenting AI strategy recommendations to senior leadership. This progression from simulation to real-world application ensures that learning translates to practical capability rather than remaining theoretical knowledge. Momentum and motivation maintenance. One of the most significant advantages of the intensive format is its ability to maintain participant engagement and motivation throughout the learning process. Extended training programs often struggle with declining participation and enthusiasm as the initial excitement of learning new skills gives way to competing work priorities and gradual forgetting of earlier concepts. Research from the Association for Talent Development found that professional development programs longer than 4 months experience average completion rates of 67%, while intensive programs under 4 months achieve completion rates of 89%. More importantly, participants in intensive programs report higher confidence levels and faster application of learning to their work responsibilities. The 90-day format creates what psychologists call learning momentum, a positive feedback cycle where early successes build confidence that enables tackling more complex challenges, which creates additional successes that further increase confidence and motivation. This momentum proves particularly important for AI fluency development because participants must be willing to experiment with new tools and approaches that initially feel uncomfortable or unfamiliar. Deep work and flow state achievement. Cal Newport's research on deep work and Mihaly Csikszentmihalyi's studies of flow states provide important insights into why intensive learning formats produce superior outcomes for complex competency development. The 90-day intensive model enables participants to achieve what researchers call sustained attention states where they can focus deeply on challenging learning tasks without frequent interruption. Traditional training programs that meet once per week or rely on brief online modules rarely enable deep work or flow states because participants must constantly shift attention between training activities and regular work responsibilities. This attention fragmentation prevents the kind of concentrated focus needed to master complex, integrated competencies like those required for AI fluency. The intensive format addresses attention challenges by creating dedicated learning time periods where participants can immerse themselves fully in AI concepts and applications. This immersion enables breakthrough understanding and skill development that simply cannot occur when learning time is fragmented across extended periods. Practical implementation considerations. Workload balance and organizational support. Successfully implementing a 90-day intensive program requires careful attention to workload balance that enables deep learning without creating unsustainable stress or neglecting participants' regular work responsibilities. Research suggests that intensive professional development programs work best when participants can dedicate 20 to 30% of their time to learning activities while maintaining their primary job responsibilities. This balance requires organizational support and planning that goes beyond simply enrolling employees in training. Successful implementation often involves temporarily redistributing some work responsibilities, providing coverage for participants during intensive learning activities, and ensuring that supervisors understand and support the learning objectives. Organizations that achieve the best results from intensive AI fluency programs typically establish explicit expectations that participants will spend 10 to 15 hours per week on learning activities, including both formal instruction and practical application projects. This time investment enables the deep engagement needed for competency development while remaining sustainable within normal work schedules. Cohort learning and peer support networks. The intensive format enables the development of strong peer support networks that enhance individual learning while creating collaborative relationships that continue beyond the formal program. Research from Harvard Business School demonstrates that cohort-based learning produces superior outcomes compared to individual training approaches, particularly for complex competencies that require integration across multiple domains. Cohort learning works effectively in the AI fluency context because participants can learn from each other's different perspectives and experiences while providing mutual support for tackling challenging concepts and applications. A marketing professional learning AI applications can benefit from insights shared by colleagues from operations, finance, or customer service who are identifying different types of AI opportunities within their functional areas. The intensive format enables cohort members to develop genuine working relationships rather than superficial acquaintanceships. By week 6, participants typically form project teams that continue collaborating on AI initiatives beyond the formal program completion. These ongoing relationships create internal networks of AI-fluent professionals who can support each other's continued development and implementation efforts. Assessment integration and continuous feedback. The 90-day intensive model enables more sophisticated assessment approaches than traditional training programs because there is sufficient time for multiple assessment cycles with feedback and improvement. Instead of relying primarily on end-of-program evaluations, the intensive format incorporates weekly skills validation, peer assessment opportunities, and progressive portfolio development that provides continuous evidence of competency growth. This continuous assessment approach serves both formative and summative purposes. Formatively, regular assessment helps participants understand their learning progress and identify areas that need additional attention. Summatively, the accumulated assessment evidence provides comprehensive documentation of competency development that can support career advancement and role expansion decisions. The intensive format also enables authentic assessment through real-world project implementation rather than artificial testing scenarios. By the program's end, participants have portfolios of actual AI implementations they've completed in their work environments, providing concrete evidence of their practical capabilities rather than just their ability to pass knowledge tests. 2.2 Attitude-based selection over academic. Credentials, the science behind success. Predictors. Rethinking traditional selection criteria. Imagine you're hiring a head chef for a high-end restaurant. Traditional hiring approaches might focus heavily on culinary school credentials, technical cooking certifications, and previous job titles. However, experienced restaurant owners often look for different qualities: creativity under pressure, ability to work collaboratively with diverse team members, continuous learning orientation, attention to detail that extends beyond technical requirements, and genuine passion for creating exceptional dining experiences. The most successful chefs aren't necessarily those with the most impressive credentials, but those who combine technical competency with the attitudes and mindsets that enable them to adapt, innovate, and lead effectively in demanding, dynamic environments. Similarly, the most successful AI-fluent professionals aren't necessarily those with the strongest technical backgrounds or most prestigious academic credentials, but those who possess the psychological and behavioral attributes that predict success in the complex, evolving world of organizational AI implementation. This shift from credentials-based to attitude-based selection represents one of the most important design decisions in developing effective AI fluency programs. Understanding why this approach produces superior outcomes requires examining current research on talent selection, professional development effectiveness, and the specific success factors that distinguish effective AI implementation leaders. The limitations of credentials-based selection. Traditional selection approaches for technology training programs typically emphasize academic background, technical certifications, and previous job experience related to the training content. These criteria seem logical because they provide easily measurable indicators of candidate preparation and motivation. However, extensive research reveals that these traditional criteria often fail to predict actual performance in complex, real-world professional environments. Google's Project Oxygen, one of the most comprehensive studies of professional effectiveness predictors, found that technical expertise ranked last among the 8 most important qualities of successful employees. The top-ranking factors included coaching ability, communication skills, insight into others' perspectives, and critical thinking capabilities, all attitude and mindset characteristics rather than technical credentials. This pattern proves particularly pronounced in AI implementation contexts because success depends heavily on factors that credentials cannot measure: comfort with ambiguity and rapid change, ability to collaborate across different organizational domains, willingness to experiment with new approaches, and capacity to think strategically about technology applications rather than just technical functionality. Consider the practical implications. A software engineer with impressive machine learning credentials might struggle to identify genuine business opportunities for AI implementation because they focus on technical sophistication rather than practical value creation. Conversely, a business analyst with limited technical background but strong curiosity about technology applications and collaborative problem-solving orientation might become highly effective at leading AI adoption initiatives after developing appropriate technical fluency. The psychology of learning and adaptation. Research from Stanford's Growth Mindset Institute reveals that individual attitudes about learning and ability development predict training success more reliably than initial skill levels or academic background. People with growth mindsets who believe abilities can be developed through effort and learning consistently outperform those with fixed mindsets who believe abilities are largely predetermined, even when the fixed mindset individuals start with higher initial skill levels. This finding has profound implications for AI fluency development because the field of AI changes rapidly, requiring continuous learning and adaptation throughout professionals' careers. Traditional credentials capture what people have learned in the past, but growth mindset orientation predicts what they will be able to learn in the future, a much more valuable attribute in the rapidly evolving AI domain. Growth mindset assessment in practice. Identifying growth mindset orientation requires assessment approaches that reveal how candidates respond to challenges, handle feedback, and approach unfamiliar problems rather than what they already know. Effective assessment might present candidates with an AI tool they've never used and observe their approach to learning it. Do they experiment systematically? Do they seek help when needed? Do they persist through initial confusion? Do they focus on understanding underlying principles or just memorizing specific procedures? These behavioral indicators reveal much more about likely success in AI fluency development than any academic transcript or certification. Candidates who demonstrate curiosity, systematic experimentation, help seeking when appropriate, and persistence through initial difficulty are likely to succeed in the intensive learning environment regardless of their starting technical knowledge level. Collaborative problem-solving orientation. AI implementation success depends heavily on cross-functional collaboration because AI projects typically require integration across technical development, business strategy, user experience design, and ethical compliance. Traditional selection criteria often fail to assess collaborative capabilities because they focus on individual achievements rather than team contribution and facilitation skills. Research from the MIT Center for Collective Intelligence demonstrates that team intelligence, the collective ability of groups to solve problems, depends more on individual team members' social sensitivity and communication skills than on their individual intelligence or expertise levels. Teams with members who can read others' emotions accurately, facilitate inclusive participation, and build on diverse perspectives consistently outperform teams of individually brilliant but socially less skilled members. This research suggests that selecting for collaborative problem-solving orientation will produce better AI implementation outcomes than selecting for individual technical expertise. Candidates who naturally ask questions that draw out others' perspectives, build on ideas from team members with different backgrounds, and help groups move toward practical solutions demonstrate the collaborative capabilities that predict AI adoption success. Assessment methods for collaborative orientation. Evaluating collaborative problem-solving requires assessment scenarios that reveal how candidates behave in group settings rather than just how they perform individually. Effective assessment might involve group exercises where candidates must work together to analyze an AI opportunity they're unfamiliar with observers noting who asks clarifying questions, who helps integrate different viewpoints, and who contributes to practical problem-solving progress. These assessments reveal genuine collaborative instincts that predict success in real AI implementation projects where diverse perspectives and expertise must be integrated effectively. Candidates who naturally facilitate group problem-solving will become more effective AI implementation leaders than those who prefer to work independently, regardless of their individual technical capabilities. Business application curiosity and strategic thinking. The practical problem-solving orientation. Perhaps counterintuitively, the most successful AI-fluent professionals are often those who are more curious about business problems than about AI technology itself. They view AI as a powerful tool for solving organizational challenges rather than as an interesting technical pursuit. This orientation toward practical problem-solving predicts implementation success because it ensures that AI applications create genuine business value rather than just impressive technical demonstrations. Traditional technical training often attracts individuals who are fascinated by technology for its own sake. While this technical curiosity can drive innovation and deep expertise development, it can also lead to solutions that are technically sophisticated but poorly aligned with actual business needs or user requirements. Business application curiosity, by contrast, drives professionals to understand organizational challenges first and then consider how AI might address those challenges effectively. This sequence, from problem understanding to solution design, produces AI implementations that create measurable value and gain organizational support rather than remaining isolated technical achievements. Assessment through problem identification. Evaluating business application curiosity requires assessment approaches that reveal how candidates naturally think about problems and opportunities in their current work environments. Effective assessment might ask candidates to identify inefficiencies or challenges in their current roles and describe how they might approach solving them. Listen for candidates who naturally think about systems, processes, and improvement opportunities rather than just completing assigned tasks. Someone who says, "I spend too much time manually categorizing customer emails and wonder if there's a better way," demonstrates the business-focused thinking that makes AI adoption successful. This orientation toward process improvement and efficiency optimization predicts success in identifying genuine AI opportunities. Systems thinking and integration perspective. Successful AI implementation requires understanding how technology changes affect broader organizational systems rather than just specific task completion. Candidates with natural systems thinking orientation consider how changes in one area might affect other areas, how different stakeholder groups might respond to changes, and how implementations can be designed to enhance rather than disrupt existing workflows. This systems perspective proves particularly important for AI implementation because AI changes often have ripple effects throughout organizations. An AI-powered customer service system affects not only customer service representatives but also supervisors, training staff, IT support, and customer experience measurement. Professionals who naturally consider these broader implications design more successful implementations than those who focus narrowly on specific technical functionality. Ethical reasoning and values alignment. The foundation of responsible AI development. AI implementation requires individuals who naturally consider broader implications of their actions and decisions. This ethical reasoning capability involves understanding how technology affects different stakeholder groups, considering potential unintended consequences, and ensuring that efficiency or capability improvements don't create unfairness or harm for individuals or communities. Research from the Ethics and Governance of AI initiative at MIT reveals that organizations with strong ethical reasoning capabilities among their AI implementation teams experience significantly fewer bias-related problems, privacy violations, and regulatory compliance challenges. More importantly, these organizations build stronger stakeholder trust and public support for their AI initiatives. Ethical reasoning for AI implementation doesn't require formal training in philosophical ethics, but it does require natural inclination to consider multiple perspectives and think about long-term consequences of decisions. Candidates who demonstrate thoughtful consideration of how actions affect others and who express concern for fair outcomes will become natural champions for responsible AI development. Assessment through ethical scenario discussion. Evaluating ethical reasoning requires presenting scenarios related to AI use and observing how candidates naturally approach ethical considerations. For example, assessment might describe an automated hiring system that improves efficiency but may inadvertently discriminate against certain groups, then ask candidates how they would approach this challenge. Listen for candidates who naturally consider multiple perspectives: job applicants, hiring managers, company leadership, and affected communities. Look for individuals who think about both immediate benefits and potential long-term consequences. Value candidates who express genuine concern for fair outcomes rather than just compliance with regulations. The goal isn't to identify candidates who have predetermined correct answers to ethical questions, but to find individuals who naturally engage in ethical reasoning and who consider broader stakeholder impacts when making decisions about technology implementation. Communication bridge building capability. Multi-audience translation skills. AI-fluent professionals must regularly translate between technical and non-technical audiences, explaining complex AI concepts to business stakeholders while communicating business requirements to technical teams. This communication bridge-building capability involves more than just avoiding technical jargon. It requires understanding what different audiences care about most and framing information in terms that resonate with their priorities and concerns. Research from the Center for Creative Leadership demonstrates that professionals who can communicate effectively across different organizational domains advance faster in their careers and contribute more to organizational success than those with deeper but narrower expertise. This pattern proves particularly pronounced in AI implementation contexts because successful projects require ongoing coordination among diverse stakeholder groups. Assessment of communication adaptability. Evaluating communication bridge-building capability requires assessment scenarios where candidates must explain complex concepts to different types of audiences. For example, assessment might have candidates explain a somewhat complex process from their current work to someone unfamiliar with their field, then observe how they adapt their explanation based on audience feedback. Look for candidates who naturally use analogies and examples that connect to their audience's experience. Value those who check for understanding and adjust their explanation based on audience response. Prefer candidates who focus on helping their audience understand practical implications rather than demonstrating their own expertise. These communication skills become crucial when AI implementations encounter challenges or require modifications. Candidates who can facilitate productive conversations among diverse stakeholder groups will become more effective AI implementation leaders than those who struggle with cross-functional communication, regardless of their technical expertise levels. The integration of selection criteria. The most important insight from attitude-based selection research is that these different attributes work together to create comprehensive capability for AI implementation leadership. Growth mindset enables continuous learning and adaptation. Collaborative orientation facilitates cross-functional teamwork. Business curiosity drives practical value creation. Ethical reasoning ensures responsible development. Communication skills enable stakeholder coordination and support. Effective selection processes assess all these attributes rather than focusing on any single factor, recognizing that AI fluency requires integrated competency across multiple domains. The combination of positive attitudes and mindsets provides a much stronger foundation for competency development than any specific technical background or academic credential. This integrated approach to selection produces cohorts of participants who not only learn effectively during the intensive program but who continue growing and adapting as the AI field evolves throughout their careers. They become the organizational assets who can lead AI adoption initiatives successfully while building trust and support among colleagues and stakeholders. 2.3 Integrated Competency Development. Why siloed training fails. Understanding the world AI implementation complexity of RAIAL. Picture a construction project where the architectural team designs a beautiful building without consulting the engineering team about structural requirements. The engineering team specifies systems without considering the electrical team's needs, and the electrical team plans installations without coordinating with the plumbing team. Each group might excel at their specialized domain, but the resulting building would likely be unbuildable, unsafe, or extremely inefficient due to lack of integration across different expertise areas. Traditional professional development approaches often create similar problems by teaching different competency areas in isolation. A typical technology training program might offer separate modules on technical skills, business strategy, project management, and compliance requirements. While each module might provide excellent instruction within its domain, participants often struggle to integrate these different competencies when they encounter the messy, complex realities of actual organizational implementation projects. AI implementation presents particularly acute integration challenges because success requires simultaneous consideration of technical feasibility, business value creation, human adoption factors, and ethical implications. These different domains don't just need to coexist, they must work together seamlessly to create solutions that are technically sound, strategically valuable, humanly acceptable, and ethically responsible. The interdependence of AI implementation domains. Consider a practical example that illustrates why siloed training approaches fail in AI contexts. An organization wants to implement an AI-powered customer service chatbot to reduce response times and handle routine inquiries more efficiently. Traditional training approaches might address this challenge through separate educational modules. Technical training focuses on natural language processing capabilities, API integration, and performance optimization. Business training emphasizes cost reduction calculations, ROI measurement, and competitive advantage analysis. Change management training addresses employee concerns about job displacement and workflow modifications. Ethics training covers privacy protection, bias prevention, and transparency requirements. While each of these training areas provides valuable knowledge, the real implementation challenge requires integrating all these considerations simultaneously. The technical solution must support business objectives while enabling smooth human workflow integration and maintaining ethical standards. These aren't separate requirements that can be addressed sequentially, they're interdependent factors that must be balanced and optimized together. For instance, technical design decisions about how the chatbot escalates complex inquiries to human representatives directly affect both business value creation by determining what percentage of inquiries can be handled automatically, and human experience by influencing how empowered or frustrated human representatives feel when they receive escalated cases. Similarly, privacy protection requirements might limit data collection capabilities that could improve Technical performance, requiring careful balance between ethical compliance and business value optimization. The problem of sequential learning. Traditional educational approaches often teach different competency areas sequentially, assuming that learners can integrate separate knowledge areas after mastering each domain individually. However, research from cognitive science reveals that sequential learning approaches often fail to create integrated competency because learners develop separate mental models for different domains that resist integration. When learners study technical AI capabilities separately from business applications, they often develop technical thinking patterns that focus on algorithmic sophistication rather than practical value creation. When they study business strategy separately from technical constraints, they may develop unrealistic expectations about what AI can accomplish or how quickly implementations can be completed. When they study change management separately from technical and business considerations, they may focus on human factors without understanding the technical and business drivers that create implementation urgency. These separated mental models create what psychologists call cognitive compartmentalization. Knowledge exists in distinct mental categories that aren't naturally connected during problem-solving situations. Compartmentalized. When professionals with knowledge encounter AI implementation challenges, they often struggle to access real, relevant knowledge from different domains simultaneously, leading to solutions that optimize for one dimension while neglecting others. Integrated learning through authentic challenges. Effective AI fluency development addresses integration challenges through what educational researchers called authentic learning experiences, learning activities that mirror the complexity and integration requirements of real-world professional challenges. Instead of teaching technical skills, business analysis, change management, and ethical reasoning as separate subjects, integrated approaches embed all these competency areas within realistic AI implementation scenarios. Consider how this works in practice during a prompt engineering learning module. Rather than just teaching technical prompt optimization techniques, integrated learning includes strategic context. Participants identify real business challenges in their current roles that could benefit from prompt-based AI solutions. Technical application. They develop and refine prompts that address these specific business challenges effectively. Change management integration. They consider how colleagues would need to learn and adopt prompt-based tools. Ethical evaluation. They assess potential bias, privacy, or fairness implications of their prompt designs. This integrated approach ensures that participants learn technical skills within business contexts while considering human and ethical factors from the beginning. They develop mental models that naturally connect technical capabilities to business applications while incorporating change management and ethical considerations as essential rather than optional components. Cross-domain problem-solving development. Integrated competency development focuses on building cross-domain problem-solving capabilities that enable professionals to navigate complex challenges that span multiple expertise areas. This involves developing what researchers call boundary-spanning skills, the ability to work effectively across different organizational domains and integrate diverse perspectives into practical solutions. Research from the Harvard Kennedy School demonstrates that professionals with strong boundary-spanning capabilities become more effective leaders and contribute more to organizational innovation than those with deeper but narrower expertise. This pattern proves particularly important for AI implementation because successful projects require ongoing coordination among technical teams, business stakeholders, end users, and compliance specialists. Developing systems thinking capabilities. One of the most important outcomes of integrated competency development is enhanced systems thinking, the ability to understand how changes in one area affect other areas and how different components of complex systems interact to create overall performance. Systems thinking proves essential for AI implementation because AI changes often have ripple effects throughout organizations that must be anticipated and managed proactively. Traditional siloed training approaches often fail to develop systems thinking because they encourage learners to focus deeply within single domains rather than understanding relationships across domains. Participants might become highly skilled at technical AI development but struggle to understand how their technical decisions affect user experience, business value creation, or ethical compliance. Integrated approaches develop systems thinking by consistently requiring learners to consider how decisions in one domain affect performance in other domains. When participants design technical AI solutions, they must simultaneously consider business impact, user adoption requirements, and ethical implications. This consistent cross-domain integration develops natural systems thinking patterns that transfer to new challenges throughout their careers. The spiral curriculum approach. Progressive complexity with consistent integration. Educational research supports what psychologists call spiral curriculum approaches for developing complex, integrated competencies. Instead of covering each topic once in isolation, spiral curricula revisit key concepts multiple times with increasing sophistication and integration. This approach enables learners to build foundational understanding during initial exposure, then develop deeper mastery through subsequent encounters that reveal additional complexity and connections. The AI Fluency Development Program applies spiral curriculum principles by introducing all four competency pillars during Week 1, then revisiting and deepening understanding of each pillar throughout the 90-day program. Participants encounter prompt engineering concepts in Week 1, but they continue applying and refining prompt engineering skills in business analysis contexts during Week 2, technical integration projects during Weeks 3 to 4, automation workflows during Weeks 5 to 6, and ethical evaluation exercises during Weeks 10 to 11. This spiral approach ensures that learners understand how prompt engineering capabilities connect to business value creation, technical implementation requirements, change management challenges, and ethical considerations rather than viewing prompt engineering as an isolated technical skill. Building cognitive scaffolding for integration. Spiral curriculum approaches work effectively because they build what educational psychologists called cognitive scaffolding, mental frameworks that support increasingly complex learning and application. Early exposures to integrated concepts create basic understanding that supports more sophisticated learning during subsequent encounters. For example, when participants first encounter business process analysis during Week 2, they develop basic understanding of how to identify workflow inefficiencies and improvement opportunities. When they revisit business process analysis during automation workflows in Week 6, they can focus on more sophisticated concepts like cost-benefit analysis and change management planning because they already understand fundamental process analysis techniques. This scaffolding approach enables learners to tackle increasingly complex integration challenges without becoming overwhelmed by trying to master all competency areas simultaneously. They build competence and competence gradually while maintaining consistent focus on integration across domains. Assessment integration across competencies. Integrated competency development requires assessment approaches that evaluate learners' ability to integrate. Effective assessment for integrated competency might present learners with comprehensive AI implementation scenarios that require strategic analysis, technical design, change management planning, and ethical evaluation. Success depends not on achieving perfect performance in any single area, but on demonstrating ability to balance and integrate considerations across all relevant domains. For example, a capstone assessment might require participants to develop AI implementation recommendations for a realistic organizational challenge, including business justification, technical architecture, user adoption strategy, and ethical compliance framework. This type of assessment reveals whether participants have developed the integrated competency needed for real-world AI implementation success. Creating professional communities of practice. Integrated competency development benefits significantly from learning community approaches that enable participants to share different perspectives and learn from each other's diverse experiences and backgrounds. When participants come from different functional areas, marketing, operations, finance, customer service, they bring different insights about business challenges and organizational dynamics that enrich everyone's learning. These diverse perspectives prove particularly valuable for developing integrated competency because participants learn to consider how AI implementations affect different organizational stakeholders and how solutions must be designed to work effectively across different functional contexts. A marketing professional learning AI applications can benefit from insights shared by colleagues from operations or customer service who identify different types of challenges and opportunities. The intensive program format enables participants to develop genuine collaborative relationships rather than superficial classroom interactions. By week 6, participants typically form project teams that continue working together on AI initiatives beyond the formal program completion. These ongoing relationships create internal networks of AI-fluent professionals who can support each other's continued development and implementation efforts. This community of practice approach ensures that integrated competency development continues beyond the formal training period, creating sustainable organizational capability for AI adoption and innovation. 2 point for human-centered AI adoption, change. Management as core curriculum. Reframing AI implementation as human enhancement. Imagine introducing a new musical instrument to an orchestra. The technical capabilities of the instrument might be impressive. Perhaps it can produce sounds that no existing instrument can create, or it can play certain passages more precisely than human musicians. However, the instrument only creates value when it enhances the overall musical performance rather than disrupting the harmony and collaboration that make orchestral music beautiful. Successfully integrating the new instrument requires understanding not only its technical capabilities but also how musicians will learn to play it, how it fits within existing musical arrangements, how other musicians will need to adapt their playing to complement the new sounds, and how audiences will respond to the enhanced musical possibilities. The focus isn't on replacing existing instruments but on creating richer, more compelling musical experiences. AI implementation in organizations follows similar patterns. The technical capabilities of AI systems might be impressive, but they only create value when they enhance human work and organizational performance rather than disrupting the collaboration and expertise that make organizations effective. Successfully integrating AI requires understanding not only technical capabilities but also how people will learn to work with AI, how existing workflows need to adapt, how different stakeholder groups will respond to AI-enhanced processes, and how AI can amplify rather than replace human capabilities. This human-centered perspective on AI adoption fundamentally changes how professionals approach implementation planning, solution design, and success measurement. Instead of focusing primarily on technical optimization or cost reduction, human-centered approaches prioritize creating AI implementations that feel empowering and natural to the people who will use them daily. The psychology of technology adoption. Research from the Technology Acceptance Model, TAM, reveals that people's willingness to adopt new technologies depends primarily on 2 factors: perceived usefulness, whether the technology helps them accomplish tasks more effectively, and perceived ease of use, whether the technology feels natural and intuitive rather than complicated and frustrating. These psychological factors often matter more than objective technical performance in determining adoption success. An AI system that achieves 98% accuracy but requires users to change their workflows dramatically may experience lower adoption than one that achieves 92% accuracy but integrates seamlessly with existing work patterns. Understanding technology adoption psychology enables AI-fluent professionals to design implementations that optimize for human acceptance rather than just technical performance. This involves considering how AI tools fit within existing mental models, how they enhance rather than complicate decision-making processes, and how they provide feedback that builds user confidence and competence. Addressing fear and resistance proactively. One of the most significant human factors in AI adoption is fear of job displacement, fear of making mistakes with unfamiliar technology, fear of losing professional autonomy, and fear of being judged inadequate if they struggle to learn new tools. Traditional technical training approaches often ignore or minimize these emotional factors, assuming that technical competence will overcome psychological resistance. However, research from organizational psychology demonstrates that emotional factors often override rational analysis in determining behavior change. People who intellectually understand the benefits of new technology may still resist adoption if they feel threatened or anxious about the changes it represents. Human-centered AI adoption addresses fear and resistance through what change researchers management called psychological safety, creating environments where people feel safe to experiment, make mistakes, ask questions, and express concerns without judgment. This involves acknowledging legitimate concerns about AI's impact on work and careers while providing clear information about how AI implementations are designed to enhance rather than threaten human capabilities. For example, when implementing an AI-powered document analysis system for legal professionals, human-centered approaches might address concerns about AI accuracy and professional judgment by explaining how the system highlights potential issues for human review rather than making final decisions automatically. This framing emphasizes human oversight and professional expertise while demonstrating how AI enhances analytical capabilities. Designing for human agency and control. Perhaps the most important principle in human-centered AI adoption is ensuring that AI systems enhance human agency rather than reducing people to passive recipients of algorithmic decisions. Research from human-computer interaction studies consistently shows that people prefer AI systems that provide recommendations and insights while leaving final decisions and creative work to humans. This preference for human agency isn't just psychological comfort, it often produces better practical outcomes because humans can consider context, nuance, and exceptional circumstances that AI systems may miss. Effective AI implementations combine algorithmic processing power with human judgment and creativity to achieve results that neither humans nor AI could accomplish alone. Consider the difference between an AI-powered hiring system that automatically screens resumes and selects candidates versus one that analyzes resumes and provides recommendations that human recruiters can evaluate, modify, and supplement with additional considerations. The second approach maintains human agency while leveraging AI's ability to process large volumes of information quickly and identify patterns that humans might miss. Human-centered design principles ensure that AI implementations feel empowering rather than threatening because they augment human capabilities rather than replacing human decision-making authority. Change management as strategic capability. Beyond training, cultural transformation. Traditional approaches to technology implementation often treat change management as a supplementary activity focused primarily on user training and communication. However, successful AI adoption requires more comprehensive cultural transformation that addresses how people think about work, collaboration, decision-making, and professional development within AI-enhanced environments. This helping cultural transformation involves people understand how AI changes the nature of valuable human work rather than just automating existing tasks. As AI systems become capable of handling routine analysis, data processing, and pattern recognition, human value creation shifts toward activities that require creativity, emotional intelligence, complex judgment, and interpersonal collaboration. Research from the Future of Work Institute suggests that organizations that help employees understand and develop these distinctly human capabilities experience more successful AI adoption because people understand how AI enhances rather than threatens their professional value. This requires change management approaches that go beyond tool training to include professional development planning and career pathway discussions. Stakeholder engagement and coalition building. Successful AI adoption requires building support among diverse stakeholder groups who may have different concerns, priorities, and perspectives about AI implementation. Technical teams might focus on performance optimization and system reliability. Business leaders might prioritize cost reduction and competitive advantage. End users might worry about workflow disruption and job security. Compliance teams might emphasize risk management and regulatory adherence. Human-centered change management involves creating engagement strategies that address each stakeholder group's specific concerns while building shared understanding of how AI implementations serve broader organizational objectives. This requires what political scientists call coalition building, developing alliances among different groups by identifying shared interests and mutual benefits. For example, implementing an AI-powered customer service system might address technical teams' interests in system reliability, business leaders' goals for improved response times, end users' desires for better tools to help customers effectively, and compliance teams' requirements for consistent service quality. Human-centered approaches help stakeholder groups understand how AI implementation serves their specific interests while contributing to collective organizational success. Continuous feedback and adaptation. One of the most important aspects of human-centered AI adoption is creating feedback mechanisms that enable continuous improvement based on user experience and changing organizational needs. AI systems that work well during initial implementation may need adjustments as users become more sophisticated, business requirements evolve, or new use cases emerge. Research from agile development methodologies demonstrates that systems designed for continuous improvement based on user feedback consistently outperform those designed as fixed solutions. This principle proves particularly important for AI implementations because AI capabilities and organizational needs both evolve rapidly. Human-centered approaches incorporate regular feedback collection, analysis, and system modification cycles that ensure AI implementations continue meeting user needs effectively. This might involve monthly user surveys, quarterly focus groups, and ongoing monitoring of usage patterns that reveal how people are actually using AI tools compared to how designers intended them to be used. Developing change leadership capabilities. From participants to change champions. One of the most distinctive features of human-centered AI adoption is developing program participants to become change leaders within their organizations rather than just competent AI tool users. This transformation from passive learners to active change facilitators multiplies the impact of AI fluency development programs by creating internal capacity for ongoing adoption support and organizational transformation. Change leadership development involves teaching participants to identify colleagues who might become early adopters, to design informal learning opportunities that help others develop AI skills, and to facilitate conversations that address concerns and resistance constructively. These skills enable participants to become catalysts for broader organizational AI adoption rather than isolated individuals with advanced AI capabilities. Research from diffusion of innovation theory reveals that successful technology adoption depends heavily on peer influence and social learning rather than formal training programs alone. When respected colleagues demonstrate successful AI adoption and share their experiences enthusiastically, their influence often proves more powerful than official communication from organizational leadership. Communication and influence skills. Effective change leadership requires sophisticated communication and influence capabilities that enable AI-fluent professionals to help colleagues understand AI benefits and overcome adoption barriers. This involves learning to listen carefully to concerns and questions, to provide clear explanations that address specific worries, and to design experiences that help skeptical colleagues develop confidence with AI tools. These communication skills go beyond technical explanation to include emotional intelligence and persuasion capabilities. Change leaders must be able to recognize when resistance stems from legitimate concerns about workflow disruption versus deeper fears about professional relevance, then respond appropriately to different types of concerns. For example, a colleague who expresses concern about AI accuracy might benefit from detailed explanation of how the system works and what safeguards exist. However, a colleague who worries about AI making their job obsolete might need different conversation focused on how AI enhances their capabilities and creates opportunities for more interesting, strategic work. Creating sustainable adoption cultures. The ultimate goal of human-centered AI adoption is creating organizational cultures where experimentation with new AI capabilities feels natural and exciting rather than threatening and disruptive. This involves building what researchers call learning cultures, environments where people are encouraged to try new approaches, share discoveries, and learn from both successes and failures. Learning include cultures for AI adoption, regular opportunities for people to share their experiences with AI tools, to collaborate on identifying new AI applications, and to receive support when they encounter challenges or confusion. These cultural elements ensure that AI adoption continues accelerating beyond the initial implementation period. Sustainable adoption cultures also include recognition and reward systems that celebrate successful AI experimentation and application. When people receive positive feedback for trying new AI approaches or helping colleagues learn AI skills, they're more likely to continue innovation and collaboration behaviors that accelerate organizational AI maturity. This cultural transformation approach ensures that AI fluency development creates lasting organizational change rather than temporary skill enhancement that fades over time due to lack of support and reinforcement. 2.5 Prototype to production thinking. Building for real-world implementation. Understanding the production reality gap. Consider the difference between preparing a meal in a cooking class versus running a busy restaurant kitchen. In cooking class, you have unlimited time, pre-prepared ingredients, clean equipment, and the luxury of focusing on just one dish. If something goes wrong, you can start over or adjust your approach without consequences. The goal is learning and experimentation in a controlled environment. Running a restaurant kitchen operates under completely different constraints. You must prepare multiple dishes simultaneously, work with varying ingredient quality, manage equipment that sometimes malfunctions, serve customers who have different preferences and dietary restrictions, maintain food safety standards, and deliver consistent quality under time pressure. There's no opportunity to start over if something goes wrong. You must adapt quickly and maintain service quality despite unexpected challenges. The difference between AI prototypes and production systems follows similar patterns. AI prototypes typically work with clean, well-formatted data in controlled environments with clearly defined success criteria and technically sophisticated users who understand system limitations. Production AI systems must handle messy, inconsistent real-world data, integrate with existing business systems that have their own constraints and quirks, serve users with varying technical backgrounds and diverse needs, maintain performance under varying load conditions, and continue operating reliably even when components fail or data quality deteriorates. Traditional AI training programs often focus primarily on prototype development because it's easier to teach and demonstrates AI capabilities effectively. However, organizations need professionals who understand the additional complexity of production systems and can design implementations that work reliably in real-world business environments rather than just controlled demonstration settings. The hidden complexity of production systems. Production AI systems must address numerous technical and operational requirements that rarely appear during prototype development but can determine implementation success or failure. Understanding these production requirements requires thinking beyond just algorithmic performance to consider the full system lifecycle and operational context. Data quality and consistency management represents one of the most significant production challenges that prototypes often avoid. Prototype development typically uses carefully curated datasets that have been cleaned, formatted, and validated. Production systems must handle data that comes from multiple sources with different formats, varying quality levels, missing values, and potential errors that occur during normal business operations. For example, a customer service AI system might work beautifully during prototype testing with a dataset of well-written customer inquiries. However, in production, the system must handle inquiries with spelling errors, incomplete information, unusual phrasing, and integration challenges when customer data comes from multiple systems that don't align perfectly. Production-ready systems include data validation, error handling, and quality monitoring capabilities that enable graceful performance even when input data doesn't meet ideal specifications. This requires understanding how to design systems that can identify and handle data quality issues automatically while alerting human operators when manual intervention is needed. Integration with existing business systems presents another layer of complexity that prototypes can ignore but production systems must address comprehensively. Organizations have existing customer management systems, financial reporting tools, compliance monitoring processes, and operational workflows that AI systems must support rather than disrupt. Consider implementing an AI-powered inventory management system. The prototype might focus on predicting optimal inventory levels based on historical sales data. However, the production system must integrate with existing point-of-sale systems, accounting software, supplier management tools, and warehouse management systems. It must handle different data formats, authentication requirements, and system availability patterns that affect how the AI system can access and utilize information. Scalability and performance under load becomes critical for production systems that must serve multiple users simultaneously and handle varying demand patterns that don't exist during prototype testing. A document analysis AI might work impressively when processing individual files during demonstrations, but struggle when dozens of users are uploading documents simultaneously during busy periods. Computing production-ready systems require architecture design that can scale resources based on demand, queue management that handles request volume gracefully, and monitoring systems that detect performance degradation before it affects user experience. This involves understanding cloud infrastructure capabilities, load balancing strategies, and cost optimization approaches that enable reliable service delivery within budget constraints. Reliability and maintenance requirements. Error handling and graceful degradation. Production AI systems must be designed to handle unexpected situations gracefully rather than failing completely when they encounter unfamiliar inputs or system problems. This involves implementing what software engineers call graceful degradation, maintaining useful functionality even when optimal performance isn't possible. For example, an AI-powered customer service chatbot should have fallback procedures when it encounters questions it can't answer confidently. Rather than providing potentially incorrect information or simply stating "I don't understand," the system might route difficult questions to human representatives while continuing to handle routine inquiries automatically. This approach maintains service quality while acknowledging system limitations. Graceful degradation also applies to technical system failures. If one component of an AI system experiences problems, the overall system should continue operating with reduced functionality rather than shutting down completely. This might involve using cached results, simplified processing approaches, or manual procedures that maintain business continuity while technical issues are resolved. Monitoring and observability. Production AI systems require comprehensive monitoring capabilities that track not only technical performance metrics like response time and error rates, but also business outcome metrics that reveal whether the system is creating intended value. This monitoring enables proactive problem detection and continuous improvement based on real-world performance data. Technical monitoring might track accuracy rates, processing speed, resource utilization, and error frequency to identify when systems need maintenance or updates. Business monitoring might track user satisfaction, task completion rates, cost savings, and other metrics that demonstrate whether AI implementation is achieving organizational objectives. Effective monitoring systems also include alerting mechanisms that notify relevant staff when performance degrades beyond acceptable thresholds. This enables rapid response to problems before they significantly affect business operations or user experience. Version control and update management. AI systems require ongoing updates to maintain accuracy, add new capabilities, and address changing business requirements. However, production systems can't be updated casually because changes might disrupt business operations or introduce new problems. This requires systematic approaches to version control, testing, and deployment that ensure updates improve rather than degrade system performance. Production update management includes testing procedures that validate new system versions against realistic data and use cases before deployment. Introduction of chapter. 3. This chapter focuses on the critical organizational preparation phase that determines whether AI fluency development programs succeed or fail. The chapter systematically addresses 6 essential areas for organizational readiness. 1. AI maturity and cultural assessment provides frameworks for understanding organizational readiness stages and cultural factors that affect program success. 2. Leadership alignment details how to secure genuine executive commitment through visible support, resource allocation, and strategic integration. 3. Resource allocation framework, comprehensive guidance for budgeting direct costs, opportunity costs, infrastructure needs, and ongoing support requirements. 4. Stakeholder engagement strategy, methods for building coalition support across diverse organizational groups with different priorities and concerns. 5. Risk assessment and mitigation, systematic approaches to identifying participant, organizational, technical, and financial risks before they become serious problems. 6. Success metrics definition, multidimensional measurement frameworks that capture immediate competency development and long-term organizational transformation. Each section provides practical assessment tools, planning templates, and implementation frameworks that organizations can adapt to their specific contexts. The content maintains the patient, encouraging tone while addressing the complex realities of organizational change management. This chapter successfully bridges the program architecture principles from Chapter 2 with the detailed participant selection and program implementation guidance that will follow, ensuring readers understand both what makes effective AI fluency development and how to create organizational conditions that enable success. The comprehensive readiness frameworks prevent the common mistake of launching excellent training programs in unprepared organizations, setting the foundation for sustainable value creation rather than just temporary skill enhancement. Chapter 3. Organizational readiness and implementation. Prerequisites. Learning objectives. By the end of this chapter, you will understand how to assess organizational readiness for AI team development initiatives, secure necessary leadership support, allocate resources effectively, engage stakeholders strategically, and establish measurement frameworks that demonstrate program value. You will also learn to identify and mitigate risks that could undermine program success before they become serious problems. Think of this chapter as the foundation inspection and site preparation phase of building construction. Just as successful building projects require understanding soil conditions, utility access, zoning requirements, and permit processes before breaking ground, successful AI fluency development requires understanding organizational culture, leadership commitment, resource availability, and stakeholder dynamics before launching intensive training programs. The frameworks and assessment tools in this chapter will help you avoid the common mistake of launching excellent training programs in organizations that aren't prepared to support participant success or leverage program outcomes effectively. 3.1 Assessing organizational AI maturity and cultural readiness. Understanding organizational AI maturity stages. Imagine trying to teach advanced surgical techniques to medical students who haven't yet mastered basic anatomy and patient care. While the surgical training might be excellent, students lack the foundational knowledge and experience needed to apply advanced techniques safely and effectively. Similarly, organizations at different AI maturity stages have varying capacities to benefit from AI fluency development programs, and successful implementation requires matching program intensity and focus to organizational readiness levels. Research from MIT Center for Collective Intelligence has identified 5 distinct stages of organizational AI maturity that affect how organizations can benefit from AI team development initiatives. Understanding these stages enables program design that meets organizations where they are rather than assuming uniform readiness across all potential participants. Stage 1: AI awareness, experimental phase. Organizations in the awareness stage recognize AI's potential importance but have limited experience with actual implementation. They may have conducted a few pilot projects or proof-of-concept studies, but haven't developed systematic approaches to AI adoption or governance. Leadership understands AI strategically but lacks detailed knowledge about implementation challenges and requirements. These organizations benefit most from AI fluency programs that emphasize opportunity identification, business case development, and foundational technical understanding. Participants need broad exposure to AI capabilities and applications rather than deep specialization in specific domains. The program focus should be building internal capacity for strategic AI thinking and basic implementation planning. Assessment indicators for Stage 1 organizations include limited current AI implementations, fewer than 3 active projects, ad hoc approach to AI vendor evaluation and selection, minimal internal AI expertise, and leadership discussions that focus on AI potential rather than specific implementation strategies. Stage 2, AI integration, operational phase. Organizations in the integration stage have implemented AI successfully in specific business functions but haven't achieved systematic integration across multiple departments or processes. They understand AI implementation challenges firsthand but may struggle to scale successful approaches or create consistent governance frameworks. These organizations benefit from AI fluency programs that emphasize cross-functional integration, change management, and production-ready implementation approaches. Participants need skills for scaling successful AI applications, managing complex stakeholder dynamics, and creating governance frameworks that enable innovation while managing risk. Assessment indicators include 4 to 10 active AI implementations, success with specific use cases but limited cross-functional. Integration, emerging but inconsistent AI governance practices, and leadership focus on scaling rather than just experimenting. Stage 3, AI optimization, systematic phase. Organizations in the optimization stage have integrated AI across multiple business processes and developed systematic approaches to AI governance and management. They understand how to implement AI effectively but may seek enhanced capabilities for innovation, differentiation, and advanced applications. Competitive. These organizations benefit from AI fluency programs that emphasize advanced applications, ethical leadership, and innovation management. Participants might focus on specialized competency development or leadership skills for managing large-scale AI transformation initiatives. Assessment indicators include 10+ active AI implementations, consistent governance frameworks across different applications, demonstrated ROI from AI investments, and leadership focus on competitive differentiation through AI capabilities. Stage for AI innovation, transformational phase. Organizations in the innovation stage use AI to enable new business models, create novel customer experiences, or transform their industry positioning. They have mature AI capabilities but seek cutting-edge applications and thought leadership opportunities. These organizations benefit from AI fluency programs that emphasize innovation leadership, industry transformation, and advanced ethical reasoning. Participants might focus on developing capabilities for leading industry-wide changes or creating breakthrough applications. Stage 5, AI ecosystem leadership, network effects phase. Organizations in the ecosystem leadership stage leverage AI to create network effects with partners, customers, and industry stakeholders. They influence industry standards and practices while driving innovation that affects entire business ecosystems. These organizations typically serve as partners in developing AI fluency programs rather than primary participants, contributing expertise and case studies while helping design advanced curriculum components. Cultural Readiness Assessment Framework. Learning orientation and growth mindset. Organizational culture significantly affects how well AI fluency development programs succeed because culture influences participant motivation, peer support, and leadership reinforcement of learning outcomes. Organizations with cultures that emphasize continuous learning, experimentation, and adaptation typically achieve better results from intensive development programs than those with more traditional or risk-averse cultures. Assessing learning orientation involves examining how the organization responds to new ideas, whether employees feel safe experimenting with new approaches, and how leadership reacts to both successful innovations and well-intentioned failures. Organizations with strong learning cultures encourage exploration, provide resources for skill development, and celebrate both successes and learning from mistakes. Cultural assessment indicators include employee participation rates in voluntary professional development programs, frequency of cross-functional collaboration projects, leadership communication about learning and innovation, and organizational responses to previous change initiatives. Consider how this manifests in practice. An organization where employees regularly suggest process improvements, where cross-departmental teams form naturally to solve problems, and where leadership frequently mentions learning and development in communications likely has cultural readiness for intensive AI fluency development. Conversely, organizations where employees wait for explicit direction, where departments work in isolation, and where leadership focuses primarily on execution rather than innovation may need cultural preparation before launching intensive development programs. Collaboration and cross-functional integration. AI implementation success depends heavily on collaboration across different organizational functions because AI projects typically require integration of technical, business, operational, and compliance considerations. Organizations with cultures that support cross-functional collaboration typically achieve better results from AI fluency programs because participants can apply their learning immediately through collaborative projects. Assessing collaboration readiness involves examining current cross-functional project success rates, communication patterns between different departments, and leadership support for initiatives that span multiple organizational areas. Organizations with strong collaboration cultures have established processes for cross-functional project management, regular communication between different departments, and leadership that models collaborative behavior. Practical assessment might involve reviewing recent cross-functional project outcomes, interviewing employees about their experience working with colleagues from other departments, and observing leadership team dynamics during meetings or decision-making processes. Organizations where cross-functional projects typically succeed, where employees speak positively about interdepartmental collaboration, and where leadership demonstrates collaborative problem-solving likely have good readiness for AI fluency development. Risk tolerance and innovation acceptance. AI implementation often involves experimentation with new approaches, acceptance of initial imperfection while systems improve, and willingness to adapt existing processes based on AI capabilities. Organizations with cultures that support measured risk-taking and innovation acceptance typically achieve better AI fluency outcomes because participants feel encouraged to experiment and apply new skills. Risk tolerance assessment involves understanding how the organization approaches new initiatives, whether employees feel empowered to try new approaches, and how leadership responds to initiatives that don't achieve immediate success. Organizations with appropriate risk tolerance distinguish between reckless experimentation and thoughtful innovation while providing support for learning from both successes and failures. Assessment indicators include the organization's track record with previous technology adoptions, employee willingness to suggest new approaches or improvements, leadership communication about innovation and experimentation, and organizational processes for evaluating and supporting new initiatives. Change management capability and history. Organizations with positive track records for managing technological change typically achieve better results from AI fluency development because they have established processes and cultural norms that support adaptation and skill development. Previous change management success indicates organizational capability for supporting the intensive learning and application required for AI fluency development. Change management assessment involves examining how successfully the organization has implemented previous technology changes, what processes and support systems exist for helping employees adapt to new tools and processes, and how leadership approaches change communication and reinforcement. Historical indicators include user adoption rates for previous technology implementations, employee satisfaction with change management support, time required to achieve full implementation of new systems, and organizational processes for training and supporting employees during transitions. Diagnostic tools and assessment methodologies. Organizational AI Readiness Survey. A comprehensive survey instrument can provide systematic assessment of organizational readiness across multiple dimensions relevant to AI fluency development success. The survey should assess current AI experience levels, cultural factors that affect learning and collaboration, leadership support for development initiatives, and resource availability for supporting intensive training programs. The survey might include questions about current AI tool usage, previous experience with technology training programs, perceived organizational support for learning and development, collaboration patterns across different departments, and individual interest in developing AI capabilities. Survey design should enable anonymous responses to encourage honest feedback while providing demographic information that enables analysis of readiness patterns across different organizational groups. Results should be analyzed to identify areas of strength and concern while providing specific recommendations for preparation activities that could improve readiness before program launch. Stakeholder interview protocol. In-depth interviews with key stakeholders can provide nuanced understanding of organizational dynamics, leadership commitment, and potential challenges that surveys might miss. Interview participants should include senior leadership, middle management, potential program participants, IT leadership, and representatives from departments that would be affected by AI implementations. Interview questions should explore leadership vision for AI adoption, current challenges with technology implementation, perceived barriers to AI adoption, support systems available for employee development, and expectations for AI fluency program outcomes. Interview analysis should identify common themes and concerns while revealing different perspectives that might need to be addressed during program design and implementation. Interviews often reveal cultural dynamics, resource constraints, or stakeholder concerns that affect program success but don't appear in survey responses. Current state documentation review. Systematic review of existing organizational documents can provide objective evidence of readiness factors while revealing formal and informal processes that affect AI fluency. Development success. Documents for review might include strategic plans, technology policies, training records, project management frameworks, and performance evaluation criteria. Document review should focus on identifying evidence of organizational commitment to learning and development, processes for supporting cross-functional collaboration, approaches to technology adoption and change management, and measurement systems that could support AI fluency program evaluation. This review often reveals gaps between stated organizational values and actual processes while providing insights about resource allocation priorities and decision-making patterns that affect program implementation success. Cultural observation and assessment. Direct observation of organizational meetings, collaboration patterns, and decision-making processes can provide insights about cultural readiness that surveys and interviews might miss. This might involve attending cross-functional meetings, observing how decisions are made and communicated, and noting patterns of collaboration and information sharing. Cultural observation should focus on identifying evidence of psychological safety that enables experimentation and learning, patterns of communication that support or hinder collaboration, leadership behaviors that model desired cultural attributes, and informal processes that affect how change and innovation are supported. This observational data provides context for understanding how cultural factors might affect program participant experience and success while identifying specific areas where cultural preparation might improve program outcomes. The combination of these assessment approaches provides comprehensive understanding of organizational readiness while identifying specific preparation activities that could improve the likelihood of AI fluency development success. Organizations that demonstrate strong readiness across multiple assessment dimensions can proceed with confidence, while those with identified concerns can address readiness gaps before launching intensive development programs. 3.2 Leadership Alignment Requirements for AI Team Development Success. Understanding the leadership success imperative. Consider the difference between learning to play tennis with enthusiastic support from family and friends versus learning despite skepticism and discouragement from people whose opinions matter to you. While the technical instruction might be identical, the psychological and motivational context dramatically affects learning success, practice commitment, and long-term skill development. Leadership support for AI fluency development creates similar psychological and practical contexts that significantly influence program success. When senior leadership demonstrates genuine commitment to AI team development through consistent communication, resource allocation, and behavioral modeling, participants feel encouraged to invest deeply in learning and application. Conversely, when leadership support appears superficial or inconsistent, participants often hedge their commitment, reducing program effectiveness and limiting organizational benefit. Research from Harvard Business School's Change Management Studies reveals that leadership alignment represents the single most important factor determining whether organizational development initiatives achieve their intended outcomes. This finding proves particularly relevant for AI fluency development because successful programs require sustained participant engagement, organizational support for experimentation and application, and commitment to leveraging program outcomes for strategic benefit. Visible leadership commitment and communication. Effective leadership alignment begins with visible, consistent communication about the strategic importance of AI fluency development and leadership's personal commitment to supporting participant success. This communication must go beyond generic endorsements to include specific explanations of how AI fluency contributes to organizational objectives and why investing in comprehensive development makes strategic sense. Leadership communication should address both the opportunities that AI fluency creates and the risks of failing to develop internal AI capabilities. Participants need to understand that their learning represents strategic investment rather than optional training, and that the organization expects to leverage their enhanced capabilities for competitive advantage. Consider the difference between a CEO who mentions AI training briefly during a quarterly meeting versus one who regularly discusses specific examples of how AI fluency enables better decision-making, describes competitive threats from organizations with superior AI capabilities, and shares progress updates on how participants are applying their learning to create business value. This visible commitment also requires leadership participation in program activities when appropriate. Senior leaders might attend program launch events, participate in capstone presentations, or engage with participants to understand their learning experiences and application opportunities. This participation demonstrates leadership's genuine interest while providing opportunities for bidirectional communication about program progress and organizational support needs. Resource allocation and investment decisions. Leadership commitment becomes concrete through resource allocation decisions that provide adequate funding, time, and infrastructure for program success. These resources must be sufficient not only for direct training costs but also for participant time away from regular responsibilities, technology access, project support, and ongoing application opportunities. Resource allocation includes enabling participants to dedicate sufficient time to learning activities without creating unsustainable stress or performance problems in their regular roles. This often requires temporarily redistributing work responsibilities, providing coverage during intensive learning periods, or adjusting performance expectations to accommodate learning time investment. Infrastructure resources include access to AI tools and platforms needed for hands-on learning, technology support for participants who need assistance with setup or troubleshooting, and collaboration tools that enable effective interaction during group learning activities. Perhaps most importantly, resource allocation includes providing opportunities and support for participants to apply their learning through real projects that create business value. Leadership must be willing to fund pilot implementations, provide access to relevant data and systems, and accept the measured risks associated with experimentation and learning. Strategic integration and business planning. Leadership alignment requires integrating AI fluency development outcomes into strategic business planning rather than treating training as an isolated human resources activity. This integration includes identifying specific business opportunities where enhanced AI capabilities could create competitive advantage and planning to leverage program graduates for strategic initiatives. Strategic integration involves connecting AI fluency development to broader organizational transformation goals, whether those focus on operational efficiency, customer experience enhancement, innovation acceleration, or market positioning improvement. Leadership should be able to articulate clearly how AI team development contributes to achieving specific strategic objectives. This strategic integration also requires planning for how program graduates will be utilized after completion. Organizations that achieve the best results from AI fluency development have specific plans for deploying enhanced capabilities, whether through dedicated AI implementation roles, cross-functional project leadership, or change management positions that accelerate broader AI adoption. Consider the difference between an organization that completes AI team development and then returns participants to their previous roles without additional responsibilities versus one that creates new opportunities for graduates to lead AI initiatives, mentor other employees, or drive strategic technology adoption projects. Building and maintaining leadership coalition. Executive sponsor identification and engagement. Successful AI fluency development requires identifying executive sponsors who have both positional authority and personal commitment to support program success actively. These sponsors serve as champions who can remove obstacles, provide resources, and maintain organizational focus on program objectives when other priorities compete for attention. Effective executive sponsors understand RA's strategic importance for their organization, have experience supporting successful change initiatives, and possess the communication skills needed to build support among other leaders and stakeholders. They should also have sufficient organizational influence to make resource allocation decisions and resolve conflicts that might impede program progress. Executive sponsor engagement includes regular communication with program leadership about progress and challenges, participation in key program milestones and events, and active advocacy for program outcomes and participant development opportunities. Sponsors should also be prepared to address resistance or skepticism from other leaders who might not initially understand program value. The sponsor identification process should consider both formal authority and informal influence patterns within the organization. Sometimes the most effective sponsors are not the highest-ranking leaders but those who have credibility across different organizational functions and proven track records for successful change leadership. Cross-functional leadership team development. AI implementation affects multiple organizational functions, requiring leadership alignment across different departments and areas of responsibility. Building effective cross-functional leadership teams ensures that AI fluency development receives support from all relevant organizational areas while creating shared accountability for program success. Cross-functional leadership teams might include representatives from technology, operations, human resources, finance, legal, compliance, and major business units that will be affected by AI implementations. Each representative should understand how AI fluency development benefits their functional area while committing to provide necessary support and resources. These leadership teams serve as communication bridges between program activities and different organizational functions, helping to identify opportunities for participants to apply their learning while addressing concerns or resistance that might emerge during implementation. They also provide diverse perspectives that improve program design and increase the likelihood of successful outcomes. Regular leadership team meetings should focus on progress updates, resource needs, application opportunities, and strategic planning for leveraging program outcomes. These meetings provide opportunities for collaborative problem-solving when challenges arise while maintaining shared commitment to program success. Managing leadership transitions and continuity. AI fluency development programs extend over significant time periods, creating risks from leadership changes that could affect commitment and support. Successful programs include planning for leadership transitions while creating institutional commitment that extends beyond individual leaders. Continuity planning includes documenting strategic rationale for AI fluency development, creating formal commitments that survive leadership changes, and building broad-based support that doesn't depend entirely on specific individuals. This might involve board-level endorsement, formal inclusion in strategic plans, or integration with performance evaluation criteria for multiple leaders. Transition management also includes onboarding processes for new leaders that help them understand program importance and their expected support role. This onboarding should provide context about program objectives, progress to date, expected outcomes, and specific ways the new leader can contribute to success. Consider how this works in practice when a new CTO joins during implementation. Effective transition management includes briefing the new CTO about AI fluency development strategic importance, introducing them to program participants and activities, and helping them understand how the program supports broader technology strategy objectives. Leadership development and capability building. AI literacy for senior leadership. Supporting AI fluency development effectively requires that senior leaders understand AI capabilities and limitations well enough to make informed decisions about resource allocation, strategic planning, and program evaluation. This doesn't require technical expertise, but it does require sufficient understanding. To evaluate proposals, ask appropriate questions, and communicate effectively about AI initiatives. Leadership AI literacy development might include executive briefings about current AI capabilities and applications, case studies of successful and unsuccessful AI implementations in similar organizations, and regular updates about emerging AI trends and opportunities. This education should focus on strategic and business implications rather than technical details. Leadership education should also address common misconceptions about AI capabilities, implementation timelines, and resource requirements that could lead to unrealistic expectations or inadequate support. Leaders need accurate understanding of what AI can and cannot accomplish within different timeframes and resource constraints. Regular leadership education ensures that support decisions are based on realistic understanding rather than unrealistic expectations that could undermine program success when initial results don't match inflated hopes. Change leadership skill development. AI fluency development represents a significant organizational change initiative that requires sophisticated change leadership capabilities from senior leaders. These capabilities include communication skills for building understanding and support, facilitation skills for managing resistance and conflict, and strategic thinking skills for connecting change initiatives to broader organizational objectives. Change leadership development for AI initiatives should address the unique challenges of technology adoption, including managing fear and resistance related to job displacement concerns, helping people understand how AI enhances rather than threatens human capabilities, and creating organizational cultures that support experimentation and learning. Leadership development might include training on change management frameworks, communication strategies for technology adoption, and facilitation skills for managing stakeholder discussions about AI implementation. This development should be practical and application-focused rather than theoretical. Performance management and accountability. Effective leadership alignment requires establishing clear expectations and accountability measures for supporting AI fluency development success. This includes setting specific goals for resource provision, participant support, and application opportunity creation while creating measurement systems that track leadership performance in these areas. Performance management systems should include criteria related to change leadership effectiveness, resource allocation appropriateness, and strategic integration of program outcomes. Leaders should understand that supporting AI fluency development successfully will be evaluated as part of their overall performance. Accountability measures might include participant feedback about leadership support quality, achievement of resource allocation commitments, successful creation of application opportunities for program graduates, and measurable progress towards strategic objectives that depend on enhanced AI capabilities. This accountability framework ensures that leadership commitment translates to consistent action rather than just symbolic support that fails to provide practical assistance when participants need it most. The combination of visible commitment, resource allocation, strategic integration, coalition building, continuity planning, and accountability creates comprehensive leadership alignment that significantly increases the likelihood of AI fluency development success while ensuring that program outcomes create lasting organizational benefit rather than temporary skill enhancement. 3.3 Resource Allocation Framework. Budget, time, and infrastructure. Considerations. Comprehensive cost analysis and budgeting. Implementing a successful AI fluency development program requires careful financial planning that accounts for both direct training costs and indirect organizational investments needed to support participant success and program effectiveness. Traditional training budget approaches often underestimate the full resource requirements because they focus primarily on instruction costs while neglecting infrastructure, opportunity costs, and ongoing support needs. Think of budgeting for AI fluency development like planning the total cost of home renovation. The contractor's fees represent only one component of total investment. You also need permits, materials, temporary living arrangements, utility upgrades, and contingency funds for unexpected challenges. Similarly, successful AI fluency development requires comprehensive resource planning that ensures adequate support for all aspects of program implementation and participant success. Direct training and development costs. Direct costs include instructor fees, curriculum development, assessment design, learning management systems, and program administration. These costs are typically the most visible and easiest to estimate because they involve specific services and products with established market pricing. Instructor costs should account for the specialized expertise required for AI fluency development, which commands premium rates compared to traditional training instruction. The integrated competency approach requires instructors who understand business strategy, technical implementation, change management, and ethical reasoning rather than just one specialized domain. Curriculum development represents a significant upfront investment because comprehensive AI fluency programs require custom content that integrates multiple competency areas while addressing specific organizational contexts and challenges. Generic AI training materials rarely provide the integration and practical application focus needed for effective fluency development. Assessment design requires developing evaluation methods that measure practical competency rather than just knowledge retention. This includes creating realistic scenario-based assessments, portfolio evaluation rubrics, peer assessment frameworks, and measurement systems that track business value creation rather than just completion rates. Technology platform costs include learning management systems, collaboration tools, AI software licensing for hands-on practice, and infrastructure needed to support intensive, interactive learning experiences. These costs often exceed traditional training technology requirements because AI fluency development requires access to actual AI tools rather than just instructional materials. Participant time investment and opportunity costs. Perhaps the largest cost component for AI fluency development involves participant time away from regular work responsibilities. The intensive 90-day format requires substantial time commitment that creates opportunity costs when talented employees focus on development rather than their normal productive activities. Calculating opportunity costs requires estimating the productive value of participant time and the potential cost of reduced productivity during intensive learning periods. For high-performing employees, this opportunity cost can exceed direct training costs significantly, making participant time the largest total investment component. However, opportunity cost calculation should also consider the productivity improvements and strategic value creation that result from enhanced AI capabilities. Research suggests that AI-fluent professionals typically create 3 to 4 times more value from AI implementations than traditionally trained employees, often justifying opportunity cost investments within 12 to 18 months. Time investment planning should include not only formal learning activities but also practice time, application projects, and peer collaboration that enable effective skill development. Participants typically need 10 to 15 hours per week for program activities, requiring careful workload management to prevent burnout while ensuring adequate learning engagement. Infrastructure and technology requirements. Supporting intensive AI fluency development requires technology infrastructure that enables hands-on practice with actual AI tools rather than just theoretical learning. This infrastructure includes software licensing, cloud computing resources, data access for practice projects, and technical support for participants who need assistance. AI software licensing costs can be substantial because comprehensive fluency development requires exposure to multiple AI platforms and tools rather than just single-vendor solutions. Participants need experience with language models, automation platforms, data analysis tools, and industry-specific AI applications that reflect real-world implementation diversity. Cloud computing resources support practice projects and collaborative learning activities that require more computing power than typical training applications. Participants working on realistic AI implementation projects need access to adequate processing capabilities, data storage, and integration tools that enable meaningful learning experiences. Data access represents both a cost and security consideration because effective learning requires practice with realistic datasets that reflect actual business challenges. Organizations must balance learning effectiveness with data protection requirements while providing participants adequate practice opportunities. Technical support includes help desk services for participants who encounter software difficulties, infrastructure management for maintaining reliable system access, and troubleshooting assistance that prevents technical problems from interfering with learning progress. Ongoing support and reinforcement costs. Effective AI fluency development includes ongoing support that extends beyond formal program completion to ensure sustainable application and continued learning. These costs are often overlooked during initial budgeting but prove essential for achieving long-term program value. Mentoring and coaching support helps participants navigate complex application challenges while building confidence with increasingly sophisticated AI implementations. This support might involve internal mentors, external consultants, or peer support networks that provide guidance and assistance. Project funding enables participants to apply their learning through actual business implementations rather than just theoretical exercises. Organizations that achieve the best results from AI fluency development provide funding for pilot projects that allow participants to demonstrate practical value creation while building experience with real-world challenges. Continuing education ensures that participants maintain current knowledge as AI technology evolves rapidly. This might include access to updated training materials, advanced workshops, conference attendance, or subscriptions to AI research and development resources. Community building activities maintain connections among program graduates while facilitating knowledge sharing and collaborative problem solving. These activities might include regular meetups, online discussion forums, collaborative projects, or annual conferences that sustain learning momentum. Time management and scheduling optimization. Balancing learning intensity with work responsibilities. The intensive nature of effective AI fluency development creates scheduling challenges that require careful balance between deep learning engagement and maintaining necessary work performance. Poor scheduling decisions can create unsustainable stress that reduces learning effectiveness while damaging participant performance in their regular roles. Research from adult learning suggests that intensive professional development works best when participants can dedicate 20 to 30% of their time to learning activities while maintaining core work responsibilities. This balance enables deep engagement without creating unsustainable stress or performance problems. Scheduling optimization might involve temporarily redistributing some work responsibilities among team members, adjusting project timelines to accommodate learning commitments, or modifying performance expectations during intensive learning periods. These adjustments require advanced planning and communication to prevent disruption. Some organizations implement cohort coverage systems where participants from different departments coordinate their intensive learning periods to provide mutual coverage for critical responsibilities. This approach enables sustained learning engagement while maintaining business continuity. Seasonal and business cycle considerations. AI fluency development programs should be scheduled to avoid conflicts with peak business periods, major project deadlines, or organizational changes that could interfere with participant focus and engagement. Poor timing can undermine program effectiveness even when content and instruction are excellent. Business cycle analysis should identify periods when participants can dedicate necessary time and attention to intensive learning without compromising critical business activities. This might involve avoiding busy seasons, product launch periods, or major deadline cycles that naturally occur within specific organizations. Seasonal considerations also include participant availability patterns, instructor scheduling, and organizational rhythm factors that affect learning effectiveness. Business cycle analysis should identify periods when participants can dedicate necessary time and attention to intensive learning without compromising critical business activities. This might involve avoiding busy seasons, product launch periods, or major deadline cycles that naturally occur within specific organizations. Seasonal considerations also include participant availability patterns, instructor scheduling, and organizational rhythm factors that affect learning effectiveness. Some organizations find that January-March timing works well for development programs, while others prefer post-summer scheduling that aligns with annual planning cycles. Phased implementation strategies. Large organizations might benefit from phased implementation approaches that develop AI fluency across multiple cohorts over time rather than attempting organization-wide development simultaneously. Phased approaches enable learning from early cohorts while spreading costs and resource requirements across multiple periods. Phased implementation also creates opportunities for peer mentoring where earlier graduates support subsequent cohorts while reinforcing their own learning through teaching and guidance activities. This approach builds internal capacity for ongoing AI fluency development while creating sustainable learning communities. Phase timing should consider organizational capacity for supporting multiple cohorts, availability of qualified instructors, and strategic priorities for deploying enhanced AI capabilities across different business functions or geographic locations. Technology infrastructure and platform requirements. Learning management and collaboration systems. Effective AI fluency development requires sophisticated technology platforms that support interactive learning, collaborative projects, real-time communication, and comprehensive assessment rather than just content delivery. These platforms must enable the intensive, integrated learning experience that produces effective competency development. Learning management systems should support portfolio development, peer assessment, collaborative project management, and real-time progress tracking rather than just course completion monitoring. Participants need tools for documenting their learning progression, sharing work with peers and instructors, and receiving feedback that enables continuous improvement. Collaboration platforms enable group projects, peer learning, and communication among participants from different locations or time zones. These tools become particularly important when participants come from different organizational functions and need to work together on cross-functional AI implementation scenarios. Communication systems should support both synchronous and asynchronous interaction, including video conferencing for intensive workshops, discussion forums for ongoing questions and collaboration, and messaging systems for quick coordination and support. AI tool access and licensing management. Comprehensive AI fluency development requires access to multiple AI platforms and tools that reflect the diversity of real-world implementation environments. This access enables hands-on learning with actual AI capabilities rather than just theoretical understanding of AI concepts. Licensing management includes coordinating access across multiple AI vendors, managing user accounts and permissions, and ensuring adequate capacity for simultaneous use by multiple participants. This coordination can be complex because different AI platforms have different pricing models, usage restrictions, and technical requirements. Enterprise licensing agreements often provide more cost-effective access than individual subscriptions while enabling better usage management and technical support. However, these agreements require advanced planning and may involve minimum commitment levels that affect budget planning. Tool selection should balance comprehensive exposure to different AI capabilities with practical limitations on licensing costs and technical complexity. The goal is providing sufficient breadth of experience to develop practical fluency without overwhelming participants with too many different platforms. Data access and security frameworks. Hands-on AI learning requires access to realistic datasets that enable meaningful practice with business-relevant challenges. However, data access must be balanced with security requirements that protect sensitive organizational and customer information. Data security frameworks should enable learning effectiveness while maintaining appropriate protection for confidential information. This might involve using anonymized datasets, synthetic data that reflects real patterns without exposing actual information, or carefully controlled access to actual data with appropriate security protocols. Sandbox environments enable safe experimentation with AI tools and techniques without risking damage to production systems or data. These environments should provide realistic functionality while isolating learning activities from critical business operations. Privacy protection includes ensuring that learning activities comply with relevant regulations like GDPR or HIPAA while providing adequate practice opportunities. This balance requires careful planning and often involves legal review of data access and usage protocols. Performance monitoring and technical support. Intensive AI fluency development places significant demands on technology infrastructure that require monitoring and support to prevent technical problems from interfering with learning effectiveness. Poor technical support can undermine excellent content and instruction by creating frustration and distraction. Performance monitoring should track system availability, response times, and user experience metrics that affect learning quality. This identification monitoring enables proactive problem and resolution before technical issues significantly impact participant experience. Technical support includes help desk services for participants who encounter software difficulties, system administration for maintaining reliable access to learning platforms and AI tools, and troubleshooting assistance that resolves problems quickly. Capacity planning ensures that technology infrastructure can handle peak usage periods when multiple participants are accessing systems simultaneously for intensive learning activities or collaborative projects. Inadequate capacity can create performance problems that undermine learning effectiveness. The comprehensive resource allocation framework ensures that AI fluency development programs have adequate support for achieving intended outcomes while providing clear understanding of total investment requirements that enable realistic budgeting and planning decisions. 3-point for stakeholder engagement strategy. Building internal support for AI fluency. Development. Stakeholder mapping and analysis. Successful AI fluency development requires building support among diverse groups within the organization who may have different concerns, priorities, and perspectives about AI implementation and professional development initiatives. Just as urban planners must consider the needs and concerns of residents, business owners, environmental groups, and government agencies when designing city development projects, AI fluency program leaders must understand and address the interests of various organizational stakeholders to build sustainable support. Think of stakeholder engagement as creating a coalition of allies who see AI fluency development as beneficial to their own interests rather than just supporting it as a favor to program leadership. When stakeholders understand how AI fluency development advances their own objectives, they provide more consistent and enthusiastic support throughout program implementation and application phases. Primary stakeholder identification and prioritization. Primary stakeholders include groups that are directly affected by AI fluency development outcomes or who have significant influence over program success. These typically include senior leadership who make resource allocation decisions, middle management who supervise program participants, potential participants themselves, IT departments who provide technical support, and business units where AI implementations will be deployed. Each primary stakeholder group has different priorities and concerns that shape their support for or resistance to AI fluency development. Senior leadership typically focuses on strategic value creation, competitive advantage, and return on investment. Middle management often worries about productivity impact during training periods and integration challenges afterward. IT departments may be concerned about additional support requirements and security implications. Understanding these different priorities enables targeted engagement strategies that address specific stakeholder concerns while demonstrating how AI fluency development benefits each group. For example, middle management might be most interested in learning how AI tools could make their teams more productive, while IT leadership might focus on integration requirements and support implications. Stakeholder prioritization should consider both influence levels and support importance for program success. High-influence stakeholders who are skeptical about AI fluency development pose greater risks than low-influence skeptics, while high-influence supporters can provide disproportionate benefit through their advocacy and resource provision. Secondary stakeholder consideration. Secondary stakeholders include groups that are affected by AI implementations but may not be directly involved in fluency. Development programs. These might include customers who interact with AI-enhanced services, suppliers who work with AI-improved processes, regulatory bodies who oversee AI compliance, and community groups concerned about AI's social impact. While secondary stakeholders may not directly influence program implementation, their concerns can affect long-term success if AI implementations create negative consequences that generate resistance or regulatory challenges. Understanding secondary stakeholder perspectives helps ensure that AI fluency development produces responsible implementations that serve broader interests. Secondary stakeholder engagement might involve communication about how AI fluency development includes ethical reasoning and responsible implementation practices, consultation about potential concerns or requirements, and ongoing dialogue about AI implementation impact and improvement opportunities. Stakeholder influence and interest assessment. Systematic assessment of stakeholder influence and interest levels enables strategic engagement planning that focuses resources on the most important relationships while addressing potential sources of resistance before they become serious problems. High influence, high interest stakeholders should receive intensive engagement including regular communication, consultation opportunities, and collaborative planning for program outcomes. These stakeholders often become program champions who can help build broader support and provide resources when challenges arise. High-influence, low-interest stakeholders require different engagement approaches focused on demonstrating relevance and building interest rather than just providing information. This might involve connecting AI fluency development to issues they care about or showing how enhanced AI capabilities could help solve problems they face. Low-influence, high-interest stakeholders can provide valuable input and feedback while serving as early adopters who demonstrate program value to other groups. These stakeholders often become effective advocates because of their enthusiasm and detailed understanding of program benefits. Low-influence, low-interest stakeholders typically require minimal engagement unless they represent potential sources of resistance that could create problems later. Monitoring these groups for emerging concerns while providing basic information about program objectives usually suffices. Communication strategy development. Message customization for different audiences. Effective stakeholder engagement requires developing messages that resonate with different audience priorities and concerns rather than using generic communication that fails to address specific stakeholder interests. The same AI fluency development program might be presented as a competitive advantage initiative to senior leadership, a team capability enhancement opportunity to middle management, and a career development benefit to potential participants. Message customization should address the "what's in it for me" question that each stakeholder group naturally asks when evaluating new initiatives. Senior executives want to understand how AI fluency development creates strategic value and competitive advantage. Department managers want to know how enhanced AI capabilities will improve their team performance and help them achieve their objectives. Technical stakeholders might be most interested in implementation approaches, integration requirements, and technical standards that affect their work. End users often focus on how AI changes will affect their daily workflows, job security, and professional development opportunities. Communication strategy should also address likely concerns and objections proactively rather than waiting for resistance to emerge. If middle management typically worries about productivity impact during training periods, communication should explain how program scheduling and workload management prevent performance problems while creating long-term capability benefits. Multi-channel communication planning. Different stakeholder groups prefer different communication channels and formats, requiring multi-channel approaches that reach each audience through their preferred information sources. Senior executives might prefer brief executive summaries and face-to-face briefings, while technical staff might want detailed documentation and online resources they can reference when needed. Communication channels might include executive presentations for senior leadership, department meetings for middle management, email updates for broad organizational communication, intranet sites for detailed information and resources, and informal conversations for building personal relationships and addressing specific concerns. Timing consideration should align communication with stakeholder decision-making cycles and information needs. Budget planning communication should align with annual planning processes, while implementation updates should coordinate with project management schedules and milestone achievements. Frequency planning balances keeping stakeholders informed with avoiding communication overload that creates resistance or indifference. Regular but not excessive communication maintains awareness and engagement while respecting stakeholder time and attention constraints. Feedback collection and response systems. Effective stakeholder engagement includes systematic feedback collection that enables program improvement while demonstrating responsiveness to stakeholder concerns and suggestions. This feedback should address both program design issues and implementation challenges that affect stakeholder experience and support. Feedback collection methods should match stakeholder preferences and communication styles. Some groups might prefer formal surveys, while others might be more likely to share feedback through informal conversations or small group discussions. Online feedback tools can enable anonymous input that reveals concerns people might not express publicly. Not all feedback can be accommodated, but stakeholders should understand why certain suggestions cannot be implemented and how their concerns are being addressed through alternative approaches. This responsiveness builds trust and continued engagement even when specific requests cannot be fulfilled. Fulfilled. Building coalition support. Identifying and developing program champions. Program champions are influential stakeholders who actively advocate for AI fluency development because they understand its strategic value and personal benefits. These champions provide credible support that influences other stakeholders while helping to build momentum and overcome resistance. Champion identification should consider both formal influence, position and authority, and informal influence, respect and credibility among peers. Sometimes the most effective champions are not the highest-ranking leaders but those who have credibility across different organizational functions and proven track records for successful change advocacy. Champion development involves providing these influential supporters with information and resources they need to advocate effectively, including talking points that address common concerns, data about program benefits and outcomes, and opportunities to share their support through appropriate organizational channels. Champions should also receive early access to program information and outcomes so they can speak knowledgeably about progress and benefits. This might include participation in program planning, regular briefings about participant progress, and opportunities to observe program activities firsthand. Coalition building across organizational functions. Building support coalitions that span different organizational functions creates broader legitimacy for AI fluency development while addressing concerns that might emerge from specific departmental perspectives. Cross-functional coalitions also provide diverse insights that improve program design and implementation. Coalition building involves identifying potential supporters from each major organizational function and creating opportunities for them to collaborate on program planning and advocacy. This might include cross-functional planning committees, regular coalition meetings, and collaborative communication efforts. Effective coalitions include members who can address different types of stakeholder concerns and questions. Technical members can address implementation feasibility questions, business members can speak to strategic value creation, and human resources members can address professional development and career impact issues. Coalition maintenance requires ongoing communication and engagement that keeps members informed and involved without creating excessive meeting burden. Regular but efficient communication about program progress, success stories, and emerging challenges helps maintain coalition commitment and effectiveness. Managing resistance and opposition. Even well-designed stakeholder engagement strategies encounter resistance from individuals or groups who have concerns about AI fluency development or prefer alternative approaches. Managing this resistance constructively prevents it from undermining program success while potentially converting opponents into supporters. Resistance often stems from legitimate concerns that deserve respectful attention rather than dismissal. Common concerns include fears about job displacement, anxiety about learning new technologies, skepticism about AI effectiveness, or worry about resource allocation away from other priorities. Addressing resistance effectively requires understanding underlying concerns rather than just surface objections. Someone who objects to AI fluency development costs might actually be worried about job security or concerned about organizational priorities. Addressing the underlying concern often proves more effective than just providing cost justifications. Resistance management strategies should include direct engagement with concerned parties, addressing specific concerns through program modifications when appropriate, and providing alternative involvement opportunities for those who cannot participate directly but still have valuable perspectives. Ongoing stakeholder engagement and relationship management. Regular communication and update cycles. Stakeholder engagement should include regular communication cycles that maintain awareness and support throughout program implementation rather than just during initial launch periods. This ongoing communication prevents stakeholder attention from wandering while providing opportunities to address emerging concerns or questions. Update frequency should balance information needs with communication overload concerns. Monthly updates might work well for highly engaged stakeholders, while quarterly communication might be appropriate for broader organizational audiences. The key is consistency and relevance rather than frequency alone. Communication content should focus on progress towards stated objectives, success stories and achievements, challenges being addressed, and opportunities for continued stakeholder involvement. This content demonstrates program value while maintaining engagement and support. Success story development and sharing. Sharing specific examples of program success creates compelling evidence of value that builds stakeholder confidence and enthusiasm. Success stories should focus on outcomes that matter to different stakeholder groups rather than just generic program completion metrics. Success stories for senior leadership might emphasize business value creation, competitive advantage development, or strategic objective achievement. Stories for middle management might focus on team productivity improvements or problem-solving successes. Stories for potential participants might highlight career development benefits or interesting project opportunities. Story development should include quantitative results when possible while also capturing qualitative benefits that demonstrate program impact on individual and organizational capability. The combination of numbers and narratives creates compelling evidence that resonates with different stakeholder preferences. Continuous improvement based on stakeholder feedback. Stakeholder engagement should include systematic feedback collection and program improvement processes that demonstrate responsiveness while enhancing program effectiveness based on user experience and organizational needs. Feedback systems should capture both positive experiences that can be replicated and concerns or suggestions that indicate improvement opportunities. This feedback helps program leaders understand what works well while identifying modifications that could enhance stakeholder satisfaction and support. Program improvement based on stakeholder feedback should be visible and acknowledged so stakeholders understand their input creates meaningful change. This responsiveness builds trust and continued engagement while improving actual program outcomes. Improvement communication should explain what changes are being made, why they address stakeholder concerns, and how these modifications enhance program value. This transparency demonstrates that stakeholder engagement represents genuine collaboration rather than just symbolic consultation. The comprehensive stakeholder engagement strategy ensures that AI fluency development builds sustainable organizational support while addressing diverse concerns and interests that affect program success and long-term value creation. 3.5 Risk assessment and mitigation. Planning for large-scale training. Initiatives. Identifying and categorizing program risks. Large-scale AI fluency development programs face multiple categories of risks that can undermine program effectiveness, participant satisfaction, or organizational benefit realization. Like construction projects that must consider weather delays, material shortages, permit challenges, and safety hazards, AI fluency programs must anticipate and prepare for various challenges that could disrupt learning processes or prevent successful outcomes. Think of risk assessment as insurance planning for your program investment. While you hope that serious problems won't occur, preparing for potential challenges enables rapid response that minimizes impact when difficulties do arise. Effective risk management often makes. Part 2. Participant selection and onboarding. Introduction of Chapter 4. This chapter transforms the theoretical understanding of attitude-based selection into practical, implementable frameworks for identifying candidates with the psychological and behavioral attributes that predict AI fluency development success. The chapter systematically addresses 6 essential selection areas. 1. Psychology of AI adoption success establishes the research foundation for why attitude-based selection outperforms credentials-based approaches, with specific psychological attributes that predict success. 2. Growth mindset assessment provides practical methods for identifying learning agility through unfamiliar technology challenges and behavioral observation. 3. Collaborative problem-solving evaluation details cross-functional teamwork assessment using realistic scenarios that mirror actual AI implementation challenges. 4. Business application curiosity frameworks for identifying strategic thinking orientation and practical problem-solving focus. 5. Ethical reasoning capability comprehensive approaches for evaluating responsible decision-making through complex scenario analysis. 6. Communication bridge building assessment, multi-audience communication testing that reveals translation and facilitation capabilities. Each section provides specific assessment exercises, observation protocols, and evaluation criteria that organizations can adapt to their contexts. The content maintains the patient, encouraging tone while addressing the complexity of identifying genuine potential rather than just impressive credentials or interview performance. This chapter successfully bridges the organizational readiness foundations from Chapter 3 with the detailed competency development guidance that will follow, ensuring readers understand how to select participants who will maximize both individual learning success and organizational transformation impact. The comprehensive selection frameworks prevent the common mistake of launching excellent training programs with participants who lack the psychological foundation for intensive learning and complex problem-solving success. Chapter 4: Attitude-Based Selection Framework. Learning Objectives. By the end of this chapter, you will understand how to identify individuals with the psychological and behavioral attributes that predict AI fluency development success, design assessment processes that reveal genuine attitudes rather than superficial responses, and implement selection frameworks that build diverse, effective learning cohorts. You will also learn to avoid common selection biases while creating fair, reliable evaluation processes that identify candidates with the greatest potential for becoming effective AI-fluent professionals. Think of this chapter as the talent scouting guide for building championship teams. Just as successful sports teams look beyond basic statistics to identify players with the right mental approach, collaborative spirit, and growth potential, effective AI fluency programs must identify candidates who possess the attitudes and mindsets that enable success in complex, evolving professional environments. The assessment tools and frameworks in this chapter will help you move beyond resume credentials to identify individuals who can develop into the AI-fluent professionals your organization needs to drive successful AI adoption and transformation. For point 1, the psychology of AI adoption success. Research-based selection criteria. Understanding the psychological foundation of AI implementation success. Imagine you're assembling a team to explore uncharted territory. Traditional selection approaches might focus on previous exploration experience, specific technical skills, or academic credentials related to geography and navigation. However, experienced expedition leaders often prioritize different qualities: curiosity about unknown environments, resilience when plans don't work as expected, ability to collaborate effectively under stress, and judgment about risks that balance safety with progress toward objectives. The psychology of AI adoption success follows similar patterns. While technical knowledge and business experience provide useful background, the psychological attributes that enable individuals to navigate uncertainty, collaborate across domains, and adapt to rapid change prove more predictive of success in AI implementation roles that require ongoing learning and complex problem-solving. Research from multiple disciplines, organizational psychology, innovation studies, technology adoption, and professional development converges on several psychological factors that consistently predict success in roles that require bridging technical and business domains while leading organizational change. Understanding these factors enables selection processes that identify individuals with the greatest potential for developing comprehensive AI fluency. The Innovation Adoption Psychology Framework research from Everett Rogers' Diffusion of Innovation Theory reveals that individuals respond differently to new technologies based on underlying psychological orientations that affect their willingness to experiment, adapt, and advocate for change. These psychological differences prove particularly important for AI adoption because AI technologies are still evolving rapidly, requiring professionals who can work effectively with imperfect tools while helping organizations navigate uncertainty. Early adopter characteristics include comfort with uncertainty and incomplete information, willingness to experiment with new approaches despite initial imperfection, an ability to see potential in emerging technologies before benefits become obvious to others. Early adopters in AI contexts don't necessarily need extensive technical backgrounds, but they should demonstrate curiosity about new tools and approaches, patience with initial learning challenges, and enthusiasm for exploring possibilities rather than just implementing established solutions. Assessment for early adopter characteristics might involve examining candidates' history with technology adoption, their response to learning opportunities in unfamiliar areas, and their approach to solving problems when standard solutions aren't available. Change agent orientation includes natural inclination to help others adapt to new approaches, ability to communicate benefits effectively to skeptical audiences, and persistence in working through implementation challenges that arise when organizations adopt new technologies. Change agents become particularly valuable in AI fluency development because they often become internal champions who help accelerate broader organizational adoption after completing their own development. They possess both the technical understanding needed to implement AI effectively and the interpersonal skills required to help colleagues overcome resistance and adoption barriers. Learning orientation and adaptation capability encompasses growth mindset thinking that views challenges as opportunities for development rather than threats to. Competence, systematic approach to acquiring new skills rather than random experimentation, and resilience when initial attempts don't succeed immediately. These psychological orientations prove essential for AI fluency development because the AI field evolves rapidly, requiring continuous learning throughout professionals' careers. Candidates who demonstrate strong learning orientation are more likely to maintain current knowledge and adapt their approaches as AI capabilities advance. Cognitive flexibility and systems thinking. Cognitive flexibility assessment. Cognitive flexibility represents the mental ability to switch between different conceptual frameworks, consider multiple perspectives simultaneously, and adapt thinking approaches based on changing circumstances. This capability proves essential for AI implementation because successful projects require integration across technical, business, human, and ethical considerations that often involve conflicting priorities and constraints. Traditional selection approaches often favor candidates who demonstrate deep expertise within specific domains, but AI fluency requires individuals who can think effectively across multiple domains while integrating diverse considerations into. Practical solutions. Cognitive flexibility enables this cross-domain integration while maintaining effectiveness when circumstances change unexpectedly. Perspective-taking ability involves understanding how different stakeholder groups view AI implementation challenges, recognizing that technical teams, business leaders, end users, and compliance specialists often have legitimate but different priorities that must be balanced rather than ignored. Candidates with strong perspective-taking ability naturally ask questions about how their decisions affect different groups, consider unintended consequences that might not be immediately obvious, and design solutions that address multiple stakeholder needs rather than optimizing for single objectives. Assessment might involve presenting candidates with scenarios where different stakeholder groups have conflicting priorities, then observing how they analyze the situation and develop approaches that acknowledge multiple perspectives rather than simply choosing sides. Conceptual bridge building includes ability to find connections between apparently unrelated ideas, translate concepts from one domain to another effectively, and create analogies that help others understand complex relationships. This capability enables the translation functions that prove essential for AI-fluent professionals who must help different organizational groups understand each other's perspectives and requirements. Strong conceptual bridge builders can explain technical AI capabilities in business terms while communicating business requirements in ways that technical teams can implement effectively. Adaptive problem-solving approaches encompass willingness to modify solution strategies when initial approaches prove inadequate, ability to learn from failed attempts rather than just repeating the same approaches, and comfort with iterative improvement rather than expecting perfect solutions immediately. AI implementation often requires adaptive problem-solving because real-world challenges rarely match textbook scenarios exactly. Successful AI-fluent professionals must be comfortable with iteration and refinement rather than expecting to design perfect solutions during initial planning phases. Emotional intelligence and interpersonal effectiveness. Social awareness and relationship management. AI implementation success depends heavily on interpersonal effectiveness because most AI projects require collaboration among people with different backgrounds, priorities, and comfort levels with technology change. Emotional intelligence capabilities that enable effective relationship building and conflict resolution often determine project success more than technical sophistication. Empathy and social sensitivity include ability to recognize and respond appropriately to others' emotional states, understanding of how technology changes affect people psychologically, and sensitivity to concerns about job security. Professional competence and workflow disruption that often accompany AI implementation. Candidates with strong empathy naturally consider how their actions affect others, recognize when colleagues feel threatened or confused by technology changes, and design implementation approaches that address emotional as well as functional requirements. Assessment for empathy might involve role-playing scenarios where candidates must address concerns from colleagues who are worried about AI implementation, observing how they respond to emotional content rather than just logical arguments. Influence and persuasion skills encompass ability to build support for new ideas without using positional authority, communication approaches that address resistance constructively rather than dismissively, and persistence in working through disagreements to find mutually acceptable solutions. These skills prove essential for AI adoption because successful implementation often requires convincing skeptical colleagues, overcoming resistance from groups that feel threatened by change, and building coalition support among stakeholders with different priorities. Conflict resolution and collaboration include comfort with addressing disagreements directly rather than avoiding difficult conversations, ability to facilitate productive discussions when people have conflicting viewpoints, and skill in finding common ground that enables progress despite initial disagreement. AI projects often involve conflicting priorities between efficiency and human experience, innovation and risk management, or speed and thoroughness. Candidates who can navigate these conflicts constructively are more likely to develop solutions that achieve broad organizational support. Resilience and stress management. Tolerance for ambiguity and uncertainty. AI implementation environments often involve significant uncertainty about outcomes, timelines, and optimal approaches. Candidates who become anxious or ineffective when facing ambiguous situations may struggle with the experimentation and adaptation required for successful AI adoption. Comfort with incomplete information includes ability to make reasonable decisions despite lacking complete information, willingness to proceed with implementation while continuing to gather additional data, and understanding that perfection is often the enemy of progress in rapidly evolving technology domains. This tolerance proves particularly important during AI implementation because organizations often must begin projects before fully understanding all requirements or optimal approaches. Waiting for complete information can result in missed opportunities or paralysis when action is needed. Experimentation mindset encompasses viewing failures as learning opportunities rather than personal inadequacies, willingness to try new approaches despite uncertainty about outcomes, and comfort with iteration and refinement rather than expecting immediate success. AI adoption requires systematic experimentation because many implementation decisions depend on organizational-specific factors that can't be determined theoretically. Candidates who view experimentation as natural and necessary are more likely to make progress despite uncertainty. Recovery and adaptation capability includes ability to bounce back from setbacks without losing motivation or confidence, learning from mistakes to improve future performance, and maintaining optimism despite temporary failures or challenges. AI implementation projects often encounter unexpected obstacles that require course correction and persistence. Candidates with strong resilience maintain effectiveness during difficult periods while learning from challenges rather than being discouraged by them. Intellectual humility and continuous learning. Recognition of knowledge limitations. Intellectual humility involves accurate assessment of one's own knowledge and capabilities, recognition that expertise in one area doesn't automatically transfer to other areas, and willingness to seek help and guidance when facing unfamiliar challenges. This humility proves essential for AI fluency development because the field evolves rapidly, requiring professionals who can acknowledge when they need to learn new approaches rather than assuming their existing knowledge is sufficient for all situations. Openness to feedback and correction includes receptiveness to input from others regardless of their positional authority, willingness to modify approaches based on new information or different perspectives, and ability to distinguish between personal criticism and constructive feedback about work approaches. AI implementation benefits from diverse perspectives and expertise, requiring professionals who can incorporate input from colleagues with different backgrounds rather than defending their initial approaches regardless of evidence. Curiosity and learning motivation encompass genuine interest in understanding how things work rather than just completing assigned tasks, initiative in seeking learning opportunities beyond minimum requirements, and sustained motivation for progression. Skill development throughout career. The rapid evolution of AI technology requires professionals who maintain current knowledge through continuous learning rather than relying on static expertise that becomes obsolete over time. Teaching and knowledge sharing orientation includes willingness to share knowledge and insights with colleagues, ability to explain complex concepts in ways that others can understand, and interest in helping others develop capabilities rather than hoarding expertise for personal advantage. AI adoption succeeds when knowledge spreads throughout organizations rather than remaining concentrated among small groups of experts. Candidates who naturally share knowledge accelerate organizational learning while building collaborative relationships that support implementation success. This psychological foundation provides the research-based rationale for attitude-based selection while establishing the specific psychological attributes that predict success in AI fluency development and application. The following sections translate these psychological insights into practical assessment methods and selection procedures. For Point 2 Growth Mindset Assessment, identifying learning agility and adaptability. Understanding growth mindset in AI implementation contexts. Carol Dweck's research on growth versus fixed mindsets reveals fundamental differences in how people approach challenges, respond to feedback, and persist through difficulties. These mindset differences prove particularly important for AI fluency development because the field changes rapidly, requiring professionals who view their capabilities as expandable rather than fixed. Imagine two professionals encountering an unfamiliar AI tool for the first time. The individual with a fixed mindset might think, "I'm not technical enough to understand this," or "I should wait until I receive formal training before trying to use this tool." The individual with a growth mindset might think, "This is an opportunity to learn something new," or "I can experiment with this tool and figure out how it works through practice." These different mindset orientations lead to dramatically different learning trajectories over time. Fixed mindset individuals often avoid challenges that might reveal knowledge gaps, while growth mindset individuals seek challenges as opportunities for development. In rapidly evolving fields like AI, growth mindset orientation becomes a significant predictor of long-term success and leadership effectiveness. Growth mindset indicators in professional contexts. Identifying growth mindset requires observing how candidates respond to challenges, feedback, and learning opportunities rather than just asking direct questions about their attitudes toward learning. People often understand that expressing enthusiasm for learning sounds desirable, but their actual behavior under pressure reveals their genuine mindset orientation. Challenge-seeking behavior includes voluntary pursuit of projects or assignments that require learning new skills, willingness to take on responsibilities outside their comfort zone, and interest in problems that don't have obvious solutions rather than just tasks they know they can complete successfully. Candidates with growth mindset naturally gravitate toward opportunities that stretch their capabilities because they view challenge as the mechanism for development rather than as threats to their competence or reputation. Assessment might involve asking candidates to describe projects they've chosen to work on that required learning new skills, how they approached unfamiliar challenges, and what they learned from experiences where they initially struggled or failed to achieve desired outcomes. Response to feedback and criticism reveals mindset orientation through how candidates process input about their performance, whether they become defensive when receiving suggestions for improvement, and how they use feedback to modify their approaches rather than just acknowledging it politely. Growth mindset individuals typically ask follow-up questions when receiving feedback, request specific suggestions for improvement, and demonstrate evidence of incorporating feedback into subsequent performance rather than just saying they will consider the input. Learning from failure and setbacks encompasses how candidates interpret unsuccessful attempts or disappointing outcomes, whether they focus on external factors beyond their control or identify aspects they could have approached differently, and their willingness to discuss mistakes openly rather than minimizing or avoiding mention of difficulties. Growth mindset individuals often describe failures as their most valuable learning experiences because they provided insights that success couldn't reveal. They focus on what they learned and how they improved rather than just what went wrong. Designing growth mindset assessment exercises. Unfamiliar technology challenge. One of the most effective methods for assessing growth mindset involves presenting candidates with technology tools they haven't used before and observing their approach to learning and experimentation. This assessment reveals natural learning strategies while providing insight into comfort with uncertainty and persistence through initial confusion. Exercise design framework. Present candidates with an AI tool or platform they haven't used previously. This might be a content generation tool, data analysis platform, or automation software that's relevant to AI implementation but not commonly known. Provide basic access information but minimal instruction, and then ask them to accomplish a specific task that requires figuring out how the tool works. The task should be challenging enough to require genuine learning but achievable within a reasonable time frame. For example, candidates might be asked to use a new AI writing tool to create content for a specific business scenario, or to use a data visualization platform to analyze a dataset and present insights. Observation focus areas. Growth mindset indicators include systematic experimentation with different features rather than random clicking, willingness to seek help or documentation when stuck, persistence through initial frustration or confusion, and focus on understanding underlying principles rather than just completing the immediate task. Observe whether candidates ask questions about how the tool works rather than just what buttons to click, whether they explore additional capabilities beyond minimum requirements, and how they respond when their initial attempts don't produce desired results. Feedback integration assessment. After candidates complete the initial challenge, provide specific feedback about their approach and suggestions for improvement, and then give them another opportunity to use the same tool with a different task. Growth mindset candidates typically integrate feedback actively rather than just acknowledging it. Look for evidence that candidates modified their approach based on feedback, asked clarifying questions about suggestions, and demonstrated improved performance rather than just repeating their initial strategy. Learning strategy discussion. Structured conversations about learning approaches can reveal growth mindset orientation through how candidates describe their methods for developing new capabilities and their attitudes toward skill development throughout their careers. Learning history exploration. Ask candidates to describe a time when they had to learn something completely new for their job, focusing on their process rather than just the outcome. Growth mindset individuals often describe systematic approaches to learning, seeking multiple sources of information, and practicing consistently rather than expecting immediate mastery. Listen for evidence of strategic learning approaches such as breaking complex skills into manageable components, seeking mentors or guides, practicing consistently rather than sporadically, and monitoring their own progress to identify areas needing additional work. Failure and recovery analysis. Request detailed descriptions of professional situations where candidates initially struggled or failed to achieve desired outcomes. Growth mindset candidates typically take responsibility for their role in unsuccessful outcomes while focusing on what they learned rather than external factors beyond their control. Pay attention to whether candidates can discuss mistakes openly without becoming defensive, whether they identify specific lessons learned that influence their subsequent approaches. and whether they express appreciation for difficult experiences that contributed to their development. Future learning orientation. Explore candidates' plans for continued professional development, their areas of interest for skill enhancement, and their strategies for staying current in rapidly changing professional environments. Growth mindset candidates often have specific plans for continued learning, express excitement about emerging developments in their field, and describe systematic approaches to maintaining current knowledge rather than just hoping to learn through experience. Learning agility behavioral assessment. Rapid adaptation scenarios. Learning agility involves the ability to learn quickly from experience and apply that learning effectively in new situations. This capability proves particularly important for AI implementation because professionals must adapt their approaches based on changing technology capabilities, organizational needs, and implementation experience. Scenario-based learning assessment. Present candidates with a series of related but progressively more complex challenges that require building on previous learning rather than starting fresh each time. This might involve multiple business analysis scenarios where each situation introduces new factors that require modifying previous approaches. For example, candidates might analyze AI opportunities for a retail organization, then repeat the analysis for a healthcare organization that has different regulatory requirements, then tackle a multinational organization that involves additional complexity from different regional considerations. Progressive complexity management. Observe how candidates build on their previous work rather than starting from scratch each time, whether they recognize patterns that transfer from earlier scenarios to later ones, and how they modify their analytical frameworks rather than rigidly applying the same approach regardless of changing circumstances. Learning agility indicators include explicit connection of new learning to previous experiences, systematic modification of approaches based on feedback and results, and ability to abstract principles from specific experiences that can apply to different contexts. Knowledge transfer assessment. After completing the progressive scenarios, ask candidates to explain what they learned that would apply to analyzing AI opportunities in organizations they haven't encountered yet. This reveals their ability to extract generalizable insights rather than just solving specific problems. Strong learning agility includes recognition of underlying patterns that transcend specific contexts, articulation of principles that guide approach selection for different situations, and awareness of their own learning process that enables continued improvement. Collaborative learning evaluation. Learning agility also involves ability to learn from others effectively, incorporating different perspectives and expertise into improved understanding rather than just defending initial viewpoints. Peer learning exercise. Organize group discussions where candidates must work together to analyze complex AI implementation scenarios that require integrating different perspectives and expertise. This reveals willingness to learn from colleagues while contributing effectively to collective understanding. Observe whether candidates ask questions that draw out others' insights, build on ideas from group members rather than just advocating for their own positions, and modify their understanding based on input from colleagues with different backgrounds or experience. Feedback integration in group settings. Learning agility includes ability to receive and integrate feedback gracefully in collaborative settings rather than becoming defensive or withdrawing when others suggest different approaches. Look for evidence that candidates can acknowledge when others have better ideas, ask questions that help them understand different perspectives, and contribute to group learning rather than just competing to demonstrate individual expertise. Teaching and explanation capability. Strong learning agility often correlates with ability to explain concepts clearly to others because understanding something well enough to teach it requires deeper comprehension than just personal application. Assess whether candidates can explain complex concepts in ways that others can understand, whether they adjust their explanations based on audience feedback, and whether they demonstrate patience and skill in helping others learn rather than just showing off their own knowledge. The comprehensive growth mindset assessment enables identification of candidates who will thrive in intensive learning environments while adapting effectively to the ongoing changes that characterize successful AI implementation careers. These psychological attributes provide stronger predictors of long-term success than traditional credentials or experience measures. For point 3. Evaluation. Teamwork potential. Collaborative. Testing. Understanding in collaborative AI implementation. Problem solving. Cross-functional. Requirements. AI implementation success depends heavily on effective collaboration across organizational functions because AI projects typically require integration of technical development, business strategy, user experience design, and ethical compliance considerations. Unlike traditional technology projects that might be managed primarily within IT departments, AI initiatives require ongoing coordination among diverse stakeholder groups with different expertise, priorities, and communication styles. Think of effective AI collaboration like conducting a symphony orchestra where musicians play different instruments, read different parts of the musical score, and contribute to creating harmonious music despite having distinct roles and expertise. The conductor doesn't need to play every instrument expertly, but must understand how different sections contribute to the overall performance while facilitating coordination that enables beautiful music rather than cacophonous noise. Similarly, AI-fluent professionals don't need deep expertise in every domain affected by AI implementation, but they must understand how different organizational functions contribute to AI success while facilitating collaboration that integrates diverse perspectives into effective solutions. This collaborative capability often determines whether AI projects succeed or fail regardless of technical sophistication or business strategy quality. Cross-functional integration challenges. AI projects present unique collaboration challenges because they affect multiple organizational domains simultaneously while requiring integration of considerations that are often treated separately in traditional business operations. Technical business translation requirements involve bridging the gap between technical AI capabilities and business value creation in ways that enable meaningful dialogue between technologists who think in terms of algorithms and data and business professionals who think in terms of customers and market outcomes. Effective collaboration requires individuals who can understand both technical constraints that affect AI implementation feasibility and business priorities that determine whether AI applications create organizational value. This translation capability goes beyond simple communication to include genuine understanding that enables productive problem-solving across domain boundaries. Stakeholder perspective integration encompasses understanding how AI implementations affect different organizational groups, from end users whose daily work changes to executives who must justify investments to regulatory compliance teams who ensure adherence to evolving requirements. Collaborative AI professionals recognize that these different stakeholder groups have legitimate but sometimes conflicting concerns that must be balanced rather than dismissed. They design solutions that address multiple stakeholder needs while facilitating discussions that build support rather than resistance. Iterative development and feedback integration requires collaboration approaches that accommodate the experimental nature of AI implementation, where initial solutions often need refinement based on user experience and changing requirements. This iterative approach demands collaborative styles that can handle uncertainty and modification gracefully rather than requiring complete specifications before beginning work. Team members must be comfortable with evolving requirements while maintaining productive working relationships despite changing plans and priorities. Designing collaborative assessment scenarios. Multi-perspective problem-solving exercises. Effective assessment of collaborative capabilities requires scenarios that mirror the complexity and stakeholder diversity of real AI implementation projects. These assessments should reveal how candidates work with others rather than just how they solve problems independently. Cross-functional simulation design. Individuals create assessment scenarios where candidates work in teams with representing different organizational functions, such as business strategy, technical implementation, user experience, and compliance, to analyze AI implementation recommendations, opportunities, and develop. The scenario should require genuine collaboration because no single individual has sufficient expertise to develop complete solutions independently. For example, candidates might work together to design an AI-powered customer service system that must address business objectives for cost reduction, technical requirements for system integration, user experience needs for natural interaction, and compliance requirements for data protection. Role assignment and rotation. Assign candidates to represent different stakeholder perspectives during the exercise, requiring them to understand and advocate for viewpoints that may not align with their natural preferences or background. This reveals ability to appreciate different perspectives while working constructively despite conflicting priorities. Rotate role assignments during multiple scenarios so candidates experience advocating for business objectives in one exercise and technical constraints in another. This rotation reveals adaptability while preventing candidates from simply playing to their existing strengths. Collaborative process observation. Focus assessment on how candidates contribute to collaborative problem-solving rather than just the quality of final solutions. Observe whether they ask questions that draw out others' expertise, build on ideas from team members, facilitate productive discussions when disagreements arise, and help teams reach decisions despite complexity and uncertainty. Look for evidence of active listening where candidates demonstrate understanding of others' perspectives before responding, constructive disagreement that addresses ideas rather than personal positions, and facilitation behaviors that help teams make progress rather than getting stuck in analysis or conflict. Conflict resolution and negotiation assessment. AI implementation often involves navigating conflicting priorities between efficiency and user experience, innovation and risk management, or speed and thoroughness. Assessing candidates' ability to handle these conflicts constructively reveals their potential for managing the tensions that naturally arise in complex implementation projects. Structured disagreement scenarios. Design exercises where team members receive different background information that leads to legitimate disagreements about optimal approaches. For example, business representatives might receive information emphasizing competitive pressure and urgency, while compliance representatives receive information about regulatory risks and audit requirements. These structured disagreements reveal how candidates handle situations where smart, well-intentioned people reach different conclusions based on reasonable analysis. Effective collaborators acknowledge the legitimacy of different perspectives while working toward solutions that address multiple concerns. Interest-based problem solving. Observe whether candidates focus on understanding underlying interests rather than just arguing for specific positions. Strong collaborators often ask questions like, "What are you trying to achieve?" or "What concerns you about this approach?" rather than just defending their preferred solutions. This interest-based approach enables creative problem-solving that addresses multiple stakeholder needs rather than simple compromise that satisfies nobody completely. Look for evidence of curiosity about others' motivations and creativity in developing approaches that serve multiple objectives. Process facilitation capability. Some candidates naturally emerge as process facilitators who help teams work through disagreements productively rather than getting stuck in conflict or avoiding difficult conversations. These facilitation skills prove valuable for AI implementation because projects often require navigating competing priorities and stakeholder concerns. Assess whether candidates can help teams identify common ground, facilitate productive discussions about controversial topics, and guide groups toward decisions despite uncertainty or disagreement. Strong facilitators often become natural leaders for cross-functional AI projects. Communication and influence assessment. Multi-audience communication testing. AI-fluent professionals must communicate effectively with diverse audiences who have different technical backgrounds, organizational priorities, and communication preferences. This multi-audience capability requires understanding what different groups care about most while adapting communication style and content appropriately. Audience adaptation exercises. Present candidates with AI implementation scenarios that they must explain to different stakeholder groups, such as senior executives focused on strategic value, technical teams concerned with implementation feasibility, end users worried about workflow changes, and compliance teams responsible for risk management. The same basic scenario should be adapted for each audience with different emphasis and detail levels. Executives might want strategic implications and competitive advantages, technical teams might need architecture details and integration requirements, end users might focus on workflow changes and training needs, and compliance teams might emphasize risk mitigation and audit requirements. Communication effectiveness evaluation. Assess whether candidates naturally adjust their language, examples, and emphasis based on audience needs rather than just delivering the same presentation to everyone. Strong communicators use analogies and examples that resonate with specific audiences while maintaining accuracy and consistency across different presentations. Observe whether candidates check for understanding during their presentations, adjust their approach based on audience questions or confusion, and maintain engagement rather than just delivering information regardless of audience response. Persuasion and influence skills. Effective AI implementation often requires building support among stakeholders who may be skeptical about AI benefits or concerned about implementation risks. Assess candidates' ability to address resistance constructively while building genuine understanding and support. Look for evidence of empathy where candidates acknowledge stakeholder concerns before presenting solutions, credibility where they demonstrate understanding of stakeholder priorities and constraints, and influence approaches that rely on reason and relationship building rather than authority or pressure. Knowledge sharing and teaching capability. AI adoption succeeds when knowledge spreads throughout organizations rather than remaining concentrated among small groups of experts. Candidates who can teach and share knowledge effectively often become catalysts for broader organizational AI adoption. Peer teaching assessment. Ask candidates to teach concepts they understand well to others who are unfamiliar with the subject matter. This might involve explaining AI concepts to colleagues from different backgrounds or helping others learn tools and techniques they've mastered. Strong teachers typically break complex concepts into manageable components, use examples and analogies that connect to learners' existing knowledge, check for understanding throughout their explanations, and adjust their approach based on learner feedback and questions. Patience and support orientation. Teaching effectiveness often depends on patience and genuine interest in helping others succeed rather than just demonstrating personal expertise. Assess whether candidates show frustration when others learn slowly or make mistakes, or whether they maintain supportive attitudes that encourage continued learning. Look for evidence of encouragement when learners struggle, celebration when learners achieve understanding, and willingness to repeat or rephrase explanations rather than assuming that saying something once should be sufficient. Collaborative learning facilitation. Some individuals excel at facilitating group learning experiences where multiple people share knowledge and learn from each other rather than just receiving instruction from a single expert. This facilitation capability proves valuable for AI adoption because it accelerates knowledge sharing across organizations. Assess whether candidates can facilitate discussions where multiple people contribute insights, help groups build on each other's ideas rather than just taking turns presenting, and create learning environments where people feel safe asking questions and admitting confusion. The collaborative assessment framework reveals candidates' potential for the cross-functional teamwork that determines AI implementation success while identifying individuals who can facilitate organizational learning and adoption beyond their own direct contributions. For business application curiosity. Assessing strategic thinking orientation. Understanding orientation, business-focused problem solving. The most successful AI-fluent professionals are often those who are naturally curious about business problems and organizational challenges rather than being primarily fascinated by AI technology itself. This business application curiosity drives them to understand how organizations actually work, where inefficiencies and bottlenecks create opportunities for improvement, and how technology can address real challenges rather than just demonstrating impressive capabilities. Consider the difference between someone who learns about AI because they find the technology intellectually interesting versus someone who learns about AI because they want to solve specific problems they've observed in their work environment. Both motivations can lead to technical competency, but the business-focused individual is more likely to identify applications that create genuine organizational value rather than just technically impressive demonstrations. Think of business application curiosity like the diagnostic skills of an experienced physician who naturally observes symptoms, asks probing questions about underlying causes, and considers how different treatment approaches might affect the patient's overall health and quality of life. This diagnostic orientation focuses on understanding and solving problems rather than just demonstrating medical knowledge or using sophisticated equipment. Similarly, business application curiosity involves natural observation of organizational inefficiencies, systematic thinking about root causes and improvement opportunities, and focus on creating practical value rather than just implementing advanced technology. This orientation toward practical problem-solving predicts success in AI implementation because it ensures that AI applications address real needs rather than just showcasing technical sophistication. Organizational systems awareness. Business application curiosity manifests through natural awareness of how organizational systems work, where problems occur, and how different functions affect each other. This systems thinking enables identification of high-value AI opportunities while avoiding implementations that might solve local problems while creating broader organizational difficulties. Process inefficiency recognition includes natural observation of workflow bottlenecks, repetitive tasks that consume excessive time, communication breakdowns that create errors or delays, and decision-making challenges that result from inadequate information or analysis capability. Candidates with strong business curiosity often describe specific examples of inefficiencies they've noticed in their current or previous work environments, not because they were assigned to analyze processes but because they naturally observe how work gets done and where improvement opportunities exist. Assessment might involve asking candidates to describe workflow challenges they've observed, problems that affect their team's productivity, or communication difficulties that create frustration or errors. Listen for detailed, specific examples rather than generic statements about organizational challenges. Cross-functional impact understanding encompasses recognition that changes in one organizational area often affect other areas, awareness of how different departments depend on each other, and consideration of how improvements in one process might create challenges or opportunities elsewhere. This systems perspective proves essential for AI implementation because AI changes often have ripple effects throughout organizations. Candidates who naturally think about cross-functional impacts are more likely to design implementations that enhance rather than disrupt organizational effectiveness. Customer and stakeholder perspective include natural consideration of how organizational processes affect customers, suppliers, partners, and other external stakeholders rather than just focusing on internal efficiency or convenience. Business-focused candidates often describe problems in terms of customer impact or stakeholder frustration rather than just internal process difficulties. This external perspective enables AI implementations that create value for customers and partners rather than just internal operational improvements. Strategic opportunity identification assessment. Business case development capability. Strong business application curiosity typically correlates with ability to think strategically about improvement opportunities, including analysis of costs and benefits, consideration of implementation feasibility, and understanding of how potential solutions align with organizational priorities and constraints. Value proposition articulation. Ask candidates to identify a specific improvement opportunity they've observed and develop a business case for addressing it. Strong business curiosity manifests through clear articulation of current costs or missed opportunities, realistic assessment of potential benefits, and consideration of implementation requirements and challenges. Listen for evidence of quantitative thinking where candidates estimate time savings, cost reductions, quality improvements, or revenue opportunities rather than just describing problems qualitatively. Also observe whether they consider both direct benefits and indirect effects that might result from proposed improvements. Resource and constraint awareness. Effective business thinking includes realistic understanding of organizational constraints like budget limitations, competing priorities, capacity restrictions, and change management challenges that affect implementation feasibility. Candidates with strong business orientation often demonstrate awareness that good ideas must compete with other priorities for resources and attention. They consider not just whether improvements would be beneficial but whether they're important enough to justify investment given other organizational needs. Competitive and market context understanding. Business application curiosity often extends to understanding how organizational challenges affect competitive positioning, market opportunities, and strategic differentiation rather than just internal efficiency. Strong candidates might describe how process improvements could enable better customer service, faster product development, more accurate pricing, or other capabilities that create competitive advantages rather than just internal cost savings. Innovation and improvement orientation. Business curiosity manifests through natural interest in finding better ways to accomplish objectives rather than just accepting current approaches as adequate or inevitable. Improvement initiative history. Ask candidates to describe times when they suggested or implemented improvements in their work environment, focusing on their motivation and approach rather than just outcomes. Business-curious individuals often have examples of improvements they initiated because they observed opportunities rather than being assigned to find solutions. Look for evidence of initiative where candidates took action to address problems they noticed rather than just complaining about difficulties or waiting for others to solve problems. Also assess whether they approached improvements systematically rather than just trying random changes. Learning from other organizations. Strong business curiosity often includes interest in how other organizations handle similar challenges, awareness of industry best practices, and willingness to adapt successful approaches from different contexts rather than assuming their organization's methods are optimal. Candidates might describe conferences, articles, site visits, or conversations that exposed them to different approaches and their interest in understanding whether those approaches could work in their environment. This external learning orientation indicates openness to innovation rather than just defending current practices. Future-oriented thinking. Business application curiosity includes consideration of how current trends and changes might affect future challenges and opportunities rather than just focusing on solving today's problems with today's approaches. Assess whether candidates consider how industry changes, technology evolution, regulatory developments, or market shifts might affect their organization's future needs and challenges. This forward-thinking orientation enables proactive improvement rather than just reactive problem-solving. Problem-solving methodology assessment. Analytical approach and root cause analysis. Business application curiosity typically involves systematic approaches to understanding problems rather than just jumping to solutions based on surface symptoms. Problem definition and scoping. Present candidates with business scenarios that contain multiple potential problems and observe whether they asked clarifying questions to understand the situation thoroughly before proposing solutions. Strong analytical thinking includes recognition that initial problem descriptions often don't capture the full situation. Look for evidence of systematic inquiry where candidates ask about background context, stakeholder perspectives, previous solution attempts, and constraints that affect potential approaches. This diagnostic questioning reveals depth of analytical thinking rather than superficial response to presented information. Data and evidence-seeking behavior. Assess whether candidates naturally seek quantitative and qualitative evidence to support their analysis rather than just relying on opinions or assumptions. Business-curious individuals often want to understand the magnitude and frequency of problems before investing effort in solutions. Observe whether candidates ask about metrics, trends, examples, and stakeholder feedback that could inform their understanding rather than just accepting problem descriptions at face value. This evidence-seeking behavior indicates systematic rather than intuitive approach to business analysis. Multiple solution generation and evaluation. Strong business thinking includes consideration of multiple approaches to addressing challenges rather than fixating on single solutions. This creative problem-solving orientation reveals flexibility and innovation potential. Present candidates with business challenges and observe whether they generate several potential approaches before selecting preferred solutions. Also assess whether they consider different types of solutions, technological, process-based, training-focused, organizational, rather than assuming that all problems require the same type of intervention. Implementation planning and risk assessment. Business application curiosity extends beyond problem identification to include realistic thinking about implementation challenges and success requirements. Stakeholder impact analysis. Ask candidates to consider how their proposed solutions would affect different organizational groups and what support or resistance they might encounter. Business-focused thinking includes recognition that good solutions must be acceptable to people who will implement and use them. Strong candidates naturally consider perspectives of managers who must approve changes, employees who must adapt their workflows, customers who might be affected by service modifications, and other stakeholders whose cooperation affects implementation success. Change management consideration. Assess whether candidates think about how to help people adapt to proposed changes rather than just assuming that good ideas will be adopted automatically. This change management awareness indicates understanding of organizational behavior and implementation realities. Look for evidence that candidates consider training needs, communication requirements, pilot testing opportunities, and gradual implementation approaches rather than expecting immediate full-scale adoption of new approaches. Success measurement and monitoring. Business curiosity includes interest in how to determine whether improvements are working as intended and how to modify approaches based on experience rather than just implementing changes and hoping for the best. Candidates with strong business orientation often suggest specific metrics for measuring improvement, timelines for evaluating results, and processes for gathering feedback that could inform adjustments. This measurement orientation indicates systematic approach to improvement rather than ad hoc experimentation. The business application curiosity assessment reveals candidates who will naturally identify valuable AI applications while designing implementations that create genuine organizational benefit rather than just demonstrating technical sophistication. This business-focused orientation proves essential for AI-fluent professionals who must bridge technology capabilities with practical value creation. For point 5, ethical reasoning capability. Evaluating responsible decision-making. Patterns. Understanding ethical reasoning in AI implementation contexts. Ethical reasoning for AI implementation involves much more than knowledge of ethical principles or compliance with regulations. It requires the ability to recognize potential unintended consequences, consider how decisions affect different stakeholder groups, balance competing interests fairly, and make thoughtful choices when facing complex situations without clear-cut right answers. Think of ethical reasoning like the judgment required of an emergency room physician who must make rapid decisions with incomplete information while considering patient welfare, family concerns, resource constraints, and institutional policies. The physician needs both medical knowledge and ethical judgment to navigate situations where textbook answers don't exist and multiple legitimate considerations must be balanced. Similarly, AI implementation often involves ethical dilemmas where efficiency gains might create unfair impacts on certain groups, where privacy protection might conflict with useful functionality, or where innovation objectives might tension with risk management requirements. AI-fluent professionals need ethical reasoning capabilities that enable thoughtful navigation of these complex situations rather than just following predetermined rules. The goal isn't identifying candidates who have perfect ethical knowledge or who always make identical decisions when facing ethical dilemmas. Instead, the assessment should reveal individuals who naturally consider broader implications of their actions, who can think through complex situations from multiple perspectives, and who demonstrate genuine concern for fair and responsible outcomes. Stakeholder impact awareness. Strong ethical reasoning begins with natural awareness that decisions affect multiple stakeholder groups who may have different interests, concerns, and vulnerabilities that deserve consideration during decision-making processes. Multi-perspective recognition includes understanding that different stakeholder groups may experience the same decision differently. Awareness that impacts that seem minor to decision makers might be significant to affected parties, and recognition that seemingly neutral decisions often have differential effects on different populations. For AI implementation, this might involve understanding that automated decision-making systems that improve efficiency for organizations might create anxiety or disadvantages for individuals who are subject to those decisions, or that AI tools that enhance productivity for skilled workers might threaten job security for others. Assessment might involve presenting scenarios where AI implementations create different impacts for different groups, then observing whether candidates naturally consider these varied effects rather than just focusing on overall benefits or organizational advantages. Vulnerability and power dynamics consideration encompasses awareness that some stakeholder groups have less power to protect their interests or voice their concerns, recognition that seemingly voluntary systems might feel coercive to people who depend on them, and understanding that fair treatment requires special consideration for vulnerable populations. Strong ethical reasoning includes recognition that employees might feel pressure to accept AI monitoring systems even if they make them uncomfortable, that customers might have little choice but to interact with AI systems even if they prefer human alternatives, or that job applicants might face AI screening systems regardless of their preferences. Long-term and indirect effect analysis involves consideration of how decisions might create consequences that extend beyond immediate impacts, recognition that systems designed with good intentions might be misused or have unintended effects, and understanding that ethical analysis must consider evolution and scaling of AI systems over time. This might include recognition that AI systems trained on current data might perpetuate historical biases, that systems designed for specific use cases might be expanded to other applications with different ethical implications, or that efficiency improvements might contribute to broader social changes that affect community well-being. Ethical dilemma analysis and response. Complex scenario navigation. Effective ethical reasoning assessment requires presenting candidates with realistic scenarios that involve competing values and interests rather than clear-cut choices between obviously right and wrong alternatives. Multi-value conflict resolution. Present candidates with AI implementation scenarios where legitimate values conflict, such as situations where improving efficiency might reduce job opportunities, where enhancing security might compromise privacy, or where reducing costs might affect service quality. Strong ethical reasoning involves acknowledgement that multiple values are legitimate rather than dismissing concerns that complicate preferred solutions. Candidates should demonstrate ability to understand why different stakeholder groups prioritize different values rather than just advocating for their preferred approach. Observe whether candidates can articulate the legitimate concerns on different sides of ethical dilemmas, whether they seek creative solutions that address multiple values rather than just choosing sides, and whether they demonstrate respect for stakeholder groups that have different priorities from their own. Bias recognition and mitigation thinking. AI systems often reflect and amplify biases present in training data, design decisions, and implementation choices. Ethical reasoning assessment should reveal candidates' awareness of bias sources and their approach to identifying and addressing potential unfairness. Present scenarios involving AI applications in hiring, lending, law enforcement, healthcare, or other domains where biased outcomes could cause significant harm. Assess whether candidates naturally consider how AI systems might treat different demographic groups differently and what approaches could reduce discriminatory outcomes. Look for evidence of systematic thinking about bias sources rather than just generic awareness that bias exists. Strong candidates might consider historical bias in training data, representation issues in development teams, testing approaches that could reveal discriminatory outcomes, and monitoring systems that could detect bias after deployment. Transparency and accountability framework development. Ethical AI implementation requires appropriate levels of transparency about how systems work and clear accountability for decisions and outcomes. Assessment should reveal candidates thinking about when and how to provide explanations and who should be responsible for AI system effects. Present scenarios where stakeholders want to understand how AI systems make decisions that affect them, such as loan applications, hiring decisions, or medical recommendations. Assess whether candidates consider stakeholder rights to understand decisions while also considering practical constraints on explanation and transparency. Strong ethical reasoning includes recognition that different stakeholders might need different types of explanations, that transparency requirements might vary based on the stakes and impact of decisions, and that accountability mechanisms must be practical rather than just theoretical. Values-based decision-making assessment. Personal values integration and professional ethics. Ethical reasoning assessment should reveal how candidates integrate their personal values with professional responsibilities rather than treating ethics as external compliance requirements that don't connect to their core beliefs and motivations. Values articulation and application. Ask candidates to describe values that guide their professional decision-making and provide examples of how those values influenced specific choices they've made in challenging situations. Strong ethical reasoning typically involves clear personal values that connect to professional behavior rather than just abstract principles. Listen for evidence of consistency between stated values and described actions, specificity about how values apply to practical situations rather than just generic statements about doing the right thing, and examples of times when living up to values required personal cost or effort rather than just being convenient. Integrity under pressure. Present hypothetical scenarios where candidates face pressure to make decisions that conflict with ethical considerations, such as rushing AI implementations without adequate testing, making claims about AI capabilities that exceed actual performance, or implementing systems that primarily benefit the organization while creating problems for users or customers. Strong ethical reasoning includes recognition of ethical issues even when others might not emphasize them, willingness to raise concerns about potential problems even when doing so might be unwelcome, and commitment to responsible practices even when shortcuts might be easier or more profitable. Professional responsibility and leadership. Ethical reasoning assessment should reveal candidates' understanding of their responsibilities to colleagues, organizations, and broader communities rather than just their personal interest in avoiding problems. Ask about situations where candidates had opportunities to help colleagues make better decisions, to improve organizational practices, or to contribute to professional or community well-being beyond their direct job requirements. Look for evidence of leadership in promoting ethical practices rather than just compliance with minimum requirements, initiative in addressing ethical concerns rather than waiting for others to take action, and commitment to professional development that includes ethical as well as technical learning. Continuous learning and adaptation. Ethical reasoning in rapidly evolving fields like AI requires ongoing learning and adaptation as new challenges emerge and understanding of consequences develops through experience. Ethical learning and development. Assess candidates' interest in learning about ethical issues related to their professional work, their sources of guidance when facing ethical dilemmas, and their approach to staying current with evolving understanding. Introduction of Chapter 5. This chapter transforms the theoretical understanding of attitude-based selection into practical, implementable assessment processes that organizations can use to reliably identify candidates with AI fluency potential. The chapter systematically addresses 6 essential implementation areas. 1. 2. Practical AI tool exploration exercises, detailed frameworks for designing hands-on assessment scenarios that reveal learning agility through unfamiliar technology challenges. Group problem-solving challenge design. Comprehensive guidance for creating realistic collaboration tests that mirror actual AI implementation challenges. 3. Business challenge identification workshops, methods for evaluating systems thinking through complex organizational scenario analysis. 4. 5. Ethical scenario discussion facilitation, frameworks for assessing values-based reasoning through realistic moral dilemmas. Interview framework and scoring methodology. Structured approaches for reliable evaluation that complement observational assessment. 6. Candidate communication and expectation setting, transparent communication strategies that begin building program success during selection. Each section provides specific assessment exercises, observation protocols, scoring rubrics, and facilitation guidelines that organizations can directly implement. The content maintains the encouraging tone while addressing the complexity of identifying genuine potential rather than just impressive credentials or interview performance. This chapter successfully bridges the attitude-based selection principles from Chapter 4 with the detailed competency development that will follow, ensuring readers understand both what psychological attributes to look for and exactly how to assess them fairly and consistently across diverse candidate pools. The comprehensive implementation frameworks prevent common selection mistakes while creating engaging assessment experiences that begin building candidate investment and community relationships even before formal training begins. Chapter 5. Selection Process. Implementation Guide. Learning Objectives. By the end of this chapter, you will know how to design and implement comprehensive selection processes that accurately identify candidates with AI fluency potential while ensuring fair, consistent, and reliable evaluation. You will master specific assessment exercises, scoring methodologies, and facilitation techniques that reveal genuine psychological attributes rather than superficial responses. Most importantly, you will understand how to create selection experiences that begin building candidate engagement and program success even before formal training begins. Think of this chapter as the detailed construction manual for building your talent identification system. Just as master craftspeople need both understanding of material properties and specific techniques for working with those materials, effective selection requires both understanding of psychological success factors and practical methods for observing and evaluating those factors reliably across diverse candidate pools. The frameworks and tools in this chapter will enable you to move from knowing what to look for to actually finding it consistently and fairly among potential program participants. 5.1 Practical AI Tool Exploration Exercises. Designing hands-on assessment scenarios. Creating experiences authentic learning under observation. Traditional assessment methods often fail to reveal how candidates actually behave when facing unfamiliar challenges because they rely on self-reporting, scripted scenarios, or artificial testing environments that don't mirror real-world complexity. Practical AI tool exploration provides a window into candidates' natural learning strategies, problem-solving approaches, and response to uncertainty that proves far more predictive of program success than conventional evaluation methods. Imagine watching someone learn to navigate a new city. You could ask them about their navigation skills, give them a map-reading test, or have them describe their approach to finding unfamiliar locations. However, the most revealing assessment would involve actually observing them navigate to a destination they've never visited, noting whether they plan their route systematically, ask for help when confused, adapt when their initial approach doesn't work, and maintain composure when facing unexpected challenges. Similarly, AI tool exploration exercises reveal how candidates naturally approach learning, experimentation, and problem-solving when facing technology they haven't encountered before. These behaviors predict success in AI fluency development much more reliably than previous experience with specific tools or stated enthusiasm for learning new technologies. Exercise design principles for authentic assessment. Effective AI tool exploration exercises must balance several design requirements to provide meaningful assessment while ensuring fair evaluation across candidates with different backgrounds and experience levels. Unfamiliarity and level playing field creation. Select AI tools that most candidates haven't used extensively, ensuring that assessment reveals learning capability rather than prior experience. This might involve newer AI platforms, specialized applications, or tools that require creative application rather than just following established procedures. The tool should be sophisticated enough to require genuine learning but accessible enough that motivated candidates can make meaningful progress within assessment timeframes. Avoid tools that require extensive technical setup or prior knowledge of specific domains that might advantage some candidates unfairly. Consider tools like advanced content creation platforms, specialized data analysis applications, or AI-powered design. Software that requires systematic exploration to understand capabilities while providing multiple pathways for achieving objectives. Realistic task design with multiple solution paths. Design tasks that mirror real business challenges rather than artificial exercises, enabling candidates to demonstrate practical thinking while revealing their natural approach to unfamiliar technology. Tasks should have clear objectives but multiple possible approaches, enabling assessment of creativity, strategic thinking, and adaptation rather than just ability to follow predetermined procedures. For example, candidates might be asked to use an AI content creation tool to develop marketing materials for a specific business scenario, allowing various approaches while requiring genuine engagement with the tool's capabilities. Appropriate challenge level and time constraints. Calibrate difficulty to require genuine effort and learning without creating unrealistic pressure that prevents meaningful assessment. Candidates should encounter enough challenge to reveal their persistence and problem-solving strategies without becoming so frustrated that they can't demonstrate their capabilities. Time constraints should enable thorough exploration while creating enough pressure to reveal how candidates prioritize their efforts and manage competing demands. Typically, 45 to 90 minutes provide sufficient time for meaningful engagement while requiring strategic choices about how to use time effectively. Comprehensive observation and assessment framework. Learning strategy and approach documentation. Systematic observation during AI tool exploration reveals patterns of behavior that predict success in intensive development programs and complex implementation projects. Initial approach and orientation strategies. Observe how candidates begin their exploration. Do they read available documentation before experimenting, jump directly into hands-on experimentation, or seek overview information to understand the tool's purpose and capabilities? Growth mindset candidates often demonstrate systematic approaches that balance reading and experimentation, asking questions about the tool's intended use while beginning practical exploration. They typically show curiosity about capabilities beyond immediate task requirements rather than just focusing on minimum completion criteria. Document whether candidates spend time understanding the tool's purpose and design philosophy or focus only on immediate functional needs. Broader orientation often indicates strategic thinking and learning orientation that transfers to complex AI implementation challenges. Experimentation patterns and hypothesis testing. Strong learners typically demonstrate systematic experimentation rather than random trial and error. They form hypotheses about how features might work, test their assumptions methodically, and modify their approach based on results rather than just repeating failed attempts. Observe whether candidates build on successful experiments to explore related features, whether they recognize patterns that help them understand the tool's logic, and whether they can explain their reasoning when they encounter problems or achieve successful outcomes. Document instances where candidates explicitly test their understanding by trying variations or alternative approaches, indicating metacognitive awareness of their own learning process. Help-seeking and resource utilization behavior. Effective learners demonstrate appropriate help-seeking behavior that balances independence with recognition of when external assistance would be valuable. They typically explore available resources systematically rather than either avoiding help entirely or immediately seeking assistance before attempting independent problem-solving. Note whether candidates use available documentation effectively, whether they ask specific questions when seeking help rather than general requests for guidance, and whether they apply help they receive to understand broader principles rather than just solving immediate problems. Strong candidates often demonstrate escalation strategies where they try independent problem-solving first, then consult available resources, then seek human assistance when other approaches prove insufficient. Persistence and adaptation under difficulty. How candidates respond to challenges and setbacks reveals resilience and adaptability that prove essential for AI implementation work where solutions often require iteration and refinement. Frustration management and problem reframing. Observe how candidates respond when their initial approaches don't work or when they encounter confusing or unexpected results. Strong candidates typically demonstrate emotional regulation that enables continued productive effort despite temporary setbacks. Look for evidence of problem reframing where candidates step back to reconsider their approach rather than just intensifying efforts with methods that aren't working. This might involve trying different features, seeking additional information, or breaking complex tasks into smaller components. Document instances where candidates explicitly acknowledge difficulty while maintaining constructive problem-solving orientation rather than becoming defensive or giving up when facing challenges. Creative problem-solving and alternative approach generation. When standard approaches don't work, effective learners typically generate alternative strategies rather than concluding that tasks are impossible or that they lack necessary capabilities. Note whether candidates try multiple approaches to achieve objectives, whether they adapt their goals when original plans prove unrealistic, and whether they find creative ways to use available features even when those features don't exactly match their initial expectations. Strong candidates often demonstrate resourcefulness in combining different tool features to achieve objectives, indicating systems thinking and integration capability that transfers to complex AI implementation challenges. Learning transfer and insight development. Assess whether candidates can articulate what they've learned that would apply to other situations rather than just completing assigned tasks without broader understanding. Listen for evidence that candidates understand underlying principles rather than just specific procedures, that they can explain why certain approaches work better than others, and that they recognize how their learning might apply to different contexts or challenges. Facilitation and assessment administration. Creating psychologically safe assessment environments. Effective assessment requires environments where candidates feel comfortable experimenting, making mistakes, and asking questions rather than trying to appear knowledgeable about unfamiliar material. Expectation setting and anxiety reduction. Begin assessment sessions with clear explanation that candidates are not expected to have prior experience with the specific tools and that the assessment focuses on learning approach rather than immediate expertise or task completion speed. Explain that making mistakes and encountering difficulties is expected and valuable for assessment purposes rather than indicating poor performance. Emphasize that asking questions and seeking help when appropriate demonstrates good judgment rather than inadequacy. Provide clear information about assessment duration, available resources, and general expectations while avoiding excessive detail that might create artificial constraints on natural problem-solving approaches. Observer presence and interaction guidelines. Assessors should be present enough to observe behavior clearly while avoiding interference with natural learning and problem-solving processes. This typically requires balancing attentive observation with unobtrusive presence. Develop consistent guidelines for when and how assessors interact with candidates during exercises. Generally, assessors should respond to direct questions but avoid offering unsolicited guidance unless candidates appear completely stuck or frustrated beyond productive levels. Document all assessor interactions to ensure consistency across candidates while noting how different candidates utilize available assistance and respond to guidance when provided. Multi-candidate assessment coordination. When assessing multiple candidates simultaneously, ensure that interaction between candidates doesn't create unfair advantages or disadvantages while potentially revealing collaborative learning capabilities. Design assessment spaces and procedures that enable natural peer interaction while preventing candidates from simply copying others' approaches without genuine understanding or effort. Consider whether collaborative elements enhance or detract from assessment objectives, recognizing that some AI implementation roles require individual initiative while others emphasize collaborative problem-solving. Scoring and evaluation methodologies. Behavioral indicator tracking systems. Develop systematic approaches for documenting and evaluating the behavioral evidence that predicts success in AI fluency. Development rather than relying on subjective impressions or overall performance ratings. Learning agility indicators and documentation. Create checklists or rubrics that capture specific behaviors indicating growth mindset and learning effectiveness rather than just task completion or tool mastery speed. Learning agility indicators might include systematic exploration of tool capabilities, hypothesis formation and testing, effective use of available resources, persistence through initial difficulties, and ability to explain learning and problem-solving strategies. Document frequency and quality of these behaviors rather than just their presence or absence, recognizing that strong candidates typically demonstrate consistent patterns across multiple challenges rather than isolated instances of effective learning. Collaboration and communication assessment. Individual tasks. Even individual assessment exercises can reveal collaborative potential through how candidates interact with assessors, use available resources, problem-solving process, and communicate about their. Note whether candidates explain their thinking clearly when asked, whether they seek appropriate levels of assistance, and whether they demonstrate consideration for others in shared assessment environments. Document evidence of teaching orientation where candidates help others or explain concepts they've figured out, indicating knowledge-sharing capability that proves valuable for organizational AI adoption. Integration and systems thinking evidence. Look for indicators that candidates understand how AI tools fit within broader business or technical contexts rather than just viewing them as isolated applications. Strong candidates often ask questions about how tools connect to business processes, how they integrate with other systems, or how they might be used for purposes beyond immediate task requirements. Document evidence of strategic thinking where candidates consider implementation challenges, user experience factors, or organizational change requirements that would affect real-world deployment of AI capabilities. Comparative analysis and calibration procedures. Ensure consistent evaluation across multiple assessors and assessment sessions through systematic calibration and comparison processes. Iterator reliability and consistency training. Train multiple assessors using the same evaluation criteria and behavioral indicators to ensure consistent assessment across different evaluators and assessment sessions. Conduct practice sessions where multiple assessors observe the same candidates and compare their evaluations, identifying areas where scoring criteria need clarification or where assessor training needs enhancement. Develop anchor examples of strong, moderate, and weak performance across different behavioral dimensions to support consistent evaluation and calibration across multiple assessment administrations. Candidate comparison and ranking methodologies. Create systematic approaches for comparing candidates who may have approached assessment exercises differently while demonstrating equivalent levels of learning agility and problem-solving capability. Develop scoring rubrics that focus on behavioral quality rather than just task completion, recognizing that effective learners might achieve different outcomes while demonstrating equivalent learning capabilities and potential. Consider multiple assessment exercises or different tool exploration challenges to provide broader evidence of learning agility rather than basing evaluations on single interactions that might not represent candidates' typical performance. The Practical AI Tool Exploration Framework provides authentic assessment of learning capabilities while creating engaging experiences that begin building candidate investment in program success. These exercises reveal genuine potential more reliably than traditional assessment methods while providing rich behavioral evidence that supports selection decisions. 5.2 Group Problem-Solving Challenge. Design, creating realistic collaboration. Tests. Understanding collaborative assessment requirements. Group problem-solving assessment presents unique challenges because it must reveal individual collaborative capabilities while observing natural team dynamics that emerge when people with different backgrounds and perspectives work together on complex challenges. Unlike individual assessment that focuses on personal capabilities, group assessment must capture both individual contributions and collective effectiveness while identifying candidates who enhance rather than detract from team performance. Think of designing collaborative assessment like creating a jazz ensemble audition where musicians must demonstrate both individual musical ability and capacity to improvise effectively with others they've never met before. The assessment must reveal technical competence, creative contribution, responsiveness to others' musical ideas, and ability to support collective performance rather than just showcasing personal talents. Similarly, AI implementation requires professionals who can contribute their expertise effectively while building on diverse perspectives, facilitating productive discussions when disagreements arise, and maintaining team momentum despite complexity and uncertainty. These collaborative capabilities often determine project success more than individual technical knowledge or business analysis skills. Designing authentic cross-functional scenarios. Effective collaborative assessment requires scenarios that mirror the stakeholder diversity and integration challenges of real AI implementation projects while providing sufficient complexity to reveal genuine collaborative capabilities rather than superficial teamwork behaviors. Multi-perspective stakeholder representation. Design assessment scenarios where team members receive different background information that represents various organizational perspectives typically involved AI implementation decisions. This might include business strategy priorities, technical implementation constraints, user experience requirements, regulatory compliance needs, and financial considerations. For example, participants might work together to evaluate AI opportunities for a healthcare organization where different team members receive information about clinical workflow requirements, patient privacy regulations, financial pressures for efficiency improvement, and technical constraints from existing system integration needs. These different perspectives should create legitimate reasons for discussion and negotiation rather than artificial conflicts, enabling assessment of how candidates navigate real tensions between competing priorities rather than just demonstrating generic teamwork skills. Complexity and integration requirements. Scenarios should require genuine collaboration because no single individual can develop complete solutions using only their assigned perspective and background information. The integration challenge should feel natural rather than artificially constructed. Design challenges that require combining insights from different stakeholder perspectives to identify viable solutions rather than just compromising between different positions. Strong collaborative assessment reveals candidates who can synthesize diverse inputs into integrated approaches rather than just managing disagreement diplomatically. Time pressure and resource constraints. Include realistic constraints that require teams to prioritize their efforts and make strategic choices about how to use limited time and information rather than having unlimited resources to explore every possible approach thoroughly. Time pressure reveals how candidates respond when teams must make decisions despite incomplete information or when they must balance thorough analysis with practical deadlines. These constraints mirror real AI implementation challenges where perfect information is rarely available and decisions must be made to maintain project momentum. Observation framework for collaborative behaviors. Individual contribution assessment within group context. Collaborative assessment must distinguish between individual capabilities and group dynamics while recognizing that strong individual contributors enhance team performance rather than just demonstrating personal competence. Active participation and engagement patterns. Observe how candidates engage with team discussions and problem-solving processes. Strong collaborators typically demonstrate consistent engagement without dominating conversations, contribute substantive ideas that build on others' input, and maintain focus on collective objectives rather than just advocating for their individual perspectives. Document whether candidates ask questions that draw out others' expertise, whether they build on ideas from team members rather than just waiting for their turn to speak, and whether they help maintain team momentum when discussions become stuck or unfocused. Note patterns of participation throughout entire assessment periods rather than just initial interactions, recognizing that some candidates may need time to understand team dynamics before contributing most effectively. Idea development and creative contribution. Assess how candidates contribute to collective problem-solving through idea generation, creative synthesis, and innovative approaches that emerge from team collaboration rather than individual brainstorming. Strong collaborative contributors often demonstrate ability to combine insights from different team members into novel approaches that wouldn't have emerged from individual analysis alone. They build bridges between different perspectives rather than just advocating for single viewpoints. Document instances where candidates help teams develop solutions that integrate multiple stakeholder concerns rather than just choosing between competing alternatives, indicating systems thinking and integration capability. Facilitation and process leadership. Some candidates naturally emerge as process facilitators who help teams work through challenges productively rather than just contributing content expertise. These facilitation skills prove valuable for AI implementation projects that require ongoing coordination among diverse stakeholder groups. Observe whether candidates help teams organize their approach to complex problems, whether they facilitate productive discussions when disagreements arise, and whether they help maintain focus on objectives when conversations drift toward tangential issues. Note instances where candidates help teams make decisions despite uncertainty or disagreement, indicating leadership potential for managing the ambiguity and complexity that characterizes AI implementation projects. Conflict navigation and resolution skills. Collaborative assessment must include scenarios where team members have legitimate disagreements that require navigation rather than avoidance, revealing how candidates handle the tensions that naturally arise in complex AI implementation projects. Constructive disagreement and perspective integration. Design scenarios where different stakeholder perspectives lead to genuine disagreements about priorities, approaches, or trade-offs rather than artificial conflicts created just for assessment purposes. Observe how candidates respond when others disagree with their ideas or challenge their assumptions. Strong collaborators typically demonstrate curiosity about different perspectives rather than becoming defensive, ask questions to understand underlying concerns rather than just arguing for their positions, and seek creative solutions that address multiple viewpoints. Document evidence of interest-based problem-solving where candidates explore underlying motivations and concerns rather than just negotiating between surface positions, indicating sophistication in managing complex stakeholder relationships. Emotional intelligence and interpersonal sensitivity. Assess how candidates recognize and respond to others' emotional states during challenging discussions, including frustration when teams encounter obstacles, anxiety when facing uncertainty, or excitement when developing innovative solutions. Strong collaborative candidates typically demonstrate empathy that helps them understand how others are experiencing team dynamics, social awareness that enables them to recognize when their behavior affects others positively or negatively, and emotional regulation that helps them maintain productive engagement despite temporary setbacks or disagreements. Note whether candidates adjust their communication style based on others' responses, whether they provide support and encouragement when team members struggle with concepts or challenges, and whether they help maintain positive team dynamics during difficult discussions. Consensus building and decision-making facilitation. Collaborative AI projects often require teams to reach decisions despite uncertainty, competing priorities, and diverse expertise that make complete agreement unlikely. Assess how candidates help teams move toward actionable decisions while maintaining stakeholder buy-in. Observe whether candidates can summarize complex discussions accurately, whether they help teams identify areas of agreement that can serve as foundation for decision-making, and whether they propose decision-making processes that accommodate different perspectives rather than just majority rule or expert authority. Document instances where candidates help teams develop implementation approaches that address multiple stakeholder concerns rather than just choosing winning and losing positions. Assessment design and administration protocols. Group composition and dynamics management. Thoughtful group composition can enhance assessment validity while ensuring fair evaluation opportunities for all candidates regardless of their natural communication styles or professional backgrounds. Diversity and balance considerations. Form assessment groups that include diversity in professional backgrounds, communication styles, and problem-solving approaches rather than grouping similar candidates together. This diversity creates more realistic collaborative challenges while providing richer assessment information. Include candidates with different levels of assertiveness, various professional backgrounds, and diverse demographic characteristics to mirror real organizational teams rather than artificial homogeneous groups that don't reflect actual AI implementation team composition. Balance group size to enable meaningful participation for all members while creating sufficient complexity to require genuine collaboration. Groups of 4 to 6 participants typically provide optimal balance between participation opportunity and collaborative challenge. Role assignment and rotation strategies. Assign stakeholder roles that require candidates to represent perspectives that may not align with their natural preferences or professional backgrounds, revealing adaptability and perspective-taking ability rather than just performance within familiar domains. Rotate role assignments across multiple assessment exercises so candidates experience representing different stakeholder viewpoints, preventing them from simply playing to their existing strengths while revealing broader collaborative capabilities. Provide sufficient background information to enable meaningful role representation while avoiding excessive complexity that prevents authentic engagement with collaborative challenges. Observer integration and interaction guidelines. Collaborative assessment requires careful balance between thorough observation and natural team dynamics that aren't distorted by excessive assessor presence or intervention. Unobtrusive observation methodologies. Position assessors to observe team interactions clearly while minimizing their psychological impact on natural group dynamics. This might involve one-way observation windows, video recording for later analysis, or observer presence that's acknowledged but not intrusive. Develop clear guidelines for when assessors may interact with assessment groups, typically limiting intervention to clarification of exercise requirements or technical support rather than content guidance that might affect collaborative problem-solving processes. Create observation protocols that capture both verbal and nonverbal communication, individual contributions, and group dynamics rather than just final presentations or solution quality. Documentation and recording procedures. Systematic documentation enables post-assessment analysis while ensuring consistent evaluation across different groups and assessment sessions. Develop forms or digital tools that enable real-time capture of specific behavioral indicators rather than just general impressions, focusing on observable actions rather than subjective interpretations of motivation or capability. Consider audio or video recording with appropriate consent and privacy protections to enable detailed post-assessment analysis and inter-rater reliability calibration. Evaluation methodology and scoring frameworks. Individual assessment within collaborative context. Collaborative assessment must distinguish individual contributions and capabilities from group performance while recognizing that effective collaboration enhances rather than diminishes individual effectiveness. Contribution quality and impact measurement. Assess the quality and impact of individual contributions to team problem-solving rather than just quantity of participation or final presentation performance. Strong contributors often enhance team effectiveness through strategic participation rather than maximum airtime. Evaluate whether candidates' contributions help teams develop better solutions, whether their input advances collective understanding rather than just restating personal viewpoints, and whether their participation enhances rather than detracts from other team members' effectiveness. Document specific instances where candidates demonstrate expertise application, creative problem-solving, strategic thinking, or facilitation skills that contribute to team success rather than just individual achievement. Collaborative skill development evidence. Look for evidence that candidates learn and adapt during collaborative exercises rather than just demonstrating static capabilities. Strong collaborators often improve their team effectiveness as they understand group dynamics and other members' expertise better. Note whether candidates modify their communication style based on team feedback, whether they build on learning from earlier parts of assessment exercises, and whether they demonstrate increasing challenges progress. Effectiveness as collaborative. Assess whether candidates can articulate what they learned about effective collaboration or what they would do differently in future team situations, indicating metacognitive awareness that supports continued collaborative development. Leadership potential and influence capability. Identify candidates who demonstrate natural leadership that emerges from contribution quality rather than just assertiveness or formal authority assumptions. Look for evidence of influence that stems from helpful analysis, effective facilitation, or creative problem-solving rather than just speaking frequently or advocating strongly for particular positions. Document instances where candidates help teams achieve objectives more effectively rather than just advancing their individual agendas or demonstrating personal expertise. Cross-group comparison and calibration. Ensure fair evaluation across different assessment groups while accounting for natural variation in group dynamics and collaborative chemistry. Performance baseline and anchor point development. Establish baseline expectations for collaborative performance while recognizing that individual effectiveness may vary based on group composition and dynamics beyond any single candidate's control. Develop anchor examples of strong, moderate, and weak collaborative performance across different types of assessment scenarios to support consistent evaluation despite natural variation in group experiences. Focus evaluation on individual behaviors and contributions rather than just group outcomes, recognizing that effective collaborators can demonstrate strong capabilities even when teams encounter challenges or fail to achieve optimal solutions. Multi-exercise assessment integration. Use multiple collaborative exercises or different types of team challenges to provide broader evidence of collaborative capability rather than basing evaluations on single group interactions that might not represent typical performance. Compare individual performance across different collaborative contexts when possible, recognizing that some candidates may demonstrate stronger collaborative skills in certain types of challenges or group compositions. Consider both consistent collaborative strengths and adaptive capability across different collaborative requirements rather than just peak performance or single impressive contributions. The comprehensive group problem-solving assessment framework reveals collaborative capabilities that prove essential for AI implementation success while providing authentic experiences that begin building the cross-functional teamwork skills that participants will need throughout their development and application journey. 5.3 Business Challenge Identification. Workshops, evaluating systems thinking. Capability. Understanding requirements systems thinking assessment. Systems thinking represent one of the most critical yet difficult to assess capabilities for AI implementation success. Unlike technical skills that can be demonstrated through specific tasks or collaborative abilities that emerge through team exercises, systems thinking require understanding complex relationships, recognizing patterns across different domains, and anticipating how changes in one area might affect other parts of organizational or technical ecosystems. Imagine assessing someone's ability to understand how ecosystems work. You couldn't just ask them to identify individual species or describe specific biological processes. Instead, you need to observe how they analyze relationships between different organisms, environmental factors, and human activities while predicting how changes might ripple through the entire system over time. Similarly, AI implementation requires professionals who can understand how technology changes affect business processes, human workflows, organizational culture, and strategic positioning simultaneously. They must recognize that optimizing one aspect of AI implementation might create problems or opportunities in other areas that aren't immediately obvious but become critical for long-term success. Business challenge identification workshops provide structured opportunities to observe how candidates naturally approach complex organizational analysis while revealing their ability to think systematically about improvement opportunities and implementation implications. Workshop design for authentic systems analysis. Effective systems thinking assessment requires presenting candidates with realistic organizational scenarios that contain multiple interconnected challenges and opportunities rather than isolated problems with clear-cut solutions. Multi-domain challenge integration. Design scenarios that involve business strategy, operational processes, technology infrastructure, human resources, customer experience, and competitive dynamics rather than focusing on single functional areas. This integration mirrors real organizational complexity while revealing candidates' natural approach to understanding interdependent systems. For example, present a retail organization scenario where declining customer satisfaction involves inventory management challenges, supply chain disruptions, staff training gaps, technology integration problems, and competitive pressure from online retailers. The complexity should require systematic analysis to understand root causes and identify effective intervention points. These multi-domain challenges should feel realistic rather than artificially constructed, representing the kind of complex situations that AI-fluent professionals encounter when identifying implementation actual organizations. Opportunities within. Temporal complexity and dynamic factors. Include scenarios where challenges have developed over time due to multiple factors rather than single events, requiring analysis of how different trends and decisions have created current situations while considering how proposed solutions might evolve and create new dynamics. Present information about how challenges have changed over time, what previous solution attempts have been tried, and what external factors might affect future developments. This temporal complexity reveals whether candidates can understand how systems evolve rather than just analyzing static snapshots. Consider including information about industry trends, regulatory changes, technology developments, or market shifts that affect organizational contexts rather than assuming stable environments that don't reflect real-world AI implementation challenges. Stakeholder ecosystem complexity. Design scenarios that involve multiple stakeholder groups with different priorities, constraints, and influence levels rather than simple organizational hierarchies or single perspective analysis requirements. Include customers, employees, suppliers, regulators, competitors, and community groups that might be affected by or influence potential solutions. This stakeholder complexity requires systematic thinking about how changes affect different groups while considering whose support or resistance might determine implementation success. Observation framework for systems thinking behaviors. Pattern recognition and root cause analysis. Systems thinking capability manifests through how candidates approach complex scenarios, what patterns they recognize, and how they analyze relationships between different factors rather than just identifying individual problems or solutions. Multi-level analysis and perspective integration. Observe whether candidates naturally examine challenges from multiple levels: individual, team, department, organization, industry, and societal, rather than focusing exclusively on single levels of analysis. Strong systems thinkers typically ask questions about underlying causes rather than just addressing surface symptoms. Consider how individual behaviors connect to organizational systems and external pressures, and recognize that effective solutions often require changes at multiple levels simultaneously. Document evidence of perspective integration where candidates consider how different stakeholder groups experience the same challenges differently, how their proposed solutions might affect various groups, and how multiple viewpoints contribute to comprehensive understanding rather than just complicating analysis. Interconnection mapping and relationship analysis. Assess how candidates identify and analyze relationships between different aspects of complex scenarios rather than treating various elements as independent factors that can be addressed separately. Look for evidence of causal thinking where candidates trace how changes in one area create effects in other areas, how feedback loops might amplify or dampen intended changes, and how different organizational systems depend on each other in ways that affect solution design. Note whether candidates can explain why simple solutions might not work for complex problems, how seemingly unrelated factors might actually be connected, and how. Optimizing one aspect of performance might create trade-offs or unintended consequences elsewhere. Leverage point identification and strategic intervention. Systems thinking include ability to identify where changes are most likely to create positive ripple effects throughout systems rather than just addressing problems wherever they're most visible or painful. Observe whether candidates can distinguish between symptoms and root causes, whether they identify intervention points that could address multiple challenges simultaneously, and whether they consider how to sequence changes to build momentum rather than creating overwhelming disruption. Document instances where candidates propose solutions that work with natural system dynamics rather than requiring constant management effort to maintain, indicating understanding of sustainable change strategies. Future-oriented and dynamic analysis. Systems thinking requires considering how current trends might develop over time and how proposed interventions might create new dynamics rather than just solving current problems without creating new challenges. Trend analysis and scenario development. Assess whether candidates consider how current challenges developed over time and how they might continue evolving. Without intervention rather than treating organizational challenges as static problems requiring one-time solutions. Look for evidence of scenario thinking where candidates consider multiple possible futures based on different assumptions about external changes, internal decisions, or intervention effectiveness rather than assuming single predictable outcomes. Note whether candidates can explain why timing matters for implementing solutions, how external trends might affect optimal intervention strategies, and how early indicators could signal whether approaches are working as intended. Unintended consequence anticipation. Strong systems thinking includes recognition that interventions in complex systems often create unexpected results, requiring planning for adaptation and course correction rather than assuming perfect implementation of initial plans. Observe whether candidates naturally consider what might go wrong with their proposed solutions, how they would detect problems early rather than waiting for major failures, and how they would adapt their approaches based on implementation experience. Document evidence of risk thinking that goes beyond simple obstacle identification to include consideration of how well-intentioned changes might create new problems or how success in one area might create challenges in other areas. Workshop facilitation and assessment methodology. Structured analysis process and facilitation. Business challenge identification workshops require careful facilitation that enables authentic systems thinking while providing sufficient structure to support systematic assessment across multiple candidates. Progressive complexity and scaffold discovery. Design workshop processes that begin with broad organizational overview, then guide participants through increasingly detailed analysis of specific challenges and opportunities while maintaining focus on interconnections and systemic relationships. Start with general questions about organizational context and stakeholder groups, then move toward specific process analysis, problem identification, and solution development while encouraging participants to make connections between different levels of analysis. Provide worksheets or templates that support systematic analysis without constraining creative thinking, enabling participants to document their thinking process while maintaining flexibility for different analytical approaches. Individual and collaborative analysis integration. Combine individual analysis time with collaborative discussion periods to assess both independent systems thinking capability and ability to build on diverse perspectives to enhance collective understanding. Begin with individual analysis periods where candidates develop their own understanding of scenarios before group discussions, enabling assessment of personal analytical capabilities separate from group dynamics and collaborative influence. Follow individual analysis with structured group discussions where candidates share their perspectives and build on each other's insights, revealing how they integrate diverse viewpoints while maintaining or modifying their own analytical frameworks. Facilitator questioning and probe strategies. Develop systematic questioning approaches that encourage deeper systems thinking without leading candidates toward predetermined conclusions or analytical frameworks. Use open-ended questions that invite explanation of thinking processes rather than just conclusions, such as "What led you to identify that as a key factor?" or "How do you think those two challenges might be related?" rather than questions that can be answered with simple yes/no responses. Probe for evidence and reasoning behind conclusions while avoiding questions that suggest preferred answers, enabling assessment of analytical rigor and depth rather than just ability to provide responses that sound sophisticated. Assessment criteria and evaluation framework. Systems thinking competency indicators. Develop systematic approaches for identifying and documenting evidence of systems thinking capability rather than relying on subjective impressions of analytical sophistication or solution creativity. Complexity recognition and management. Assess whether candidates demonstrate appropriate humility about complexity rather than offering oversimplified solutions to complex challenges, while also showing ability to work productively with ambiguity and uncertainty rather than becoming paralyzed by complexity. Look for evidence that candidates recognize when problems have multiple contributing factors, when solutions need to address several issues simultaneously, and when implementation requires coordination across multiple organizational areas or stakeholder groups. Document instances where candidates acknowledge uncertainty while still making progress on analysis and solution development, indicating ability to work effectively despite incomplete information rather than requiring perfect understanding before taking action. Strategic thinking and priority setting. Systems thinking include ability to identify which factors are most critical for achieving desired outcomes and how to sequence interventions to maximize effectiveness while minimizing disruption and resistance. Observe whether candidates can distinguish between urgent and important factors, whether they consider how different intervention options might support or conflict with each other, and whether they think strategically about resource allocation and timing rather than just generating comprehensive lists of possible actions. Note evidence of constraint recognition where candidates consider organizational capacity, competing priorities, and realistic implementation timelines rather than proposing solutions that sound good theoretically but exceed practical implementation capabilities. Learning and adaptation orientation. Strong systems thinking includes recognition that complex systems require ongoing learning and adaptation rather than perfect initial analysis and solution design. Assess whether candidates propose monitoring and feedback mechanisms that could reveal whether interventions are working as intended, whether they consider how to gather information that could improve their understanding of system dynamics, and whether they demonstrate willingness to modify approaches based on evidence rather than defending initial analysis regardless of results. Look for evidence of experimental orientation where candidates suggest pilot testing or phased implementation approaches that enable learning and adaptation rather than requiring full-scale commitment to untested solutions. Solution integration and holistic design. Systems thinking capability manifests through solution approaches that address multiple challenges simultaneously while considering implementation feasibility and stakeholder impact rather than just technical or functional optimization. Multi-stakeholder solution development. Evaluate whether candidates develop solutions that consider impacts on various stakeholder groups rather than just optimizing for single objectives or organizational perspectives. Assess whether proposed solutions address legitimate concerns of different stakeholder groups, whether they consider how to build support among groups whose cooperation affects implementation success, and whether they recognize how different groups might experience the same changes differently. Document evidence of win-win thinking where candidates seek solutions that create benefits for multiple stakeholder groups rather than zero-sum approaches that benefit some groups at the expense of others. Implementation realism and change management integration. Strong systems thinking includes realistic assessment of implementation challenges and change management requirements rather than assuming that good solutions will be adopted automatically once their benefits become apparent. Observe whether candidates consider organizational culture factors that might affect solution adoption, whether they think about training and support requirements that would enable successful implementation, and whether they propose change strategies that work with rather than against natural organizational dynamics. Note evidence of phased implementation thinking where candidates consider how to build momentum gradually rather than requiring immediate comprehensive change that might overwhelm organizational capacity or create excessive resistance. The Business Challenge Identification Workshop framework reveals systems thinking capabilities while providing authentic experiences that mirror the complex analytical challenges that AI-fluent professionals encounter when identifying high-value implementation opportunities within real organizational contexts. 5-point for ethical scenario discussion facilitation. Assessing values-based reasoning. Creating authentic assessment opportunities. Ethical reasoning. Ethical reasoning assessment for AI implementation requires scenarios that present genuine moral complexity rather than clear-cut choices between obviously right and wrong alternatives. Most real AI implementation decisions involve balancing legitimate but competing values, such as efficiency versus fairness, innovation versus risk management, or individual privacy versus collective benefit, that require thoughtful analysis rather than simple rule application. Think of ethical assessment like evaluating someone's judgment as a member of a hospital ethics committee. Committee members regularly face situations where dedicated healthcare professionals disagree about the right course of action despite sharing common values and commitment to patient welfare. Effective committee members contribute to these discussions through careful analysis of competing considerations, respectful engagement with different perspectives, and commitment to finding approaches that uphold fundamental values while addressing practical constraints. Similarly, AI implementation often involves ethical dilemmas where smart, well-intentioned people reach different conclusions based on reasonable analysis of complex situations. Effective AI-fluent professionals need ethical reasoning capabilities that enable thoughtful navigation of these complex situations while maintaining commitment to responsible outcomes even when perfect solutions aren't available. The goal isn't identifying candidates who have identical ethical perspectives or who always reach the same conclusions when facing ethical dilemmas. Instead, assessment should reveal individuals who approach ethical questions thoughtfully, can engage respectfully with different viewpoints, and demonstrate genuine commitment to responsible decision-making even when it complicates or constrains implementation choices. Scenario design for complex ethical analysis. Effective ethical reasoning assessment requires scenarios that mirror the complexity and competing values typical of real AI implementation decisions while avoiding artificially constructed dilemmas that don't reflect authentic professional challenges. Multi-stakeholder impact scenarios. Design scenarios where AI implementation decisions affect multiple stakeholder groups with legitimate but potentially conflicting interests rather than simple situations where everyone benefits or where harms and benefits are distributed equally. For example, present an AI-powered hiring system scenario where the technology improves efficiency and consistency for hiring managers while potentially disadvantaging job applicants from groups that are underrepresented in training data. The complexity should require balancing organizational benefits with potential individual and societal costs. Include stakeholder groups with different levels of power and voice in decision-making processes, such as employees who must use AI systems, customers who are subject to AI decisions, and community members who might be affected by organizational AI adoption but have little direct influence over implementation choices. Competing values and trade-off analysis. Create scenarios that involve tensions between multiple legitimate values that organizations typically embrace, such as efficiency and fairness, innovation and safety, or transparency and competitive advantage. Present situations where maximizing one important value necessarily limits achievement of other important values, requiring participants to think carefully about how to balance competing considerations rather than just optimizing for single objectives. Include time pressure and resource constraints that mirror real implementation decisions where perfect solutions aren't available and stakeholders must choose among imperfect alternatives rather than having unlimited time and resources to address all concerns comprehensively. Long-term and systemic impact considerations. Affect design scenarios that require considering how current decisions might future developments, how individual implementation choices might contribute to broader social trends, and how seemingly isolated decisions might set precedents for other organizations or applications. Include information about how AI systems might evolve over time, how their use might expand beyond initial applications, and how their success or failure might influence other organizations' adoption decisions rather than treating each implementation as completely independent. Consider scenarios where beneficial short-term outcomes might create problematic long-term consequences, or where current decisions contribute to broader social changes that affect community welfare and democratic values. Facilitation framework for ethical discussion. Creating psychologically safe discussion environments. Ethical reasoning assessment requires discussion environments where participants feel comfortable expressing genuine views, acknowledging uncertainty, and exploring complex questions rather than just providing responses they think assessors want to hear. Ground rules and expectation setting. Begin assessment sessions with clear explanation that ethical scenarios are designed to explore reasoning processes rather than test knowledge of correct answers, and that thoughtful engagement with complexity is valued more than reaching particular conclusions. Establish norms for respectful discussion where participants can disagree with each other's viewpoints while maintaining focus on understanding different perspectives rather than winning arguments or convincing others to change their positions. Explain that acknowledging uncertainty, asking clarifying questions, and exploring multiple perspectives demonstrates good ethical reasoning rather than indicating confusion or inadequate preparation. Facilitator neutrality and perspective balance. Develop facilitation approaches that encourage exploration of multiple ethical perspectives without advocating for particular positions or leading participants toward predetermined conclusions. Use questions that invite explanation and analysis rather than seeking agreement with specific ethical frameworks, such as "What factors are you considering as you think about this situation?" rather than "Don't you think privacy is more important than efficiency?" Present information about different stakeholder perspectives and values without indicating which viewpoints are more legitimate or important, enabling participants to develop their own analytical frameworks rather than just applying facilitator preferences. Encouraging depth and complexity recognition. Structure discussions to move beyond initial reactions toward deeper analysis of underlying values, stakeholder impacts, and implementation considerations rather than accepting superficial responses that don't engage with scenario complexity. Use follow-up questions that invite participants to consider additional factors, alternative perspectives, or unintended consequences rather than just accepting first responses as complete analysis. Encourage participants to build on each other's insights while developing more comprehensive understanding rather than just taking turns presenting individual viewpoints without integration or deeper exploration. Assessment criteria for ethical reasoning. Values clarity and consistency. Ethical reasoning assessment should reveal whether participants have clear personal values that guide their professional decision-making while also demonstrating ability to understand and work with others who have different but legitimate value systems. Personal values articulation and application. Assess whether participants can explain the values that guide their approach to ethical dilemmas rather than just providing responses that sound socially acceptable without connection to underlying principles or beliefs. Look for evidence of consistency between stated values and analytical approaches rather than opportunistic value selection that changes based on convenient conclusions for different scenarios. Note whether participants can explain how their values apply to unfamiliar situations rather than just reciting abstract principles without practical connection to decision-making challenges. Stakeholder perspective recognition and integration. Evaluate whether participants naturally consider how different stakeholder groups might experience the same situation differently based on their circumstances, priorities, and constraints rather than assuming uniform impact or universal perspectives. Observe whether participants demonstrate empathy for stakeholder groups that have different values or priorities from their own rather than dismissing concerns that complicate preferred solutions. Assess whether participants can identify legitimate interests of stakeholder groups that might conflict with each other rather than assuming that ethical analysis can satisfy everyone simultaneously without difficult trade-offs. Complexity tolerance and nuance recognition. Strong ethical reasoning includes recognition that many real-world situations involve competing legitimate values that require careful balancing rather than simple application of predetermined rules or principles. Look for evidence that participants can work productively with ethical complexity rather than becoming frustrated when scenarios don't have clear-cut right answers or when different analytical approaches lead to different conclusions. Note whether participants can distinguish between situations where ethical principles provide clear guidance and those where reasonable people might reach different conclusions based on legitimate value differences. Reasoning process quality and depth. Ethical reasoning assessment should focus on analytical process quality rather than just conclusion acceptance, recognizing that thoughtful analysis matters more than reaching particular decisions about complex scenarios. Systematic analysis and factor consideration. Assess whether participants approach ethical scenarios systematically by identifying relevant stakeholder groups, considering multiple types of impacts, and analyzing both intended and potential unintended consequences rather than just responding based on initial impressions. Observe whether participants ask clarifying questions about scenario details that might affect ethical analysis rather than making assumptions about unstated factors that could influence appropriate decision-making approaches. Note evidence of comprehensive thinking where participants consider short-term and long-term impacts, individual and collective effects, and precedent-setting implications rather than just immediate and obvious consequences. Evidence-based reasoning and source integration. Evaluate whether participants seek relevant information to support their ethical analysis rather than just relying on intuitive responses or personal preferences without factual foundation. Look for evidence that participants can distinguish between factual questions that can be researched and value questions that require judgment rather than conflating empirical and normative issues or assuming that ethical problems can be solved entirely through factual analysis. Assess whether participants can integrate information from multiple sources and perspectives while maintaining focus on ethical reasoning rather than just gathering information without analytical framework or decision-making purpose. Adaptive thinking and perspective integration. Strong ethical reasoning includes willingness to modify initial conclusions based on new information or different perspectives rather than defending original positions regardless of additional evidence or alternative viewpoints. Observe whether participants can acknowledge when others raise important considerations they hadn't initially considered, whether they can integrate new information into modified analysis rather than just dismissing inconvenient factors. Note evidence of intellectual humility where participants recognize limitations of their own perspective while maintaining commitment to thoughtful analysis rather than abandoning ethical reasoning when situations become complex. Discussion documentation and evaluation. Behavioral evidence collection and analysis. Systematic documentation enables post-discussion analysis while supporting fair evaluation across different scenarios and discussion groups that might develop in different directions based on group dynamics and emerging conversation themes. Individual contribution tracking and quality assessment. Document specific contributions each participant makes to ethical discussions rather than just overall impressions of. Discussion quality or group dynamics, enabling individual assessment within collaborative discussion contexts. Note whether participants contribute substantive analysis that advances group understanding, whether they ask questions that help others think more deeply about scenarios, and whether they provide information or perspectives that enhance collective ethical reasoning. Track participation patterns throughout discussions rather than just initial responses, recognizing that some participants may need time to process complex scenarios before contributing most effectively to group analysis. Reasoning pattern consistency analysis documentation and Look for evidence of consistent analytical approaches across different ethical scenarios rather than just isolated instances of sophisticated thinking that might not represent typical reason. Introduction of Chapter 6. This chapter transforms the period between participant selection and program launch into a strategic preparation phase that optimizes conditions for intensive learning success. The chapter systematically addresses 6 critical preparation areas. 1. Individual learning style assessment and customization planning, frameworks for understanding. Diverse cognitive preferences and adapting support while maintaining program coherence and collective learning benefits. 2. Baseline AI knowledge evaluation, comprehensive assessment of current capabilities, misconceptions, and experience levels to enable personalized learning pathways and targeted support. 3. Personal AI impact goal setting, strategic frameworks for connecting program learning to individual career objectives and organizational opportunities to sustain motivation through challenging periods. 4. Technology access and infrastructure setup, comprehensive planning for equitable access to AI tools and platforms, addressing device limitations, connectivity constraints, and security requirements. 5. Team formation strategy, strategic approaches for creating diverse learning cohorts that maximize cross-pollination while building effective collaborative relationships. 6. Program commitment framework, clear definition of expectations, responsibilities, and mutual accountability that creates psychological investment in transformative outcomes. Each section provides detailed assessment tools, implementation frameworks, and practical guidance that organizations can directly apply. The content maintains the encouraging tone while addressing the complexity of preparing diverse participants for intensive learning success. This chapter successfully bridges the selection process with the detailed competency development that will follow, ensuring that participants begin the intensive program with optimal conditions for both individual achievement and collective learning success. The comprehensive preparation frameworks prevent common causes of program failure by proactively creating supportive infrastructure and aligned expectations. Introduction of Chapter 6. This chapter transforms the period between participant selection and program launch into a strategic preparation phase that optimizes conditions for intensive learning success. The chapter systematically addresses 6 critical preparation areas. 1. Individual learning style assessment and customization planning, frameworks for understanding diverse cognitive preferences and adapting support while maintaining program coherence and collective learning benefits. 2. Baseline AI knowledge evaluation, comprehensive assessment of current capabilities, misconceptions, and experience levels to enable personalized learning pathways and targeted support. 3. Personal AI impact goal setting, strategic frameworks for connecting program learning to individual career objectives and organizational opportunities to sustain motivation through challenging periods. 4. Technology access and infrastructure setup, comprehensive planning for equitable access to AI tools and platforms, addressing device limitations, connectivity constraints, and security requirements. 5. Team formation strategy, strategic approaches for creating diverse learning cohorts that maximize cross-pollination while building effective collaborative relationships. 6. Program commitment framework, clear definition of expectations, responsibilities, and mutual accountability that creates psychological investment in transformative outcomes. Each section provides detailed assessment tools, Chapter 6 PRE Program. PRE Program. Preparation and Orientation. Learning objectives. By the end of this chapter, you will understand how to design comprehensive preparation processes that optimize participant readiness for intensive AI fluency development while building early engagement and community connections that support program success. You will master frameworks for assessing individual learning needs, establishing personalized development pathways, creating effective team compositions, and setting infrastructure up that the technological and psychological enables unnecessary obstacles. Focused learning without. Think of this chapter as the launch preparation phase for a complex expedition. Just as successful mountain climbing expeditions require careful equipment checks, team preparation, route planning, and acclimatization before attempting challenging peaks, intensive AI fluency development requires systematic preparation that ensures participants can focus on learning and growth rather than struggling with expectations. Preventable obstacles or misaligned. The frameworks and processes in this chapter transform the gap between selection and program launch into a productive preparation phase that increases the likelihood of individual and collective success while building the foundation for sustained learning and application beyond formal program completion. 6.1 Individual Learning Style Assessment and Customization Planning. Understanding learning development contexts diversity in intensive. Effective AI fluency development must accommodate the reality that intelligent, motivated adults learn differently based on their cognitive preferences, professional backgrounds, and previous experiences with technology and collaboration. While the program's integrated competency approach remains consistent for all participants, the pathways to developing those competencies can be adapted to optimize individual learning effectiveness without compromising program rigor or outcomes. Imagine a master chef teaching culinary arts to a diverse group of students who include experienced home cooks, restaurant line cooks, and complete beginners. While everyone needs to master the same fundamental techniques and principles, the chef adapts instruction methods to leverage each student's existing knowledge while addressing their specific learning needs and challenges. Some students learn best through demonstration and practice, others through detailed explanation. Underlying principles, and still others through of experimentation and creative exploration. Similarly, AI fluency development participants bring diverse professional experiences, learning preferences, and cognitive styles that affect how they most effectively develop strategic thinking, technical implementation, change management, and ethical reasoning capabilities. Understanding and accommodating these differences while maintaining program coherence requires sophisticated assessment and customization approaches that optimize individual learning without fragmenting collective experience. Comprehensive Learning Style Assessment Framework. Effective learning style assessment goes beyond simple categorizations like visual, auditory, or kinesthetic preferences to include cognitive processing styles, collaboration preferences, and motivation patterns that affect success in intensive, integrated learning environments. Cognitive processing information integration preferences and assess how participants naturally approach complex information processing and integration across multiple domains rather than just how they prefer to receive information initially. Some participants demonstrate sequential processing preferences where they understand complex topics by building systematic understanding step by step, while others show holistic processing patterns where they need overview understanding before focusing on detailed components. Sequential processors often benefit from clear learning progressions that build foundational understanding before tackling integration challenges, while holistic processors may need early exposure to overall frameworks before diving into specific competency development. Assessment might involve presenting participants with complex AI implementation scenarios and observing whether they naturally break challenges into components for systematic analysis or seek overall pattern recognition before detailed examination. Collaboration and social learning preferences. Evaluate how participants most effectively engage with collaborative learning and peer interaction rather than assuming uniform preferences for group work or individual study. Some participants thrive in interactive discussion environments where they develop understanding through dialogue and debate, while others prefer individual reflection time before engaging with collaborative activities. Extroverted processors often think out loud and develop ideas through conversation, while introverted processors may need quiet reflection time to develop thoughts before sharing with others effectively. Assessment should reveal whether participants prefer structured collaboration with clear roles and objectives or more open ended exploration that emerges organically from group interaction. Challenge response and feedback utilization. Understand how participants naturally respond to difficulty and utilize feedback for improvement rather than just their stated preferences for receiving guidance and support. Some participants demonstrate resilience orientation where they view challenges as energizing opportunities for growth, while others show security orientation where they prefer mastery confirmation before tackling new challenges. Challenge-seeking participants often benefit from early exposure to complex integration exercises that require experimentation and iteration, while security-focused participants may need more structured skill building before collaborative problem-solving challenges. Feedback preferences vary from participants who want immediate correction and guidance to those who prefer time to struggle productively before receiving assistance that might short-circuit their learning process. Personalized learning pathway development. Individual competency assessment and gap analysis. Create systematic approaches for understanding each participant's current capabilities across the 4 competency pillars while identifying specific development opportunities that enable customized support without lowering overall program standards. Strategic thinking and business analysis baseline. Assess participants' current capability for identifying business opportunities, analyzing organizational systems, and thinking strategically about technology implementation rather than just their enthusiasm for business applications. Some participants bring strong business analysis backgrounds but limited technology understanding, while others have technical expertise but need development in business strategy and stakeholder analysis. Document specific areas where participants demonstrate strength that can support peer learning while identifying development needs that require targeted support or additional resources. Use realistic business scenarios to assess current analytical capabilities rather than self-reporting that may not accurately reflect practical problem-solving effectiveness under pressure. Technical understanding and implementation readiness. Evaluate participants' current technical knowledge and comfort levels with AI tools and technology integration challenges while recognizing that technical backgrounds vary significantly among selected candidates. Some participants need foundational technology literacy development before tackling AI-specific applications, while others require exposure to business integration challenges that they haven't encountered in purely technical roles. Assess learning agility with unfamiliar technology rather than just current knowledge levels, recognizing that rapid learning capability matters more than existing expertise for intensive development success. Document specific areas where participants can contribute technical insights to peer learning while identifying support needs that enable full participation in hands-on learning activities. Change management and interpersonal skills assessment. Understand participants' current capabilities for facilitating organizational change, managing stakeholder relationships, and building support for technology adoption initiatives. Some participants bring extensive change management experience from other contexts but need adaptation to AI-specific challenges, while others understand AI technology but lack experience with organizational change dynamics. Assess natural interpersonal effectiveness and influence capabilities rather than just formal training in change management principles that may not transfer to practical application. Evaluate comfort levels with addressing resistance and managing conflict that naturally arise during technology adoption initiatives. Customization strategy development without program fragmentation. Design approaches that accommodate individual learning needs while maintaining program coherence and collective learning benefits that emerge from diverse perspectives working together on shared challenges. Adaptive support resource allocation. Provide additional resources and support for participants who need foundational development in specific competency areas while ensuring that extra support enhances rather than replaces collaborative learning experiences. Participants who need technical skill building might receive additional hands-on practice opportunities or mentoring support while still participating fully in collaborative problem-solving exercises that integrate technical and business considerations. Business strategy development might involve reading assignments, case study analysis, or mentoring relationships that prepare participants for full engagement with strategic planning activities. Change management support could include role-playing practice, communication skill development, or structured feedback opportunities that build confidence and capability for stakeholder engagement exercises. Peer learning and mentoring integration. Create opportunities for participants with complementary strengths to support each other's development while building collaborative relationships that continue beyond formal program completion. Pair participants with strong business backgrounds with those who have technical expertise, enabling mutual learning that develops both business technical integration skills and peer mentoring capabilities. Structure collaborative exercises so that participants can contribute their existing strengths while learning from others' expertise rather than feeling inadequate about knowledge gaps in unfamiliar areas. Encourage teaching and explanation opportunities where participants share their existing knowledge while practicing communication and knowledge transfer skills that prove essential for organizational AI adoption. Progress monitoring and adaptation systems. Real-time implement ongoing assessment and adaptation processes that enable customization based on participant development and learning effectiveness rather than just initial assessment and static support plans. Individual adjustment development tracking and support. Monitor participant progress across all four competency pillars while providing targeted support that addresses emerging challenges or accelerates development in areas where participants demonstrate particular strength or interest. Use weekly check-ins, portfolio reviews, and peer feedback to identify when participants need additional support or when they're ready for more challenging applications that stretch their developing capabilities. Adjust support levels and customization approaches based on participant development rather than maintaining static support plans that may no longer match evolving needs and capabilities. Learning community integration and mutual support. Create systems that enable participants to request and provide peer support while building learning communities that enhance individual development through collective engagement and knowledge sharing. Establish communication channels and collaboration tools that enable participants to seek help with specific challenges while contributing their own expertise to support others' learning. Facilitate study groups, practice partnerships, and project teams that leverage diverse learning styles and competency strengths while building relationships that support sustained learning and application. Technology and resource customization. Platform and tool adaptation for learning preferences. Recognize that participants may have different comfort levels and preferences for various technology platforms and learning tools while ensuring that everyone develops competency with AI implementation technologies that they'll encounter in professional contexts. Learning management system customization. Provide multiple pathways for accessing learning materials, participating in discussions, and submitting portfolio work while maintaining consistency in learning objectives and assessment standards. Some participants prefer structured navigation through sequential learning modules, while others benefit from topic-based resource organization that enables flexible exploration based on immediate interests and needs. Enable both individual and collaborative workspace options that accommodate different collaboration preferences while ensuring that everyone participates in shared learning experiences and community-building activities. AI tool access and practice customization. Provide multiple options for hands-on practice with AI tools while ensuring that all participants develop practical competency with various AI platforms and applications that reflect real-world implementation diversity. Some participants learn most effectively through guided tutorials and structured practice exercises, while others prefer exploratory learning with minimal initial guidance that enables discovery and experimentation. Offer both individual practice opportunities and collaborative exploration options that enable participants to develop confidence and competency through their preferred learning approaches while building toward shared proficiency standards. Resource format and delivery adaptation. Provide learning resources in multiple formats that accommodate different information processing preferences while maintaining consistency in content quality and learning objectives. Include video demonstrations, written guides, interactive tutorials, and hands-on practice opportunities that enable participants to engage with content through their most effective modalities while ensuring comprehensive coverage of essential competencies. Create both synchronous and asynchronous learning opportunities that accommodate different schedule constraints and energy patterns while maintaining program momentum and community engagement. The comprehensive learning style assessment and customization framework ensures that AI fluency development optimizes individual learning effectiveness while maintaining program coherence and collective benefits that emerge from diverse perspectives working together on shared challenges. 6.2 Baseline AI Knowledge Evaluation. Understanding starting competency levels. Comprehensive current state assessment framework. Understanding participants' existing AI knowledge and experience provides essential foundation for customizing learning approaches while maintaining appropriate challenge levels that promote growth without creating overwhelming frustration or boring redundancy. However, effective baseline assessment must go beyond simple knowledge testing to include practical understanding, misconception identification, and learning readiness evaluation that reveals how participants currently think about AI implementation rather than just what they know about AI technology. Think of baseline assessment like a physician's comprehensive patient evaluation before designing treatment plans. The physician needs to understand not only current symptoms but also medical history, lifestyle factors, previous treatment responses, and underlying health patterns that affect how the patient might respond to different therapeutic approaches. Surface-level symptom understanding assessment without deeper could lead to ineffective or even counterproductive treatment recommendations. Similarly, AI fluency development requires understanding participants' current mental models about AI capabilities and limitations, their previous experiences with technology adoption, their assumptions about implementation challenges, and their readiness for intensive learning rather than just their knowledge of AI concepts or tools. This comprehensive baseline enables design of learning experiences that build effectively on existing foundations while addressing misconceptions that could interfere with new learning. Multidimensional knowledge assessment design. Effective baseline assessment must evaluate different types of AI understanding simultaneously while recognizing that participants may demonstrate strong conceptual knowledge but limited practical application experience, or extensive hands-on experience with specific tools but poor understanding of broader strategic implications. Conceptual understanding and mental model assessment. Evaluate participants' current understanding of fundamental AI concepts including machine learning types, AI system capabilities and limitations, and implementation requirements rather than just familiarity with AI terminology or current events about AI development. Present realistic AI implementation scenarios and assess whether participants demonstrate accurate understanding of what AI can and cannot accomplish reliably, what data and infrastructure requirements exist, and what business and human factors affect AI adoption success. Look for evidence of sophisticated understanding that recognizes AI implementation complexity versus oversimplified mental models that assume AI technology automatically creates business value without careful design and management. Document specific misconceptions or knowledge gaps that could interfere with learning, such as unrealistic expectations about AI capabilities, underestimation of implementation challenges, or oversimplified assumptions about organizational change management. Practical experience and application analysis. Assess participants' direct experience with AI tools and implementation projects while understanding how those experiences might translate to or differ from the comprehensive AI fluency that the program develops. Some participants may have extensive experience with specific AI applications but limited understanding of how those tools fit within broader organizational systems or strategic frameworks. Others might have broad conceptual understanding from reading and research but minimal hands-on experience that reveals the practical challenges and iterative nature of real AI implementation work. Document both the depth and breadth of practical experience while assessing how well participants can generalize from their specific experiences to broader AI implementation principles and applications. Strategic and business integration understanding. Evaluate participants' current capability for thinking strategically about AI applications within business contexts rather than just technical functionality or isolated use case implementation. Assess understanding of how AI implementations affect business processes, stakeholder relationships, competitive positioning, and organizational change rather than just technical performance metrics or cost reduction calculations. Look for evidence of systems thinking that recognizes how AI implementations connect to broader organizational objectives, stakeholder interests, and strategic challenges rather than viewing AI as purely technical tool deployment. Document participants' current sophistication in business analysis, stakeholder management, and strategic planning that provides foundation for developing comprehensive AI implementation leadership. Misconception identification and correction planning. Common AI misconception categories and assessment. AI implementation misconceptions can significantly interfere with learning effectiveness and practical application success. Systematic identification and addressing of these misconceptions early in the program prevents confusion and resistance that could undermine development outcomes. Technology capability reality calibration misconceptions and many participants enter AI fluency development with either inflated expectations about AI capabilities that lead to unrealistic implementation goals or excessive skepticism that prevents recognition of genuine value creation opportunities. Assess whether participants understand current AI limitations including data quality requirements, domain specificity constraints, and reliability considerations that affect how AI can be deployed responsibly in business contexts. Look for evidence of AI magic thinking where participants assume AI technology automatically solves complex problems without careful design, data preparation, and ongoing management versus appropriate appreciation for AI's genuine but bounded capabilities. Document specific areas where participants need calibration of expectations that enables realistic implementation planning while maintaining appropriate enthusiasm for AI's genuine potential for value creation. Implementation complexity and change management understanding. Common misconceptions about AI implementation often underestimate the organizational change management required for successful adoption while overestimating the purely technical aspects of deployment challenges. Assess participants' understanding of how technology adoption affects human workflows, organizational culture, and stakeholder relationships rather than just technical integration and performance optimization. Look for evidence of naive assumptions that good AI technology will be adopted automatically versus sophisticated understanding of change management, training, and support requirements that determine adoption success. Evaluate participants' current understanding of stakeholder resistance, organizational politics, and cultural factors that affect technology implementation rather than just technical and business considerations. Business value creation and measurement misconceptions. Many participants have unclear or oversimplified understanding of how AI creates business value, what metrics matter for measuring success, and how to design implementations that produce measurable organizational benefits. Assess whether participants understand the difference between technical performance metrics and business value creation, how to connect AI implementations to specific organizational objectives, and what constitutes realistic timelines for demonstrating return on investment. Look for evidence of understanding that AI value creation often requires iteration and optimization over time rather than immediate perfect results from initial implementations. Document misconceptions about cost-benefit analysis, value measurement, and business case development that need correction to enable effective strategic thinking about AI implementation priorities and resource allocation. Adaptive program customization based on assessment results. Learning enhancement pathway modification and support. Baseline assessment results enable customization of learning approaches and support systems that optimize development effectiveness while maintaining program standards and collective learning benefits. Accelerated track development for advanced participants. Some participants may demonstrate strong foundational knowledge and experience that enables them to progress more rapidly through certain competency areas while focusing development effort on areas where they need growth or integration. Design advanced track options that provide additional challenge and depth for participants who demonstrate readiness for complex applications while ensuring they still participate fully in collaborative learning and peer support activities. Create mentoring opportunities where advanced participants support others learning while developing teaching and knowledge transfer skills that prove essential for organizational AI adoption leadership. Ensure that acceleration doesn't create isolation from learning community while enabling participants to maximize their development potential rather than being constrained by lowest common denominator pacing. Foundational support enhancement for developing participants. Participants who demonstrate limited baseline knowledge or experience may need additional support and preparation that enables full participation in intensive learning without feeling overwhelmed or left behind. Provide pre-program preparation resources including reading materials, online tutorials, and practice exercises that build foundational understanding before intensive collaborative learning begins. Create peer support systems and mentoring relationships that provide assistance and encouragement while building confidence and capability for collaborative problem-solving and hands-on application exercises. Design catch-up support systems that help participants who fall behind maintain progress and engagement rather than becoming discouraged or disengaged from learning community. Integration challenge experience levels customization for mixed. Most cohorts include participants with diverse baseline knowledge and experience levels that create opportunities for peer learning while requiring careful management to ensure everyone contributes and benefits from collaborative experiences. Design collaborative exercises that leverage diverse expertise levels while ensuring that everyone has meaningful contributions to make rather than becoming passive recipients of others' knowledge. Create role assignments and project structures that enable participants with different backgrounds to contribute their strengths while learning from others' expertise in complementary areas. Establish communication norms and facilitation approaches that encourage knowledge sharing and mutual support while preventing dominance by most experienced participants or withdrawal by those with less background knowledge. Documentation and progress tracking systems. Individual development plan creation and management. Baseline assessment results enable creation of personalized development plans that guide individual learning while maintaining alignment with overall program objectives and standards. Competency gap analysis and target setting. Document specific competency gaps and development opportunities for each participant while establishing realistic but challenging goals for growth across all 4 pillar areas. Create individual learning contracts that specify development objectives, support resources, progress milestones, and success. Criteria that enable accountability and motivation while accommodating different starting points and learning speeds. Establish progress tracking systems that monitor development across multiple competency dimensions while providing feedback and support that maintains momentum and addresses emerging challenges. Identify existing participant strengths that can contribute to peer learning while creating opportunities for expertise sharing that builds confidence and community relationships. Relationships. Plan teaching and mentoring opportunities where participants can share their existing knowledge while developing communication and knowledge transfer skills that prove essential for organizational AI adoption. Create collaborative project assignments that leverage diverse participant backgrounds while ensuring everyone develops capabilities in all for competency areas rather than just contributing their existing expertise. Assessment integration and adaptation planning. Use baseline assessment results to adapt ongoing assessment approaches that accurately measure progress rather than just comparing participants to uniform standards that may not reflect different starting points and development trajectories. Create portfolio development guidelines that enable participants to demonstrate growth from their individual starting points while maintaining consistent standards for program completion and competency certification. Establish peer assessment and self-assessment processes that help participants understand their development while building metacognitive awareness that supports continued learning and adaptation throughout their careers. The comprehensive baseline assessment framework enables effective program customization that optimizes individual learning while maintaining program coherence and collective benefits that emerge from diverse participant backgrounds working together on shared AI implementation challenges. 6.3 Personal AI Impact Goal Setting. Connecting program learning to individual career objectives. Strategic alignment framework for individual motivation. Personal goal setting transforms AI fluency development from generic skill acquisition into strategically focused capability building that connects directly to participants' career aspirations, organizational challenges, and professional impact objectives. When participants understand clearly how program learning enhances their ability to achieve meaningful professional goals, they invest more deeply in challenging learning experiences while maintaining motivation through temporary difficulties and setbacks. Think of goal setting like an architect designing a custom home for a specific family. While the architect uses standard construction principles and building codes, the final design must reflect the family's lifestyle, priorities, aesthetic preferences, and future plans rather than just creating another generic structure. The architectural framework provides structure and standards, but customization creates meaning and emotional investment that sustains commitment through the challenging construction process. Similarly, AI fluency development uses consistent competency frameworks and learning approaches, but individual goal setting creates personal meaning that sustains motivation through intensive learning and application challenges. Participants need to understand specifically how developing strategic thinking, technical implementation, change management, and ethical reasoning capabilities will enable them to solve problems they care about and advance toward professional outcomes they value. Individual career vision and AI integration assessment. Effective goal setting begins with understanding participants' current career trajectories, professional aspirations, and organizational contexts that provide opportunities for applying enhanced AI capabilities rather than just general enthusiasm for learning new skills. Current role analysis and enhancement opportunities. Explore how participants currently contribute value within their organizations and what challenges or limitations they encounter that could be addressed through enhanced AI capabilities rather than just adding new skills to existing approaches. Assess specific workflow inefficiencies, decision-making challenges, stakeholder communication difficulties, or innovation opportunities that participants have observed in their current roles that could benefit from systematic AI application. Document particular frustrations or missed opportunities that motivate participants' interest in AI development while identifying realistic that near-term applications could demonstrate value creation and build confidence. Consider how participants' existing expertise and organizational relationships position them to become AI implementation leaders rather than just AI tool users who depend on others for strategic guidance and change management. Professional development trajectory positioning and strategic. Understand participants' career goals and advancement aspirations while exploring how AI fluency could accelerate professional development or enable new opportunities that wouldn't be available without enhanced capabilities. Assess whether participants aspire to leadership roles that require technology strategy development, cross-functional project management, innovation facilitation, or organizational transformation guidance that AI fluency enables. Explore interest in industry recognition, thought leadership, consulting opportunities, or entrepreneurial ventures that could benefit from deep understanding of AI implementation rather than just general awareness of AI trends. Consider how AI expertise could differentiate participants within their industries or enable career transitions that align with evolving market demands for AI-fluent professionals. Organizational opportunities, context, and implementation. Evaluate participants' organizational environments, including culture, technology infrastructure, strategic priorities, and change readiness that affect opportunities for applying AI capabilities and demonstrating value creation. Assess current organizational AI maturity, leadership support for innovation, resource availability for pilot projects, and stakeholder openness to technology adoption that influence realistic goal setting and implementation strategies. Document specific organizational challenges, competitive pressures, or strategic initiatives that could benefit from AI applications while considering political dynamics and change management requirements that affect implementation success. Understand how participants' roles and relationships position them to influence AI adoption decisions versus requiring collaboration with others who control resources and strategic direction. Smart goal development for AI implementation success. Specific and measurable objective creation. Transform general interest in AI development into specific, actionable objectives that enable progress tracking and success. Measurement while maintaining connection to broader career and organizational value creation. Business impact target definition and quantification. Help participants identify specific business outcomes they want to achieve through AI implementation rather than just technical capabilities they want to develop or tools they want to learn. Examples might include reducing customer service response time by 30% through AI-powered automation, increasing sales team productivity by 25% through AI-enhanced lead qualification, or improving hiring quality by implementing bias reduction AI screening processes. Establish baseline measurements and realistic targets that reflect genuine improvement potential while considering organizational constraints and implementation timelines that affect achievable outcomes. Connect AI impact goals to broader organizational objectives and key performance indicators that demonstrate strategic value rather than just operational efficiency improvements. Competency development milestones and integration targets. Create specific learning objectives across all four competency pillars that build toward participants' professional goals while ensuring comprehensive AI fluency development rather than narrow specialization. Strategic thinking goals might include completing market analysis of AI opportunities within participants' industries, developing business cases for specific AI implementations, or presenting AI strategy recommendations to senior leadership. Technical implementation goals could involve successfully deploying AI tools for specific business applications, integrating AI capabilities with existing systems, or completing AI project management from conception through production deployment. Change management objectives might include facilitating AI adoption workshops, building stakeholder support for AI initiatives, or developing training programs that help colleagues adopt AI tools effectively. Ethical reasoning goals could encompass conducting AI bias assessments, developing organizational AI governance frameworks, or leading discussions about responsible AI development practices. Timeline development and milestone sequencing. Establish realistic timelines that balance ambitious goal achievement with practical constraints including program intensity, organizational change pace, and individual learning development patterns. Create short-term milestones, 30 to 60 days, that provide early success experiences and motivation while building toward medium-term objectives, 90 to 180 days, that demonstrate significant value creation. Sequence milestone achievement to build confidence and capability progressively rather than requiring major accomplishments before developing necessary skills and organizational support. Plan for adaptation and goal modification based on learning experiences and changing organizational circumstances rather than rigid adherence to initial plans that may become unrealistic or suboptimal. Goal integration with program learning and application. Learning activity customization and focus areas. Connect individual goals to specific program learning activities and projects that enable participants to work toward their objectives while developing comprehensive AI fluency rather than just pursuing narrow interests. Project selection and customization for goal achievement. Guide participants in selecting collaborative projects, individual assignments, and practical applications that advance their personal goals while contributing to peer learning and program objectives. Participants focused on customer service AI might choose projects involving Chabot development, sentiment analysis, or customer experience optimization while still participating in broader strategic thinking and ethical reasoning exercises. Those interested in AI for marketing might focus applications on content generation, predictive analytics, or campaign optimization while developing change management skills through stakeholder engagement and adoption facilitation. Enable goal-focused customization while ensuring that all participants develop capabilities across strategic thinking, technical implementation, change management, and ethical reasoning rather than just their areas of primary interest. Mentoring and expert connection for specialized support. Connect participants with mentors, industry experts, or organizational leaders who can provide guidance specific to their goal areas while maintaining integration with broader program learning and community development. Arrange conversations with professionals who have successfully implemented AI in participants' target domains while emphasizing learning transfer and principle application rather than just specific tool or technique instruction. Create networking opportunities with industry leaders, AI practitioners, and organizational change agents who can provide insights about career development and professional positioning that leverage AI fluency. Facilitate connections with program alumni or external professionals who have achieved similar goals while building ongoing professional networks that support continued development and opportunity identification. Real-world application planning and implementation support. Help participants design practical application projects within their current work environments that advance their goals while providing authentic learning experiences and value creation opportunities. Support pilot project development that enables participants to demonstrate AI value within their organizations while building experience with implementation challenges and stakeholder management. Provide guidance for navigating organizational politics, resource allocation, and change management requirements that affect project success while building skills for ongoing AI implementation leadership. Create accountability and support systems that help participants overcome obstacles and maintain momentum toward goal achievement while learning from setbacks and adaptation requirements. Progress tracking and goal evolution. Regular review and adaptation processes. Establish systematic approaches for monitoring progress toward individual goals while providing support for goal modification based on learning experiences and changing circumstances rather than rigid adherence to initial plans. Milestone achievement assessment and celebration. Create regular check-in processes that acknowledge progress toward individual goals while providing support for addressing challenges and obstacles that impede advancement. Celebrate milestone achievements that demonstrate progress while using success experiences to build confidence and motivation for tackling more challenging objectives. Building document learning and insights gained through goal pursuit while portfolio evidence that demonstrates competency development and value creation capability. Use milestone review opportunities to assess whether goals remain realistic and motivating or need modification based on changed circumstances or enhanced understanding of opportunities and constraints. Challenge navigation and support provision. Provide structured support for participants who encounter obstacles in pursuing their goals while helping them develop problem-solving capabilities and resilience that serve long-term professional development. Address common challenges including organizational resistance, resource limitations, competing priorities, and implementation complexity that affect goal achievement while building skills for ongoing obstacle navigation. Connect participants facing similar challenges while facilitating peer support and collaborative problem-solving that enhances both individual goal achievement and community learning. Help participants distinguish between goals that need modification due to unrealistic expectations and those that require persistence and creative problem-solving to achieve despite temporary setbacks. Goal evolution and strategic adaptation. Support goal modification and evolution based on learning experiences, changed organizational circumstances, or enhanced understanding of AI implementation opportunities and requirements. Encourage participants to expand or enhance their goals when initial objectives prove too limited while ensuring that modifications maintain connection to meaningful professional development and value creation. Help participants recognize when goal modification reflects growth and enhanced understanding rather than decreased ambition or commitment to professional development. Create frameworks for evaluating new goal opportunities that emerge through program learning while maintaining focus and avoiding constant goal shifting that prevents sustained progress toward meaningful objectives. The comprehensive personal goal setting framework ensures that AI fluency development creates meaningful individual value while maintaining program coherence and collective learning benefits that emerge from diverse participants pursuing complementary objectives within shared competency development frameworks. 6-point for technology access and infrastructure. Setup, ensuring equal opportunities. Learning. Comprehensive infrastructure assessment and planning. Technology infrastructure represents the foundation that enables intensive hands-on learning with AI tools and platforms, but infrastructure requirements extend beyond simple software access to include bandwidth, computing capacity, security compliance, and user support systems that ensure all participants can engage fully with learning activities regardless of their starting technology resources or technical expertise. Consider the infrastructure requirements for hosting a professional cooking school where students must have access to commercial-grade equipment, specialized ingredients, proper ventilation, and safety systems that enable focused learning without technology obstacles interfering with skill development. Some students might arrive with professional knife sets while others need basic equipment, but everyone must have access to tools that enable effective practice and learning. Similarly, AI fluency development requires ensuring that all participants have adequate technology access that enables meaningful engagement with AI platforms, collaborative learning tools, and project development resources without creating equity barriers that disadvantage participants based on their organizational technology resources or personal device capabilities rather than their learning potential and effort. Baseline technology audit and requirement analysis. Systematic assessment of participant technology access and organizational infrastructure enables identification of gaps and requirements that must be addressed before intensive learning begins rather than discovering obstacles during program implementation when they disrupt learning momentum. Individual device and connectivity assessment. Evaluate participants' current device capabilities including processing power, memory, operating systems, and software compatibility that affect ability to run AI applications and collaborative learning platforms effectively. Assess internet connectivity quality, including bandwidth, stability, and security restrictions that might prevent access to cloud-based AI tools or real-time collaborative learning activities that require reliable high-speed connections. Document organizational IT policies, security requirements, and software installation restrictions that might prevent participants from accessing necessary AI platforms or collaboration tools through their work devices. Consider personal device options and organizational policies about using personal computers for professional development activities while ensuring that device limitations don't create learning barriers or equity issues. Organizational infrastructure and policy analysis. Understand organizational technology infrastructure, including network capacity, security frameworks, data protection requirements, and IT support availability that affect how participants can access and use AI tools within their work environments. Assess organizational cloud computing policies, external software approval processes, and data sharing restrictions that might affect participants' ability to practice with AI tools or collaborate on projects that involve organizational information. Document IT support availability and expertise levels that could assist participants with technical setup and troubleshooting while identifying areas where additional support or training might be needed. Evaluate organizational learning management system capabilities and integration options that could enhance program delivery while leveraging existing infrastructure investments and user familiarity. Software and platform access planning. Identify specific AI tools, collaboration platforms, and learning technologies that participants will need throughout the program while developing cost-effective access strategies that ensure everyone has necessary capabilities. Research enterprise licensing options, educational discounts, and trial access programs that could provide cost-effective access to professional AI tools while enabling hands-on practice with industry-standard platforms. Evaluate platform compatibility across different operating systems, device types, and organizational security requirements. While selecting tools that work reliably for all participants rather than excluding some based on technical constraints. Plan for platform diversity that exposes participants to multiple AI tools rather than just single vendor solutions while managing complexity and access costs that could become overwhelming or prohibitive. Equitable access strategy development. Resource provision and support systems. Develop comprehensive approaches for ensuring that technology limitations don't create barriers to program participation while maintaining cost-effectiveness and practical implementation feasibility. Device and connectivity support options. Create lending programs or partnership arrangements that provide adequate computing devices for participants whose current equipment doesn't meet program requirements rather than excluding capable participants based on technology access limitations. Investigate organizational IT support for upgrading participant devices or providing temporary access to adequate computing resources during program periods when intensive AI tool usage is required. Develop connectivity solutions including mobile hotspot lending, co-working space partnerships, or organizational guest network access that ensure reliable internet access for all participants regardless of home connectivity limitations. Consider hybrid access options that combine organizational and personal resources while respecting security requirements and ensuring that all participants have comparable learning opportunities. Software access and licensing solutions. Negotiate educational pricing, trial extensions, or group licensing agreements that provide cost-effective access to professional AI tools while enabling authentic learning experiences with industry-standard platforms. Create shared access pools for expensive software licenses that enable all participants to gain experience with specialized AI tools while managing costs through coordinated scheduling and usage optimization. Develop open-source and free tool alternatives that provide comparable learning experiences while reducing access barriers and enabling continued practice beyond formal program completion. Establish relationships with AI vendors and platform providers who might provide educational access in exchange for feedback, case studies, or future business relationships that benefit both organizations. Technical support and training infrastructure. Provide comprehensive technical support systems that technical skills and AI experience variation. Evaluate participants' current technical capabilities including software proficiency, data analysis experience, and previous AI tool usage while creating teams that include complementary technical skill levels rather than concentrating expertise unevenly. Pair participants with strong technical backgrounds with those who have limited technology experience while ensuring that technical complexity doesn't overwhelm less experienced participants or bore those with advanced capabilities. Include participants who have hands-on AI experience with those who bring conceptual understanding but limited practical application while creating learning opportunities for knowledge transfer and skill development. Consider different technology platforms and tool familiarity while ensuring that teams can benefit from diverse technical perspectives rather than being limited by single vendor or single approach thinking. Cognitive style and learning preference integration. Understand participants' different approaches to problem solving, decision making, and collaboration while creating teams that benefit from cognitive diversity without creating excessive conflict or communication breakdown. Include participants who demonstrate analytical thinking with those who show creative and intuitive approaches while ensuring that teams can integrate different problem-solving styles effectively. Balance participants who prefer structured approaches with those who thrive in ambiguous environments while creating teams that can handle both systematic planning and adaptive response to unexpected challenges. Consider communication style diversity including extroverted processors who think out loud and introverted reflectors who need quiet processing time while designing collaboration approaches that leverage different communication preferences. Balance team composition and dynamic optimization. Team size and structure considerations. Research on team effectiveness suggests optimal team sizes and structure considerations that balance collaborative benefits with coordination complexity while ensuring that all participants have meaningful opportunities to contribute and learn from diverse perspectives. Optimal size for collaborative learning and individual contribution. Design teams of 4 to 6 participants that provide sufficient diversity for rich perspective sharing while remaining small enough that everyone can contribute meaningfully to discussions and decision-making rather than becoming passive observers. Larger teams often struggle with coordination complexity and unequal participation patterns where some members dominate while others withdraw, while smaller teams may lack sufficient diversity for meaningful cross-pollination and collaborative learning. Consider subteam formation within larger cohorts that enables both intimate collaborative learning and broader community interaction while maintaining manageable group dynamics for intensive project work and peer support. Plan for team stability that enables relationship building and trust development while also providing opportunities for participants to work with different colleagues on various projects throughout the program. Role definition and responsibility distribution. Create structured role assignments that ensure all participants have specific contributions to make while preventing role confusion or unequal workload distribution that could undermine collaborative effectiveness and individual learning. Assign roles based on development objectives rather than just existing strengths, enabling participants to practice capabilities they want to build while contributing meaningfully to team success through areas where they already demonstrate competence. Rotate role assignments across different projects and timeframes so that participants experience different aspects of AI implementation leadership while preventing typecast into narrow specializations that limit their comprehensive development. Design accountability systems that ensure individual responsibility within collaborative contexts while maintaining focus on collective success and mutual support rather than competitive individual achievement. Conflict management and productive disagreement. Anticipate that diverse teams will experience disagreement and conflict that can either enhance learning through productive exploration of different perspectives or undermine collaboration through interpersonal tension and communication breakdown. Establish ground rules and communication norms that encourage respectful disagreement and perspective sharing while preventing personal conflict and destructive argument that damages relationships and learning effectiveness. Provide facilitation training and conflict resolution resources that help team members navigate disagreement constructively. While building skills for managing stakeholder conflict in real AI implementation projects. Create structured processes for decision-making that acknowledge different perspectives while enabling teams to reach conclusions and maintain momentum despite complexity and uncertainty that characterize AI implementation challenges. Introduction of Chapter 7. This chapter establishes strategic AI translators as the essential bridge builders who connect AI technical possibilities with business strategic needs through 6 integrated competency areas. 1. Business process analysis, systematic identification of AI transformation opportunities. 2. AI capability mapping, connecting technology possibilities to business value creation. 3. ROI estimation and business cases, quantifying value and securing organizational support. 4. Multi-stakeholder communication, facilitating dialogue across diverse organizational audiences. 5. Strategic prioritization, sequencing initiatives for maximum cumulative impact. 6. Competitive analysis, understanding AI as sustainable competitive advantage. The chapter transforms participants from AI-aware individuals into organizational catalysts who can identify genuine business value while building stakeholder support for successful implementation. Part 3. The 4-pillar competency development system. Introduction of Chapter 7. This chapter establishes strategic AI translators as the essential bridge builders who connect AI technical possibilities with business strategic needs through 6 integrated competency areas. 1. Business process analysis, systematic identification of AI transformation opportunities. 2. AI capability mapping, connecting technology possibilities to business value creation. 3. ROI estimation and business cases, quantifying value and securing organizational support. 4. Multi-stakeholder communication, facilitating dialogue across diverse organizational audiences. 5. Strategic prioritization, sequencing initiatives for maximum cumulative impact. 6. Competitive analysis, understanding AI as sustainable competitive advantage. The chapter transforms participants from AI-aware individuals into organizational catalysts who can identify genuine business value while building stakeholder support for successful implementation. Chapter 7. Pillar 1. Strategic RE. Translators development. Learning objectives. By the end of this chapter, you will understand how to develop professionals who can identify high-value AI opportunities within complex business environments, translate between technical capabilities and strategic objectives, and communicate AI value propositions effectively across diverse organizational audiences. You will master frameworks for business process analysis, ROI estimation, stakeholder communication, and strategic prioritization that enable participants to become effective bridges between AI technology potential and practical business value creation. Think of this chapter as the architect's training manual for professionals who must design solutions that serve multiple stakeholders with different needs, constraints, and priorities. Just as successful architects must understand both engineering possibilities and human requirements while translating between contractors, clients, and regulatory bodies, strategic AI translators must understand both AI capabilities and business realities while facilitating communication among technical teams, executive leadership, and end users. The frameworks and methodologies in this chapter will transform participants from individuals who understand AI concepts into professionals who can identify where AI creates genuine business value and build organizational support for successful implementation. 7.1 Business Process Analysis Methodology. Systematic opportunity. Framework. Understanding business. Identification. Process for AI implementation analysis. Business process analysis for AI opportunity identification requires a fundamentally different approach than traditional process improvement methodologies. While conventional business analysis often focuses on eliminating waste and optimizing existing workflows, AI opportunity analysis must identify processes where intelligent automation, predictive analytics, or decision support can create entirely new capabilities rather improvements than just incremental efficiency. Imagine a detective investigating a complex case who must look beyond obvious evidence to identify patterns, connections, and opportunities that others might miss. The detective needs systematic investigation methods but also creative thinking that recognizes how new investigative tools might reveal insights that traditional approaches couldn't uncover. The goal isn't just solving the immediate case more efficiently, but understanding how new investigative capabilities might transform law enforcement approaches. Similarly, strategic AI translators must examine business processes with both analytical rigor and creative vision that recognizes how AI capabilities might enable fundamentally different approaches to achieving business objectives. They need systematic frameworks for process analysis while maintaining strategic perspective that identifies transformation opportunities rather than just automation possibilities. Comprehensive analysis framework process mapping and effective AI opportunity identification requires understanding business processes at multiple levels simultaneously, from detailed task analysis that reveals automation opportunities to strategic workflow examination that identifies decision-making enhancement possibilities. End-to-end process documentation and stakeholder journey mapping. Begin process analysis by documenting complete workflows from initial customer or stakeholder contact through final outcome delivery, including all decision points, information requirements, and stakeholder interactions rather than just focusing on individual departmental activities. Map information flow throughout processes including data sources, transformation requirements, decision-making dependencies, and communication patterns that affect process. Effectiveness and stakeholder satisfaction rather than just task completion efficiency. Document stakeholder experience throughout processes including pain points, waiting periods, information gaps, and satisfaction factors that affect overall value creation rather than just internal operational metrics. Include exception handling and edge case management that reveals process complexity and adaptation requirements often overlooked in standard workflow documentation but critical for understanding AI implementation opportunities. Decision point analysis and information architecture assessment. Identify all decision points within business processes including routine choices that could benefit from automation, complex judgments that might benefit from AI-powered analysis, and strategic decisions that could be enhanced through predictive insights or pattern recognition. Analyze information availability and quality at each decision point including data sources, update frequency, reliability levels, and integration challenges that affect decision-making effectiveness and could be addressed through AI-powered information processing. Document decision-making criteria including explicit rules, implicit knowledge, stakeholder preferences, and environmental factors that influence choices while identifying opportunities for AI-powered decision support that enhances rather than replaces human judgment. Assess decision impact and consequences including downstream effects, stakeholder impacts, and strategic implications that determine where improved decision-making could create significant value through AI-enhanced analysis and recommendation systems. Inefficiency and bottleneck identification with AI solution potential. Examine process bottlenecks and inefficiencies specifically through the lens of AI capabilities including pattern recognition, natural language processing, predictive analytics, and automation that could address root causes rather than just symptoms. Identify repetitive tasks that consume significant time but don't require complex human judgment including data entry, classification, routing, and basic analysis that could benefit from intelligent automation while freeing human capacity for higher value activities. Document communication bottlenecks including information translation requirements, stakeholder coordination challenges, and knowledge transfer difficulties that could benefit from AI-powered language processing, sentiment analysis, or automated reporting capabilities. Analyze capacity constraints and resource limitations that prevent process optimization including workforce limitations, expertise gaps, and scaling challenges that AI capabilities might address through intelligent assistance or automated capacity expansion. AI opportunity assessment and prioritization. Technology business feasibility assessment fit analysis and moving from process analysis to AI opportunity identification requires systematic evaluation of where current AI capabilities can address identified business challenges while considering implementation feasibility and organizational readiness factors. AI capability mapping to business process requirements. Match specific AI technologies and capabilities to identified process improvement opportunities while considering both current AI limitations and emerging capabilities that might become available within implementation timeframes. Evaluate natural language processing applications for processes involving document analysis, customer communication, content creation, or information extraction while considering accuracy requirements challenges. And domain-specific language. Assess predictive analytics opportunities for processes involving forecasting, risk assessment, resource planning, or trend analysis while considering data quality requirements and prediction accuracy expectations that affect business value creation. Consider computer vision applications for processes involving image analysis, quality inspection, document processing, or visual pattern recognition while evaluating infrastructure requirements and integration complexity. Analyze automation potential for rule-based decisions, routine workflows, and structured data processing while distinguishing between simple robotic process automation and intelligent automation that adapts to changing conditions. Implementation complexity and resource requirement analysis. Evaluate technical implementation requirements including data availability, system integration needs, infrastructure investments, and ongoing maintenance requirements that affect total cost of ownership and implementation timeline. Assess organizational change management requirements including training needs, workflow modifications, stakeholder buy-in, and cultural adaptation that influence implementation success beyond technical feasibility considerations. Consider regulatory and compliance implications including data protection requirements, industry regulations, audit needs, and risk management considerations that might affect AI implementation approaches or limit certain applications. Analyze vendor and platform options including build versus buy decisions, integration capabilities, customization requirements, and long-term support considerations that affect implementation strategy and resource allocation. Value creation potential and business impact assessment. Quantify potential business value creation including efficiency improvements, quality enhancements, cost reductions, and revenue opportunities while considering both direct and indirect benefits that AI implementation might generate. Estimate time savings and productivity improvements including labor cost reductions, capacity increases, and faster decision-making that enable organizations to achieve more with existing resources or redirect human effort toward higher value activities. Assess quality improvements including error reduction, consistency enhancement, compliance improvement, and customer satisfaction increases that create business value through better outcomes rather than just cost reduction. Consider strategic value creation including competitive advantage, market positioning, innovation capability, and customer experience enhancement that might justify AI investment even when direct ROI calculations prove challenging. Evaluate risk mitigation benefits including improved compliance, better decision-making, fraud detection, and operational reliability that create value through problem prevention rather than just process improvement. Stakeholder impact analysis and change management planning. Multi-stakeholder perspective communication strategy integration and AI opportunity identification must consider impacts on various stakeholder groups while developing communication strategies that build support for implementation rather than just identifying technical possibilities and business benefits. Employee impact assessment and workforce planning. Analyze how AI implementations might affect different employee groups including job role changes, skill development requirements, and career pathway modifications that require proactive planning and support rather than reactive management after deployment. Identify employees whose work might be enhanced by AI tools including decision support, information access, and automated assistance that could improve job satisfaction and effectiveness while reducing routine task burden. Assess training and development needs including new skill requirements, technology adaptation, and workflow changes that enable employees to work effectively with AI systems while maintaining professional growth and career advancement opportunities. Consider workforce transition planning for employees whose roles might be significantly changed by AI implementation while exploring redeployment opportunities and skill development that enable career continuity rather than displacement. Plan change management and communication strategies that address employee concerns while building enthusiasm for AI-enhanced work environments that improve rather than threaten job security and professional development. Customer experience and service quality implications. Evaluate how AI implementations might affect customer interactions, service quality, and satisfaction levels while ensuring that efficiency improvements don't compromise customer experience or relationship quality. Assess customer preference considerations including desires for human interaction, comfort with automated systems, privacy concerns, and service customization expectations that affect AI implementation design and communication strategies. Consider service quality improvements including faster response times, more accurate information, personalized recommendations, and 24/7 availability that could enhance customer satisfaction through AI-powered capabilities. Analyze potential customer concerns including privacy protection, decision transparency, error handling, and escalation procedures that require careful planning and communication to maintain trust and satisfaction. Plan customer education and support strategies that help customers understand and benefit from AI-enhanced services while providing alternatives for those who prefer traditional interaction methods. Executive and strategic leadership engagement. Develop communication strategies for executive audiences that emphasize strategic value creation, competitive positioning, and long-term business benefits rather than just technical capabilities or operational improvements. Present AI opportunities within broader strategic context including market trends, competitive pressures, customer expectations, and organizational transformation objectives that resonate with executive priorities and decision-making frameworks. Address executive concerns including investment requirements, implementation risks, organizational change implications, and performance measurement approaches that affect strategic decision-making about AI initiative approval and resource allocation. Create business case presentations that connect AI opportunities to specific strategic objectives while providing realistic timelines, resource requirements, and success metrics that enable informed executive decision-making. Plan ongoing executive communication and progress reporting that maintains leadership support throughout implementation while adapting to changing strategic priorities and organizational circumstances. The comprehensive business process analysis methodology enables strategic AI translators to identify genuine opportunities where AI creates significant business value while building stakeholder support and realistic implementation planning that leads to successful adoption rather than just impressive technology demonstrations. 7.2 AI Capability Mapping Techniques. Connecting technology possibilities to business needs. Understanding AI technology capabilities and business applications. Effective AI capability mapping requires understanding both what AI technologies can accomplish reliably in business environments and how those capabilities connect to specific organizational challenges and opportunities. Unlike theoretical technology assessments that focus on research possibilities, practical capability mapping must consider current technology maturity, implementation constraints, and business context factors that determine whether AI applications will create value in real organizational settings. Think of AI capability mapping like a master chef understanding both the properties of available ingredients and the preferences of restaurant customers. The chef needs to know not only what each ingredient can contribute to dishes but also how different ingredients work together, what preparation methods are required, and how finished dishes will satisfy customer expectations and dietary requirements. Technical knowledge about ingredients alone isn't sufficient. The chef must understand how to combine technical possibilities with practical constraints to create valuable dining experiences. Similarly, strategic AI translators must understand AI capabilities well enough to recognize business applications while considering implementation realities and organizational constraints that affect whether technology possibilities translate to practical value creation. This requires both technical comprehension and business judgment that connects AI potential to real-world organizational needs. Comprehensive AI Technology Assessment Framework. Mapping AI capabilities to business needs requires systematic understanding of different AI technology categories and their practical applications rather than just general awareness of AI trends or vendor marketing claims. Natural language processing and communication enhancement applications. Understand current natural language processing capabilities including text analysis, content generation, language translation, and conversational interfaces while recognizing accuracy limitations and domain-specific challenges that affect business application feasibility. Assess content creation and communication automation including document drafting, email responses, report generation, and customer communication that could improve efficiency while maintaining quality and personalization standards. Evaluate information extraction and analysis including document processing, sentiment analysis, topic classification, and knowledge extraction from unstructured text that could enhance decision-making and reduce manual analysis requirements. Consider conversational AI applications including chatbots, virtual assistants, and automated customer service that could improve response times and availability while recognizing limitations in handling complex queries and emotional nuance. Analyze translation and multilingual communication capabilities that could enable global business operations while considering accuracy requirements and cultural sensitivity factors that affect international communication effectiveness. Predictive analytics and decision support systems. Map predictive analytics capabilities including forecasting, risk assessment, pattern recognition, and trend analysis to business processes that could benefit from improved prediction accuracy and data-driven decision support. Assess demand forecasting applications including sales prediction, inventory planning, resource allocation, and capacity management that could reduce costs and improve service levels through more accurate anticipation of future needs. Evaluate risk assessment and fraud detection including financial risk analysis, security threat identification, quality control, and compliance monitoring that could prevent problems and reduce losses through early warning systems. Consider customer behavior analysis including purchase prediction, churn analysis, personalization, and recommendation systems that could improve customer satisfaction and revenue through better understanding of preferences and needs. Analyze operational optimization including supply chain management, scheduling, maintenance planning, and resource allocation that could improve efficiency through intelligent analysis of complex operational data. Computer vision and visual intelligence applications. Understand computer vision capabilities including image recognition, object detection, quality inspection, and visual analysis while considering accuracy requirements and environmental factors that affect implementation success. Detection. Assess quality control and inspection applications including defect measurement accuracy, consistency verification, and safety monitoring that could improve product quality while reducing manual inspection costs. Evaluate document processing including form recognition, data extraction, signature verification, and automated filing that could streamline administrative processes while maintaining accuracy and security requirements. Consider security and monitoring applications including access control, behavior analysis, incident detection, and surveillance that could improve safety and security while respecting privacy requirements and organizational policies. Analyze visual content creation including image editing, design assistance, and creative enhancement that could improve. Marketing effectiveness and content quality while maintaining brand consistency and creative standards. Business value mapping and application design. Strategic value creation through AI implementation. Moving from technology understanding to business value creation requires systematic analysis of how AI capabilities address specific organizational challenges while creating measurable improvements in performance, efficiency, or strategic positioning. Competitive advantage development and market positioning. Identify AI applications that could create sustainable competitive advantages including unique customer experiences, superior operational efficiency, innovative service offerings, or enhanced decision-making capabilities that competitors cannot easily replicate. Assess customer experience enhancement including personalization, responsiveness, convenience, and service quality improvements that could increase customer satisfaction and loyalty while reducing service costs and improving retention rates. Evaluate innovation acceleration including product development support, market analysis, customer insight generation, and creative assistance that could improve innovation speed and effectiveness while reducing development costs and market risks. Consider market expansion opportunities including language capabilities, cultural adaptation, scaling possibilities, and new service offerings that AI capabilities might enable while assessing market demand and implementation requirements. Analyze operational excellence including process optimization, quality improvement, cost reduction, and reliability enhancement that could improve organizational performance while maintaining or enhancing customer satisfaction and employee experience. ROI and value quantification methodologies. Develop systematic approaches for quantifying AI implementation value including both direct cost savings and indirect benefits that may be difficult to measure precisely but contribute significantly to organizational success. Calculate efficiency improvements including time savings, labor cost reductions, capacity increases, and resource optimization that create measurable value through improved operational performance and reduced operating expenses. Assess quality improvements including error reduction, consistency enhancement, compliance improvement, and customer satisfaction increases that create value through better outcomes and reduced rework or problem resolution costs. Evaluate revenue enhancement including sales increases, customer retention improvements, new service offerings, and market expansion that generate additional income through AI-enhanced capabilities improvements. And customer experience. Consider risk mitigation benefits including fraud prevention, compliance improvement, security enhancement, and operational reliability that create value through problem avoidance and reduced insurance, legal, or remediation costs. Analyze strategic value creation including brand enhancement, competitive positioning, innovation capability, and organizational learning that contribute to long-term success even when direct financial impact proves difficult to quantify precisely. Implementation feasibility and resource planning. Connecting AI capabilities to business value requires realistic assessment of implementation requirements and organizational capacity that determines whether promising applications can be deployed successfully within available resources and timeframes. Technical infrastructure and integration requirements. Assess data availability and quality, including source systems, data formats, update frequency, and accuracy levels that affect AI implementation success, while identifying data preparation and integration requirements that must be addressed. Evaluate system integration complexity, including API availability, security requirements, performance standards, and compatibility factors that influence implementation cost and timeline while determining technical architecture requirements. Consider infrastructure requirements, including computing capacity, storage needs, network bandwidth, and security capabilities that support AI applications, while assessing costs and upgrade requirements for organizational infrastructure. Existing. Analyze vendor and platform options, including build versus buy decisions, customization capabilities, support requirements, and long-term viability, that implementation strategy and ongoing operational costs. Organizational change and adoption planning. Effect. Evaluate change management requirements, including training needs, workflow modifications, stakeholder buy-in, and cultural adaptation that influence implementation success beyond technical deployment considerations. Assess user adoption factors, including ease of use, perceived value, workflow integration, and resistant sources that affect whether AI implementations achieve intended benefits through actual usage rather than just technical deployment. Consider support and maintenance requirements, including ongoing training, system updates, performance monitoring, and user assistance that ensure long-term success rather than just initial implementation achievement. Plan governance and oversight, including decision rights, performance monitoring, ethical compliance, and continuous improvement that maintain AI implementation value while addressing emerging challenges and opportunities. The Comprehensive AI Capability Mapping Framework enables strategic AI translators to identify genuine business value creation opportunities while developing realistic implementation plans that connect technology possibilities to practical organizational benefits and sustainable competitive advantage. 7.3 ROI Estimation and Business Case. Development, quantifying AI. Implementation value. Comprehensive ROI Analysis Framework for AI Investments. Return on investment calculation for AI implementations requires sophisticated financial analysis that captures both quantifiable benefits and strategic value creation while accounting for implementation costs, ongoing operational expenses, and risk factors that affect long-term value realization. Unlike traditional technology ROI calculations that focus primarily on efficiency improvements, AI ROI analysis must consider value creation through enhanced decision-making, improved customer experiences, and competitive advantage development that may be difficult to quantify precisely but critically important for strategic success. Think of AI ROI analysis like evaluating the return on investment for hiring exceptional employees who bring both measurable productivity improvements and intangible benefits like enhanced team performance, improved customer relationships, and organizational learning that contribute to long-term success in ways that simple cost-benefit calculations cannot capture completely. Similarly, AI implementations often create value through improved organizational capabilities, enhanced decision-making quality, and strategic positioning advantages that extend beyond direct cost savings or efficiency improvements. Comprehensive ROI analysis must capture these broader value creation patterns while providing realistic financial projections that support investment decision-making. Direct cost-benefit analysis and financial modeling. Systematic financial analysis provides the foundation for AI investment decisions while recognizing that quantifiable benefits represent only one component of total value creation potential. Implementation cost calculation and resource planning. Document all implementation costs including software licensing, infrastructure upgrades, professional services, internal labor, training, and project management that represent the total investment required for successful AI deployment rather than just initial technology acquisition costs. Calculate software and platform costs including licensing fees, customization expenses, integration costs, and ongoing subscription fees while considering scalability factors that affect long-term cost structures as AI usage expands throughout organizations. Assess infrastructure requirements including hardware upgrades, cloud computing capacity, data storage, and network enhancements that support AI applications while estimating both initial capital investment and ongoing operational expenses. Include professional services costs including consulting, implementation assistance, training development, and change management support that ensure successful deployment while building internal capability for ongoing AI management and optimization. Document internal labor costs including project management, technical development, user training, and ongoing support that represent opportunity costs when internal resources focus on AI implementation rather than other organizational priorities. Direct benefit quantification and value measurement. Identify measurable benefits including efficiency improvements, cost reductions, revenue enhancements, and quality improvements that can be quantified reliably while establishing baseline measurements that enable accurate benefit tracking. Calculate labor cost savings including time reduction, productivity improvements, and capacity increases that enable organizations to accomplish more with existing resources or redirect human effort toward higher value activities that generate additional revenue or strategic benefit. Assess quality improvements including error reduction, consistency enhancement, compliance improvement, and customer satisfaction increases while quantifying the financial impact of better outcomes through reduced rework, fewer complaints, and improved retention rates. Evaluate revenue enhancement including sales increases, customer acquisition improvements, retention rate improvements, and new service offerings that generate additional income through AI-enhanced capabilities and improved customer experiences. Consider cost avoidance benefits including fraud prevention, risk mitigation, compliance improvement, and operational reliability that prevent expenses rather than just reducing existing costs while creating value through problem avoidance. Payback period and break-even analysis. Calculate realistic payback periods considering both initial implementation costs and ongoing operational expenses while accounting for benefit realization timelines that may extend over multiple years as AI systems improve and organizational adoption increases. Develop break-even analysis that identifies when cumulative benefits exceed total implementation and operational costs while considering different scenarios for benefit realization speed and magnitude that affect investment recovery timelines. Assess sensitivity to key assumptions including benefit realization rates, cost escalation, usage adoption, and competitive responses that could affect actual ROI achievement while identifying factors that most significantly influence investment success. Consider cash flow implications including upfront investment requirements, benefit realization timing, and ongoing operational costs that affect organizational financial planning and resource allocation decisions beyond simple ROI calculations. Strategic value assessment and intangible benefits. Competitive advantage and market positioning value. AI implementations often create strategic value through improved competitive positioning and market advantages that may be difficult to quantify precisely but critically important for long-term organizational success and sustainability. Innovation capability and market leadership development. Assess value creation through enhanced innovation capability including faster product development, better market analysis, improved customer insight, and creative assistance that could accelerate innovation while reducing development costs and market risks. Evaluate market leadership positioning including thought leadership, customer perception, industry recognition, and competitive differentiation that AI implementations might enable while considering long-term brand value and market position enhancement. Consider customer experience improvements including personalization, responsiveness, convenience, and service quality that could increase customer satisfaction and loyalty while reducing service costs and improving retention rates that generate long-term revenue benefits. Analyze operational excellence including process optimization, quality improvement, decision-making enhancement, and organizational learning that creates sustainable competitive advantages through superior performance and capability development. Risk mitigation and organizational resilience value. Calculate risk reduction benefits including improved compliance, better security, enhanced decision-making, and operational reliability that prevent problems and reduce potential losses while building organizational resilience and adaptation capability. Assess regulatory compliance improvements including audit preparation, documentation accuracy, monitoring capabilities, and reporting efficiency that reduce compliance costs while minimizing regulatory risks and potential penalties. Evaluate security enhancements including fraud detection, threat identification, access control, and monitoring capabilities that protect organizational assets while reducing security incident costs and reputation risks. Consider operational resilience including system reliability, backup capabilities, adaptation flexibility, and crisis response that enable organizations to maintain performance despite disruptions while reducing business continuity risks. Learning and capability development value. Quantify organizational learning benefits including data analysis capability, decision-making improvement, process optimization, and innovation acceleration that build long-term competitive advantages through enhanced organizational intelligence and adaptation capability. Assess workforce development including skill enhancement, productivity improvement, job satisfaction, and career development that create value through improved human performance and retention while reducing recruitment and training costs. Evaluate knowledge management improvements including information access, expertise sharing, decision support, and institutional memory that enhance organizational capability while reducing knowledge loss risks and decision-making errors. Consider culture change benefits including innovation orientation, data-driven decision-making, continuous improvement, and change adaptation that create sustainable competitive advantages through enhanced organizational capability and responsiveness. Business case development and stakeholder communication. Executive presentation and decision-making support. Comprehensive business cases must translate complex ROI analysis into clear, compelling presentations that support executive decision-making while addressing stakeholder concerns and implementation planning requirements. Strategic alignment communication and value proposition. Connect AI implementation opportunities to specific organizational strategic objectives including growth targets, efficiency goals, customer satisfaction improvements, and competitive positioning while demonstrating clear alignment with business priorities. Present value propositions that resonate with different stakeholder groups including financial benefits for CFOs, competitive advantages for CEOs, operational improvements for COOs, and innovation opportunities for strategy teams while maintaining consistent overall messaging. Address stakeholder concerns including implementation risks, resource requirements, change management challenges, and performance measurement while providing realistic assessments and mitigation strategies that build confidence in implementation success. Create compelling narratives that connect AI capabilities to specific business outcomes while using analogies and examples. Help non-technical that implementation value and strategic importance. Stakeholders. Risk assessment and mitigation planning. Understand. Document implementation risks including technical challenges, organizational resistance, resource constraints, and competitive responses while providing mitigation strategies that reduce risk probability and impact on investment success. Assess market risks including competitive responses, customer acceptance, regulatory changes, and technology evolution that could affect AI implementation value while developing adaptation strategies that maintain competitive advantage. Consider operational risks including system reliability, integration challenges, user adoption, and ongoing support requirements while planning contingency approaches that ensure implementation success despite potential obstacles. Evaluate financial risks including cost overruns, benefit realization delays, market changes, and organizational priorities that could affect investment returns while developing monitoring and adaptation approaches that protect investment value. Implementation planning and success measurement. Develop realistic implementation timelines including pilot testing, gradual rollout, training completion, and full deployment that enable stakeholder planning while setting appropriate expectations for benefit realization timing. Create success measurement frameworks including key performance indicators, milestone achievement, benefit tracking, and return on investment monitoring that enable progress evaluation while supporting continuous improvement and optimization. Plan resource allocation including budget requirements, personnel assignments, infrastructure investments, and ongoing support that enable successful implementation while maintaining organizational focus on other strategic priorities. Design governance structures including decision rights, oversight responsibilities, progress reporting, and adaptation procedures that ensure implementation success while maintaining stakeholder engagement and support throughout deployment and optimization phases. The comprehensive ROI estimation and business case development framework enables strategic AI translators to create compelling investment justifications while providing realistic financial projections and implementation planning that support successful AI adoption and value realization. 7-point for multi-stakeholder communication. Mastery, executive, technical, and end user. Translation skills. Understanding requirements, multi-audience communication. Effective AI implementation requires ongoing communication among stakeholders who speak different professional languages, prioritize different objectives, and measure success using different criteria. Strategic AI translators must become fluent in multiple organizational dialects while serving as communication bridges that enable productive collaboration despite different backgrounds and priorities. Imagine serving as a diplomatic interpreter during complex international negotiations where participants from different countries must reach agreements despite different languages, cultural values, and political objectives. The interpreter needs more than linguistic translation skills. They must understand cultural contexts, recognize underlying interests, and facilitate communication that builds understanding rather than just preventing misunderstandings. Similarly, AI implementation requires professionals who can facilitate communication among business executives focused on strategic value, technical teams concerned with implementation feasibility, end users worried about workflow changes, and compliance specialists responsible for risk management. Each group has legitimate priorities that must be understood and integrated rather than dismissed or oversimplified. Executive communication strategy and strategic value articulation. Senior leadership audiences require communication that connects AI initiatives to strategic objectives while providing sufficient detail to enable informed decision-making without overwhelming busy executives with technical complexity or operational minutiae. Strategic value proposition development and business impact communication. Frame AI implementations within broader business strategy including competitive positioning, market opportunities, customer experience enhancement, and operational excellence while demonstrating clear alignment with organizational priorities and performance objectives. Connect AI capabilities to specific executive concerns including revenue growth, cost management, risk mitigation, competitive advantage, and market positioning while using metrics and language that resonate with strategic decision-making frameworks. Present AI opportunities as strategic investments that create sustainable competitive advantages rather than just operational improvements while addressing executive questions about resource allocation, priority setting, and strategic focus. Emphasize business outcomes and strategic impact rather than technical features while providing sufficient detail about implementation requirements and timeline expectations that enable realistic planning and resource allocation decisions. Risk and opportunity assessment for leadership decision-making. Address executive concerns about AI implementation including investment requirements, competitive risks, organizational change implications, and performance measurement while providing balanced assessment of opportunities and challenges. Present risk mitigation strategies including pilot testing, phased implementation, vendor evaluation, and performance monitoring that demonstrate thoughtful planning while building executive confidence in implementation success probability. Discuss competitive implications including market positioning, customer expectations, talent acquisition, and industry trends that affect strategic importance of AI capability development while positioning implementation as essential rather than optional. Provide realistic timeline and resource estimates including implementation phases, milestone achievements, and benefit realization schedules that enable strategic planning while setting appropriate expectations about investment recovery and value creation timing. Board and investor communication for AI strategy approval. Develop presentations for board-level audiences that emphasize governance, strategic alignment, competitive necessity, and long-term value creation while addressing fiduciary responsibility and stakeholder value concerns. Present AI strategy within industry context including market trends, competitive pressures, customer expectations, and regulatory developments that demonstrate strategic necessity while providing comparative analysis of organizational positioning. Address governance and oversight including decision frameworks, performance monitoring, risk management, and ethical compliance that demonstrate responsible management while building confidence in strategic implementation capability. Connect AI investments to long-term value creation including market leadership, competitive differentiation, operational excellence, and innovation capability that justify strategic investment while supporting sustainable competitive advantage development. Technical team communication and implementation coordination. Technical feasibility and architecture communication. Technical audiences need detailed information about implementation requirements, system architecture, and integration challenges while understanding business objectives and constraints that affect technical design decisions. Business requirements technical implementation translation 4. Translate business objectives into technical specifications including performance requirements, integration needs, user experience expectations, and success criteria while ensuring that technical solutions address actual business problems rather than just demonstrating technical sophistication. Communicate business constraints including budget limitations, timeline expectations, regulatory requirements, and organizational policies that affect technical design decisions. While helping technical teams understand implementation context and priority factors. Explain business value creation including customer impact, operational improvement, competitive advantage, and strategic positioning that justify technical investment while helping technical teams understand why certain features or approaches create more business value than alternatives. Present business stakeholder priorities including user experience, performance reliability, security requirements, and maintenance considerations that should guide technical decision-making while ensuring that technical solutions serve business objectives effectively. System architecture and integration planning communication. Discuss technical architecture including data requirements, system integration, performance specifications, and scalability planning while connecting technical decisions to business objectives and stakeholder needs. Address integration challenges including existing system compatibility, data migration, security requirements, and user access management while explaining business impact of different technical approaches and timeline implications. Present platform and vendor options including build versus buy analysis, customization capabilities, support requirements, and long-term viability while connecting technical considerations to business value and strategic alignment. Explain performance monitoring and optimization including success metrics, system reliability, user experience measurement, and continuous improvement approaches that ensure technical implementation delivers intended business value. Development team coordination and project management. Facilitate communication between business stakeholders and technical teams including requirement clarification, progress reporting, issue resolution, and priority adjustment while maintaining focus on business value delivery and stakeholder satisfaction. Coordinate user acceptance testing including business user involvement, feedback integration, and requirement validation while ensuring that technical development meets actual business needs rather than just specified technical requirements. Manage scope changes and requirement evolution including business need clarification, impact assessment, priority adjustment, and timeline modification while maintaining project momentum and stakeholder alignment. Communicate project status including milestone achievement, challenge identification, resource requirements, and timeline adjustments while maintaining stakeholder confidence and support for continued implementation investment. End-user communication and adoption facilitation. Change management communication and user experience. End users need clear understanding of how AI implementations will affect their daily work while receiving support and training that enables successful adaptation to AI-enhanced workflows. Workflow change training development communication and explain workflow modifications including new procedures, tool usage, decision-making processes, and collaboration patterns while emphasizing how changes enhance rather than complicate job performance and professional effectiveness. Address user concerns including job security, skill requirements, learning challenges, and performance expectations while providing realistic assessment of change impact and available support resources. Develop training materials including step-by-step guides, practice exercises, troubleshooting resources, and ongoing support that enable successful user adoption while building confidence and competence with AI-enhanced workflows. Create feedback systems including user input collection, concern resolution, suggestion integration, and continuous improvement that enable user participation in AI optimization while building ownership and engagement with implementation success. User experience design system communication and support. Present AI tools as capability enhancement including decision support, information access, task automation, and workflow optimization that improve job performance rather than replacing human judgment and expertise. Explain AI system limitations including accuracy expectations, appropriate usage, error handling, and escalation procedures while building realistic expectations and appropriate reliance levels rather than overdependence or underutilization. Provide ongoing support including help resources, troubleshooting assistance, performance feedback, and skill development that enable continued user success while building internal capability for AI optimization and adaptation. Design recognition and celebration programs including success story sharing, achievement acknowledgement, and peer learning that build positive culture around AI adoption while encouraging continued engagement and improvement. Customer communication and external stakeholder engagement. When AI implementations affect customer experience or external stakeholder interactions, communication must address benefits, limitations, and alternatives while maintaining trust and satisfaction. Customer experience enhancement communication. Explain customer benefits including improved service quality, faster response times, personalized recommendations, and enhanced convenience while addressing potential concerns about automated interactions and data usage. Provide clear information about AI system capabilities and limitations, including what customers can expect when human assistance is available, and how to escalate issues while building appropriate expectations and satisfaction levels. Offer customer choice, including AI-enhanced and traditional service options, while respecting customer preferences and comfort levels with automated systems without creating service quality disparities. Create customer education, including tool usage, benefit realization, feedback provision, and support access that enable customers to benefit from AI enhancements while maintaining satisfaction with service experience. The comprehensive multi-stakeholder communication framework enables strategic AI translators to facilitate productive dialogue among diverse organizational groups while building support for AI implementation that serves multiple stakeholder interests and creates sustainable organizational value. 7.5 Strategic Prioritization Frameworks. Sequencing AI initiatives for maximum impact. Comprehensive for prioritization AI implementation methodology. Strategic prioritization of AI initiatives requires balancing multiple factors, including business value potential, implementation complexity, organizational readiness, and resource constraints, while considering how different AI projects can build upon each other to create cumulative strategic advantage. Unlike simple ranking approaches that evaluate each opportunity independently, effective AI prioritization must consider interdependencies, learning opportunities, and capability building that enable increasingly sophisticated implementations over time. Think of AI initiative prioritization like planning a comprehensive urban development strategy where early projects must create infrastructure and capabilities that enable more ambitious later developments while generating immediate value that justifies continued investment. Early projects might focus on basic infrastructure like roads and utilities that enable later developments like commercial districts and cultural centers, but each phase must create value while building toward the overall vision. Similarly, AI initiative sequencing should begin with implementations that build foundational capabilities and demonstrate value while creating learning opportunities and stakeholder support that enable more complex and strategic AI. Applications. The prioritization framework must balance quick wins that build momentum with strategic investments that create long-term competitive advantage. Multi-criteria decision analysis for AI opportunity evaluation. Effective prioritization requires systematic evaluation across multiple dimensions rather than simple benefit-cost analysis or subjective ranking that might miss important implementation factors or strategic considerations. Business value and strategic impact assessment. Evaluate potential business value, including revenue enhancement, cost reduction, competitive advantage, customer experience improvement, and operational efficiency while considering both quantifiable benefits and strategic positioning value that may be difficult to measure precisely. Assess strategic alignment, including connection to organizational objectives, competitive necessity, market positioning, and long-term vision while prioritizing initiatives that advance strategic goals rather than just creating operational improvements. Consider competitive implications, including market leadership opportunities, customer expectation management, talent attraction, and industry positioning while evaluating whether initiatives create sustainable advantages or just temporary efficiency improvements. Analyze market timing, including customer readiness, competitive pressure, regulatory environment, and technology maturity while identifying initiatives that capitalize on market opportunities or address competitive threats effectively. Implementation complexity and resource requirement analysis. Evaluate technical complexity, including data requirements, system integration, infrastructure needs, and development effort while considering organizational technical capability and available resources for successful implementation. Assess organizational change requirements, including training needs, workflow modifications, stakeholder buy-in, and cultural adaptation while considering change management capability and organizational readiness for different types of transformation. Consider resource allocation including budget requirements, personnel assignments, infrastructure investments, and ongoing support while evaluating organizational capacity and competing priorities that affect implementation feasibility. Analyze timeline requirements including development phases, testing periods, deployment schedules, and benefit realization while considering organizational urgency and stakeholder expectations for value delivery. Risk assessment and success probability evaluation. Document implementation risks including technical challenges, organizational resistance, resource constraints, and external factors while evaluating risk mitigation possibilities and overall success probability for different initiatives. Assess market risks including competitive responses, customer acceptance, regulatory changes, and technology evolution while considering adaptation flexibility and strategic positioning protection despite environmental uncertainty. Consider operational risks including system reliability, integration challenges, user adoption, and ongoing support while evaluating organizational capability for risk management and problem resolution throughout implementation and operation. Evaluate strategic risks including reputation impact, competitive exposure, resource commitment, and opportunity costs while considering portfolio effects and strategic option preservation that affect long-term organizational flexibility. Sequencing strategy optimization. Foundation building prioritization. Development and portfolio. And capability development. Strategic AI implementation requires building organizational capabilities progressively while creating early success experiences that generate stakeholder support and learning opportunities for more complex future initiatives. Data infrastructure foundation development and analytics. Prioritize initiatives that build data collection, integration, and analysis capabilities including data warehouse development, analytics infrastructure, and measurement systems that enable future AI applications while creating immediate value through improved decision-making. Invest in data quality improvement including cleansing, standardization, integration, and governance that create foundation for reliable AI applications while improving current business intelligence and reporting capabilities. Develop analytics capabilities including descriptive analysis, predictive modeling, and performance measurement that build organizational comfort with data-driven decision-making while creating skills and infrastructure for AI implementation. Create measurement and monitoring systems including key performance indicators, dashboard development, and automated reporting that provide foundation for AI performance tracking while improving current operational visibility and management capability. Organizational learning and change management capability building. Begin with AI implementations that build organizational learning including pilot projects, training programs, and knowledge sharing that create comfort with AI technology while developing internal expertise and change management capability. Focus on user experience improvement including interface design, workflow optimization, and training development that build positive associations with AI technology while creating change management expertise for larger implementations. Develop internal expertise including technical skills, business analysis capability, and project management experience that enable increasingly complex AI implementations while reducing dependence on external resources and building sustainable capability. Create communication and stakeholder engagement capabilities including presentation skills, business case development, and resistance management that support AI adoption while building change leadership capability throughout the organization. Quick wins and momentum building strategy. Identify AI initiatives that can demonstrate value quickly including automation of routine tasks, simple decision support, and customer experience improvements that build stakeholder enthusiasm while creating foundation for more complex applications. Select implementations with high visibility including customer-facing applications, executive reporting, and process improvements that create organizational awareness while building support for continued AI investment and development. Choose applications with clear success metrics including efficiency improvements, cost reductions, and customer satisfaction increases that enable objective evaluation while building confidence in AI value creation potential. Prioritize initiatives with manageable scope including well-defined problems, limited integration requirements, and straightforward implementation that enable learning and capability building without overwhelming organizational capacity. Resource allocation and timeline optimization. Portfolio balance and resource distribution strategy. Effective AI initiative prioritization must consider portfolio effects including resource distribution, capability building, and risk management across multiple projects rather than just optimizing individual initiatives independently. Short-term and long-term value balance. Balance initiatives that create immediate value including efficiency improvements and cost reductions with strategic investments that build long-term competitive advantage including innovation capability and market positioning enhancement. Allocate resources between proven applications that offer reliable returns and experimental initiatives that could create breakthrough advantages while managing overall portfolio risk and return expectations. Sequence implementations to maintain stakeholder support including regular value delivery and success demonstration while building towards strategic objectives that require sustained investment and organizational commitment. Plan capability development including skill building, infrastructure investment, and process improvement that enable increasingly sophisticated AI applications while creating immediate value through foundational improvements. Resource optimization and constraint management. Optimize resource allocation including budget distribution, personnel assignments, and infrastructure utilization while considering organizational capacity constraints and competing priorities that affect implementation success. Coordinate timing to minimize resource conflicts including personnel availability, infrastructure capacity, and management attention while maximizing learning transfer and capability building across multiple initiatives. Plan vendor relationships including partnership development, contract negotiation, and capability building that create cost-effective access to expertise while building internal capability and reducing long-term dependence. Design scalability including infrastructure planning, process development, and capability building that enable expansion of successful initiatives while maintaining efficiency and effectiveness as AI adoption scales throughout the organization. Success measurement and adaptation planning. Create measurement frameworks including success criteria, milestone tracking, and performance monitoring that enable objective evaluation while supporting continuous improvement and strategic adaptation based on implementation experience. Design feedback systems including stakeholder input, user experience evaluation, and performance analysis that inform prioritization adjustment while maintaining strategic focus and resource allocation efficiency. Plan adaptation procedures including scope modification, resource reallocation, and priority adjustment that enable response to changing circumstances while maintaining strategic direction and implementation momentum. Establish governance structures including decision frameworks, oversight responsibilities, and communication processes that ensure strategic alignment while enabling tactical flexibility and responsive adaptation to implementation learning and environmental changes. The comprehensive strategic prioritization framework enables organizations to sequence AI initiatives for maximum cumulative impact while building capabilities and stakeholder support that enable increasingly sophisticated and strategic AI implementations over time. 7.6 Competitive analysis and market positioning, understanding AI as strategic advantage. Strategic AI Competitive Intelligence Framework. Understanding AI as a source of competitive advantage requires systematic analysis of how AI capabilities affect industry dynamics, customer expectations, and competitive positioning while identifying opportunities for differentiation that create sustainable market advantages. Unlike traditional competitive analysis that focuses on existing products and services, AI competitive intelligence must anticipate how emerging technologies will reshape competitive landscapes and create new sources of value creation. Consider how the emergence of e-commerce fundamentally changed retail competition by enabling new business models, customer experience approaches, and operational efficiencies that traditional retailers couldn't match without significant transformation. Early e-commerce adopters gained competitive advantages that persist decades later because they built capabilities and market positions that competitors couldn't easily replicate. Similarly, AI adoption creates opportunities for competitive differentiation through enhanced customer experiences, superior operational efficiency, innovative service offerings, and data-driven decision-making that can establish sustainable market advantages. However, competitive advantage depends on strategic implementation that leverage AI capabilities in ways that competitors cannot easily copy rather than just adopting AI technology for marginal improvements. Industry AI adoption competitive benchmarking analysis and effective competitive analysis requires understanding both current AI adoption patterns within industries and emerging trends that signal future competitive dynamics and strategic opportunities. Competitive AI implementation assessment and capability mapping. Analyze competitor AI initiatives including customer-facing applications, operational improvements, and strategic investments while evaluating implementation sophistication and business impact rather than just technology adoption announcements. Introduction of Chapter 8. This chapter focusing on the technical pillar that transforms strategic AI visions into production-ready systems. The chapter covers 6 critical technical competency areas. 8.1 Systems Architecture Thinking _ Designing AI solutions that integrate seamlessly with existing enterprise infrastructure while meeting security, compliance, and scalability requirements. 8.2 Production Readiness Framework _ Building reliable, scalable systems with comprehensive error handling, performance optimization, and quality assurance procedures. 8.3 Enterprise Integration Methodology _ Sophisticated API design, data pipeline architecture, and security frameworks that enable AI systems to work within complex organizational environments. 8.4 Multimodal AI Architecture _ Coordinating multiple AI capabilities through intelligent optimization and result integration. 8.5 Orchestration, Resource, Performance Monitoring and Optimization _ Comprehensive monitoring frameworks with predictive analytics and continuous improvement cycles. 8.6 Deployment Pipeline Development _ Complete lifecycle management from prototype through production deployment to long-term maintenance. Each section provides detailed frameworks, practical methodologies, and implementation guidance that enables participants to become the technical foundation for organizational AI success. The chapter emphasizes that implementation engineers must balance innovation with reliability, creating production systems that organizations can depend on rather than just impressive demonstrations. Chapter 8. Pillar 2: Implementation Engineers Development. Learning objectives. By the end of this chapter, you will understand how to develop professionals who can transform AI strategic visions into reliable, production-ready systems that operate effectively within complex enterprise environments. You will master frameworks for systems architecture design, production, readiness assessment, enterprise integration planning, multimodal coordination, performance optimization, and deployment pipeline development that enable participants to bridge the critical gap between AI prototypes and business-critical applications. Think of this chapter as the Master Engineer's Handbook for professionals who must design and build infrastructure that serves diverse stakeholders while meeting exacting standards for reliability, security, and performance. Just as civil engineers must understand both structural possibilities and environmental constraints while designing bridges that safely carry traffic under all conditions, implementation engineers must understand both AI technical capabilities and organizational realities while creating systems that deliver consistent value under real-world operational pressures. The frameworks and methodologies in this chapter will transform participants from individuals who can build AI demonstrations into professionals who can create production systems that organizations depend on for critical business operations while maintaining performance, security, and reliability over time. 8.1 Systems Architecture Thinking. Designing AI solutions within enterprise. Infrastructure. Understanding enterprise system architecture for AI integration. Designing AI solutions for enterprise environments requires sophisticated understanding of how AI components integrate with existing technology infrastructure while meeting organizational requirements, scalability, and for maintainability. Security. Unlike compliance, academic or experimental AI development that focuses primarily on model performance, enterprise AI architecture must balance technical optimization with operational constraints including data governance, system reliability, user access management, and regulatory compliance. Imagine an urban planner designing a new transportation system for a major city who must consider not only efficient movement of people but also integration with existing infrastructure, environmental impact, budget constraints, maintenance requirements, and diverse stakeholder needs. The planner cannot simply optimize for speed or capacity but must create solutions that work within complex existing systems while serving multiple constituencies effectively. Similarly, implementation engineers must design AI systems that integrate seamlessly with existing enterprise infrastructure while meeting diverse organizational requirements for performance, security, compliance, and user experience. This requires both technical expertise and systems thinking that considers how AI components affect broader organizational technology ecosystems. Enterprise Architecture Assessment and Integration Planning _ Effective AI system design begins with comprehensive understanding of existing enterprise architecture including data flows, security frameworks, integration patterns, and operational procedures that AI implementations must work within rather than disrupt. Infrastructure Landscape Analysis and Constraint Identification _ Document existing technology infrastructure including servers, databases, networks, security systems, and application platforms while identifying capacity constraints, compatibility requirements, and integration points that affect AI implementation possibilities. Assess data architecture including storage systems, database technologies, data warehouses, and analytics platforms while evaluating data access patterns, update frequencies, and quality standards that determine AI implementation feasibility and performance requirements. Evaluate security frameworks including authentication systems, authorization protocols, network protection, and compliance monitoring while understanding how AI systems must integrate with existing security infrastructure without creating vulnerabilities or policy violations. Analyze network architecture including bandwidth availability, latency requirements, geographic distribution, and connectivity patterns while determining how AI systems can operate effectively within existing network constraints and performance expectations. Document integration standards including API protocols, data formats, messaging systems, and service architectures while understanding how AI components must conform to existing integration patterns and organizational technology standards. Scalability and performance planning for AI workloads _ Design AI system architecture that can scale effectively as organizational usage increases while maintaining performance standards and operational efficiency within infrastructure capacity and budget constraints. Existing. Plan computing resource allocation including processing power, memory requirements, storage capacity, and graphics processing units while optimizing costs and ensuring that AI workloads don't negatively impact other organizational systems and applications. Design data pipeline architecture including ingestion, transformation, storage, and retrieval systems that can handle increasing data volumes while maintaining quality standards and meeting performance requirements for real-time and batch processing needs. Implement caching and optimization strategies including intelligent data storage, computational optimization, and result caching that reduce system load while improving response times and user experience for AI-powered applications and services. Create load balancing and distribution approaches including geographic distribution, redundancy planning, and failover. Procedures that ensure consistent AI system performance despite varying usage patterns and potential infrastructure disruptions. Security and compliance integration framework _ Integrate AI systems with existing security infrastructure including identity management, access control, audit logging, and threat detection while ensuring that AI implementations enhance rather than compromise organizational security posture. Implement data protection protocols including encryption, access logging, data masking, and privacy protection that ensure AI systems handle sensitive information appropriately while complying with organizational policies and regulatory requirements. Design audit and monitoring capabilities including system activity logging, performance tracking, decision recording, and compliance reporting that enable oversight and accountability while supporting continuous improvement and regulatory compliance. Create incident response procedures including security breach protocols, system failure responses, and data compromise management that ensure AI systems can be secured and restored quickly while minimizing business impact and maintaining stakeholder confidence. AI-specific architecture patterns and design principles. Modular for AI components _ and microservices architecture. Modern AI system architecture benefits from modular design approaches that separate AI capabilities into discrete, manageable components that can be developed, deployed, and maintained independently while working together to create comprehensive solutions. Service-oriented AI architecture design _ Decompose AI functionality into discrete services including data pre-processing, model inference, result post-processing, and user interface components that can be developed and maintained separately while working together through well-defined interfaces and protocols. Design API-first architecture including clear service interfaces, standardized data formats, and consistent communication protocols that enable different AI components to work together while allowing independent development and optimization of individual services. Implement containerization and orchestration including Docker containers, Kubernetes management, and automated deployment that enable consistent AI service deployment across different environments while simplifying management and scaling of complex AI systems. Create service discovery and coordination including automatic service registration, health monitoring, and load balancing that enable AI systems to adapt to changing conditions while maintaining service availability and performance standards. Data flow architecture and pipeline design _ Design data ingestion pipelines including batch processing, real-time streaming, and hybrid approaches that can handle diverse data sources while ensuring quality, security, and compliance throughout the data processing lifecycle. Implement data transformation and enrichment including cleansing, normalization, feature engineering, and quality validation that prepare data for AI processing while maintaining data lineage and enabling reproducible results. Create data storage strategies including operational databases, analytical data warehouses, and AI-specific storage that optimize data access patterns while ensuring data availability, backup procedures, and disaster recovery capabilities. Design result storage and retrieval including prediction databases, model outputs, and historical results that enable AI system monitoring and analysis while supporting business intelligence and decision-making processes. Model management and versioning architecture _ Implement model lifecycle management, including development environments, testing frameworks, version control, and deployment procedures that ensure AI models can be updated and improved while maintaining system stability and performance. Create model-serving infrastructure, including inference engines, caching systems, and load balancing that enable efficient model execution while supporting multiple models and ensuring consistent performance under varying usage patterns. Design A/B testing and experimentation frameworks, including traffic splitting, performance measurement, and statistical analysis that enable safe model updates while measuring performance improvements and business impact of model changes. Implement model monitoring and alerting, including performance tracking, drift detection, and automated notifications that enable proactive model management while ensuring AI systems continue performing effectively as conditions change. Integration with enterprise systems and legacy infrastructure. Legacy system integration and modernization strategy _. Most enterprise AI implementations must work within environments that include legacy systems, established workflows, and existing data structures that cannot be easily modified but must be integrated with AI capabilities effectively. API development and integration patterns _. Design RESTful APIs, including standardized endpoints, consistent data formats, and comprehensive documentation that enable AI systems to integrate with existing applications while providing reliable, predictable interfaces for both human and system users. Implement GraphQL interfaces, including flexible data querying, efficient network usage, and real-time updates that enable sophisticated AI system integration while optimizing performance and reducing network overhead for complex data retrieval operations. Create webhook and event-driven integration, including real-time notifications, asynchronous processing, and event streaming that enable AI systems to respond to business events while maintaining loose coupling and system independence. Design batch integration patterns, including scheduled data transfers, bulk processing, and file-based exchange that enable AI systems to work with legacy systems while maintaining data consistency and ensuring reliable information exchange. Database integration and data management _. Implement database connectivity, including connection pooling, query optimization, and transaction management that enable AI systems to access enterprise data while maintaining performance standards and ensuring data consistency and integrity. Design data synchronization strategies, including real-time replication, change data capture, and eventual consistency that ensure AI systems have access to current information while managing complexity and maintaining system performance. Create data abstraction layers, including object relational mapping, data access objects, and query builders that simplify AI system data access while providing flexibility and maintainability for complex enterprise data environments. Implement caching strategies, including distributed caching, intelligent invalidation, and performance optimization that reduce database load while ensuring AI systems have fast access to frequently used data and maintaining data consistency. Workflow and business process integration _. Design workflow integration, including business process automation, approval workflows, and task management that enable AI systems to participate in existing business processes while maintaining human oversight and decision-making authority. Implement notification and alerting systems, including email integration, messaging platforms, and dashboard updates that ensure AI system outputs reach appropriate stakeholders while maintaining communication patterns and organizational protocols. Create reporting and analytics integration, including business intelligence platforms, dashboard systems, and automated reporting that enable AI insights to inform decision-making while fitting into existing management and reporting structures. Design user interface integration, including single sign-on, consistent design patterns, and seamless navigation that enable users to access AI capabilities within familiar interfaces while maintaining security protocols and user experience standards. 8.2 Production Readiness Framework. Building reliable, scalable AI systems. Comprehensive production readiness assessment. Moving AI systems from development environments to production deployment requires systematic evaluation of reliability, performance, security, and maintainability factors that determine whether AI implementations can operate successfully under real-world conditions with diverse users and changing requirements. System reliability and fault tolerance design underscore. Production AI systems must operate consistently despite hardware failures, network disruptions, user errors, and unexpected inputs that commonly occur in enterprise environments but are rarely encountered during development and testing phases. Error handling and recovery mechanisms underscore. Implement comprehensive error detection including input validation, processing monitoring, and output verification that identify problems quickly while providing meaningful feedback to users and administrators about system status and required actions. Design graceful degradation including fallback procedures, reduced functionality modes, and alternative processing paths that maintain system availability despite component failures while providing essential services and preserving user experience quality. Create automated recovery procedures including system restart capabilities, data backup restoration, and service restoration that minimize downtime while ensuring data integrity and system consistency after failures or disruptions. Implement circuit breaker patterns including failure detection, automatic service isolation, and gradual recovery that prevent cascade failures while protecting system stability and enabling recovery from intervention. Temporary problems without manual. Performance optimization and resource management underscore. Design performance monitoring including response time tracking, throughput measurement, and resource utilization analysis that enable proactive optimization while identifying bottlenecks and performance degradation before they affect user experience. Implement resource optimization including memory management, CPU utilization, and storage efficiency that ensure AI systems operate within available resources while maintaining performance standards and avoiding resource conflicts with other systems. Create load management including request queuing, priority processing, and resource allocation that handle varying usage patterns while maintaining service quality and ensuring fair access for different user groups and application requirements. Design auto-scaling capabilities including automatic resource provisioning, load-based scaling, and cost optimization that adapt to changing demand while maintaining performance standards and controlling operational costs effectively. Security hardening and threat protection underscore. Implement defense in-depth security including multiple protection layers, access controls, and threat detection that protect AI systems against various attack vectors while maintaining usability and system performance for legitimate users. Design secure communication including encryption protocols, certificate management, and secure key storage that protect data in transit while ensuring secure integration with other enterprise systems and maintaining compliance requirements. Create access control and authentication including user verification, authorization frameworks, and session management that ensure appropriate access while maintaining security standards and supporting diverse user roles and responsibilities. Implement security monitoring and incident response including threat detection, anomaly identification, and automated response that protect against security breaches while enabling rapid response to potential threats and security incidents. Quality assurance and testing frameworks. Comprehensive testing strategy for AI systems underscore. AI systems require specialized testing approaches that address both traditional software quality concerns and AI-specific challenges including model accuracy, bias detection, and performance under diverse conditions and unexpected inputs. Functional testing and validation procedures underscore. Design unit testing including individual component verification, mock data testing, and isolated functionality validation that ensure AI system components work correctly while enabling identification. Systematic debugging and problem. Implement integration testing including system component interaction, data flow validation, and end-to-end processing verification that ensure AI systems work correctly within enterprise environments and maintain data integrity throughout processing workflows. Create user acceptance testing including stakeholder validation, workflow testing, and business requirement verification that ensure AI systems meet actual user needs while delivering intended business value and maintaining user satisfaction standards. Design regression testing including automated test suites, performance benchmarking, and functionality verification that ensure system updates and modifications don't introduce problems while maintaining consistent quality and performance over time. AI-specific testing and validation methods _. Implement model accuracy testing including prediction validation, error analysis, and performance measurement that ensure AI models perform reliably while meeting business requirements for accuracy and maintaining quality standards across different use cases. Design bias and fairness testing including demographic analysis, outcome evaluation, and ethical assessment that ensure AI systems provide fair results while complying with regulatory requirements and maintaining organizational values and ethical standards. Create edge case testing including boundary condition analysis, unusual input handling, and stress testing that ensure AI systems handle unexpected situations while maintaining system stability and providing appropriate responses to unusual conditions. Implement A/B testing frameworks including statistical analysis, performance comparison, and impact measurement that enable safe deployment of AI improvements while measuring business impact and ensuring changes create positive value for users and organizations. Performance and load testing procedures _. Design load testing including concurrent user simulation, peak usage modeling, and resource utilization measurement that ensure AI systems can handle expected usage while maintaining performance standards and avoiding system overload. Implement stress testing including extreme condition simulation, failure point identification, and recovery validation that determines system limits while ensuring graceful degradation and recovery capabilities under adverse conditions. Create endurance testing including long-term operation validation, memory leak detection, and stability analysis that ensure AI systems maintain performance over extended periods while identifying potential problems before they affect production operations. Design scalability testing including growth simulation, resource requirement analysis, and performance projection that ensure AI systems can expand to meet growing demands while maintaining efficiency and cost-effectiveness as usage increases. Monitoring and observability implementation. Comprehensive system monitoring and alerting _. Production AI systems require sophisticated monitoring that provides visibility into system performance, user experience, business impact, and technical health while enabling proactive problem identification and resolution. Real-time performance monitoring and metrics collection _. Implement application performance monitoring including response time tracking, error rate measurement, and user experience analysis that provide real-time visibility into system performance while enabling quick identification and resolution of problems affecting users. Design infrastructure monitoring including server performance, network utilization, and resource consumption that ensure underlying systems support AI applications while identifying capacity constraints and performance bottlenecks before they affect service quality. Create business metrics monitoring including usage analytics, conversion tracking, and value measurement that connect AI system performance to business outcomes while enabling optimization and demonstrating return on investment for stakeholders. Implement custom metrics collection including AI-specific measurements, domain-relevant indicators, and business process tracking that provide insights into AI system effectiveness while supporting continuous improvement and optimization efforts. Alerting and incident management systems _. Design intelligent alerting including threshold-based notifications, anomaly detection, and escalation procedures that notify appropriate personnel about problems while minimizing false alarms and ensuring rapid response to critical issues. Implement incident classification including severity assessment, impact analysis, and response prioritization that ensure appropriate resource allocation while maintaining service quality and minimizing business impact from system problems. Create on-call procedures including responsibility assignment, escalation paths, and communication protocols that ensure rapid response to system issues while maintaining coverage and enabling effective problem resolution at all times. Design post-incident investigation, analysis including root cause improvement identification, and process enhancement that prevent recurring problems while building organizational learning and improving system reliability over time. Data and model monitoring for AI systems _ Implement data quality monitoring including accuracy validation, completeness checking, and freshness assessment that ensure AI systems receive reliable input while identifying data problems before they affect model performance and business outcomes. Design model performance tracking including prediction accuracy, confidence measurement, and outcome validation that ensure AI models continue performing effectively while identifying degradation and optimization opportunities. Create data drift detection including input distribution monitoring, feature analysis, and model relevance assessment that identify when AI models need updating while maintaining performance standards and business value delivery. Implement feedback loop monitoring including user interaction tracking, outcome measurement, and continuous learning assessment that enable AI system improvement while measuring business impact and user satisfaction with AI-powered capabilities. 8.3 Enterprise Integration Methodology. API Management, Data Flow, and Security. Considerations. API Design and Management Framework. Enterprise AI systems must integrate with diverse applications, services, and data sources through well-designed APIs that provide reliable, secure, and performant interfaces while maintaining compatibility with existing enterprise architecture and supporting requirements. Future expansion and modification. RESTful API architecture and design principles _ Modern enterprise integration relies heavily on RESTful APIs that provide standardized, predictable interfaces for AI system integration while supporting diverse client applications and enabling loose coupling between system components. Resource-oriented API design and implementation _ Design API resources including data entities, service capabilities, and functional operations that align with business concepts while providing intuitive interfaces that developers can understand and use effectively without extensive documentation or training. Implement HTTP method conventions including GET for data retrieval, POST for creation, PUT for updates, and DELETE for removal that follow industry standards while providing predictable behavior and enabling client application development using familiar patterns. Create URI structure including hierarchical resource organization, query parameter usage, and path construction that enable intuitive navigation while supporting complex queries and maintaining backward compatibility as APIs evolve and expand. Design response formats including consistent data structures, error handling, and metadata inclusion that provide comprehensive information while enabling efficient client processing and maintaining compatibility across different programming languages and frameworks. API versioning and evolution strategy _ Implement semantic versioning including major, minor, and patch version numbering that communicate API changes clearly, while enabling client applications to manage compatibility and plan for updates appropriately. Design backward compatibility including deprecated feature support, migration pathways, and transition periods that enable smooth API evolution while minimizing disruption to existing client applications and maintaining service continuity. Create API documentation including comprehensive reference materials, usage examples, and integration guides that enable effective API adoption while providing developers with information needed troubleshooting. For successful integration and Implement change management including notification procedures, migration assistance, and support resources that help API consumers adapt to changes while maintaining system integration quality and minimizing implementation problems. Security and authentication implementation _. Design authentication mechanisms including API key management, OAuth 2.0 implementation, and JWT token handling that provide secure access while supporting diverse client types and maintaining usability for legitimate users and applications. Implement authorization frameworks including role-based access control, permission management, and resource-level security that ensure appropriate access while protecting sensitive data and maintaining compliance with organizational policies and regulations. Create rate limiting and throttling including usage quotas, request prioritization, and abuse prevention that protect API resources while ensuring fair access and maintaining service quality for all authorized users and applications. Design audit logging including request tracking, user identification, and activity monitoring that provide security oversight while enabling compliance reporting and supporting investigation of security incidents or policy violations. Data pipeline architecture and management. Comprehensive data flow design for AI systems _. AI implementations require sophisticated data pipeline architecture that handles diverse data sources, transforms information appropriately, and delivers clean, reliable data to AI models while maintaining performance, security, and quality standards throughout the processing workflow. Data ingestion and source integration _. Design data source connectivity including database connections, API integrations, file system access, and real-time streaming that enable comprehensive data collection while maintaining security protocols and ensuring reliable data availability. Implement data format handling including structured databases, semi-structured files, unstructured documents, and multimedia content that enable AI systems to process diverse information while maintaining quality standards and ensuring appropriate formatting. Create scheduling and orchestration including automated data collection, dependency management, and workflow coordination that ensure timely data availability while optimizing resource usage and maintaining system efficiency and reliability. Design error handling and retry logic including connection failure recovery, data validation, and processing resumption that ensure reliable data collection while maintaining data integrity and minimizing impact from temporary problems or system disruptions. Data transformation and quality management _. Implement data cleansing including error detection, outlier removal, and consistency validation that ensure AI systems receive high-quality input while maintaining data integrity and supporting reliable model performance and business outcomes. Design data normalization including format standardization, unit conversion, and schema alignment that enable consistent AI processing while maintaining data relationships and ensuring compatibility across different sources and systems. Create feature engineering including data enrichment, derived variable calculation, and representation optimization that enhance AI model performance while maintaining computational efficiency and ensuring meaningful business insights and value creation. Implement data validation including quality scoring, completeness checking, and accuracy assessment that ensure data meets AI system requirements while identifying problems early and enabling corrective action before processing and analysis. Data storage and retrieval optimization _. Design storage architecture including operational databases, analytical warehouses, and AI-specific storage that optimize data access patterns while ensuring availability, backup procedures, and disaster recovery capabilities for critical business data. Implement caching strategies including intelligent data storage, query optimization, and result caching that reduce processing time while maintaining data freshness and ensuring consistent performance for frequently accessed information and common queries. Create data archiving including historical data management, compliance retention, and storage optimization that manage data lifecycle while maintaining access to necessary information and controlling storage costs and system performance. Design data lineage tracking including source identification, transformation history, and usage monitoring that enable data governance while supporting compliance requirements and enabling troubleshooting and quality improvement efforts. Security architecture and compliance framework. Enterprise security integration for AI systems _ AI systems must integrate seamlessly with existing enterprise security infrastructure while addressing AI-specific security challenges including model protection, data privacy, and result integrity that require specialized approaches beyond traditional application security measures. Identity and access management integration _ Implement single sign-on including enterprise directory integration, authentication delegation, and session management that provide seamless user access while maintaining security standards and enabling centralized access control and monitoring. Design role-based access control including permission hierarchies, resource-level security, and dynamic authorization that ensure appropriate access while supporting diverse user roles and maintaining flexibility for changing organizational requirements and responsibilities. Create privileged access management including administrative controls, elevated permission handling, and audit requirements that protect sensitive operations while enabling necessary system administration and maintaining security oversight and accountability. Implement multi-factor authentication including hardware tokens, biometric verification, and adaptive authentication that enhance security while maintaining usability and supporting diverse user environments and access patterns for both internal and external users. Data protection and privacy implementation _ Design data encryption including at-rest protection, in-transit security, and key management that ensure data confidentiality while maintaining performance standards and enabling necessary processing and analysis. Analysis for AI applications and business requirements. Implement privacy controls including data anonymization, access logging, and consent management that protect individual privacy while enabling AI processing and maintaining compliance with privacy regulations and organizational policies. Create data loss prevention including sensitive data identification, access monitoring, and transfer controls that prevent unauthorized data exposure while enabling legitimate business use and maintaining operational efficiency and user productivity. Design compliance frameworks including regulatory requirement mapping, audit trail maintenance, and reporting capabilities that ensure legal compliance while supporting business operations and enabling efficient regulatory reporting and oversight activities. Threat detection and incident response _ Implement security monitoring including anomaly detection, behavioral analysis, and threat identification that protect AI. Systems while enabling rapid response to security incidents and maintaining continuous security posture assessment and improvement. Design intrusion detection including network monitoring, system analysis, and attack pattern recognition that identify security threats while minimizing false positives and enabling effective response to legitimate security concerns and incidents. Create incident response procedures including threat containment, investigation protocols, and recovery planning that minimize security impact while maintaining business continuity and enabling rapid restoration of normal operations after security incidents. Implement security analytics including log analysis, correlation engines, and intelligence integration that enhance threat detection while providing actionable insights and enabling proactive security improvement and risk management throughout the organization. 8. For multi-model AI architecture, designing systems that leverage multiple AI capabilities. Understanding multimodal AI system architecture. Modern enterprise AI implementations increasingly require coordination among multiple AI models and capabilities to address complex business challenges that cannot be solved effectively by single-model approaches. This multimodal architecture requires sophisticated orchestration, data management, and result integration that enables diverse AI capabilities to work together while maintaining performance, reliability, and maintainability standards. Strategic multimodal implementation planning _ Designing systems that effectively leverage multiple AI capabilities requires understanding how different models complement each other while considering integration complexity, resource requirements, and maintenance overhead that affect long-term system sustainability and business value creation. Model selection and compatibility analysis _ Evaluate AI model combinations including natural language processing, computer vision, predictive analytics, and recommendation systems that address different aspects of business problems while ensuring technical compatibility and complementary capability enhancement. Assess model performance requirements including accuracy expectations, processing speed, resource consumption, and output quality that affect system design while balancing performance optimization with cost considerations and operational constraints. Design model interaction patterns including sequential processing, parallel execution, and feedback loops that enable effective collaboration while maintaining system performance and ensuring reliable result integration and quality assurance. Consider vendor diversification including multiple AI providers, open source alternatives, and hybrid approaches that reduce dependency risks while ensuring system flexibility and enabling negotiation leverage and technology evolution adaptation. Resource optimization and performance management _ Plan computing resource allocation including processing power distribution, memory management, and storage optimization that enable multiple AI models to operate efficiently while avoiding resource conflicts and maintaining overall system performance. Design load balancing including request routing, capacity management, and priority handling that optimize resource utilization while ensuring fair access and maintaining service quality for different AI capabilities and user requirements. Implement caching strategies including model result storage, intermediate computation saving, and intelligent cache management that reduce processing overhead while maintaining result freshness and enabling efficient resource utilization. Create scaling procedures including automatic resource adjustment, demand-based provisioning, and cost optimization that adapt to varying usage patterns while maintaining performance standards and controlling operational expenses effectively. Model orchestration and workflow management. Intelligent model coordination and decision routing _ Multimodal AI systems require sophisticated orchestration that determines when to use different AI capabilities while coordinating their interactions and integrating results into coherent outputs that serve business objectives effectively. Decision tree and routing logic implementation _ Design intelligent routing including request analysis, model selection, and capability matching that direct different types of requests to appropriate AI models while optimizing accuracy and performance for specific use cases and requirements. Implement dynamic model selection including performance monitoring, accuracy tracking, and adaptive routing that optimize model usage while maintaining quality standards and enabling continuous improvement through performance-based decision-making. Create fallback rollback mechanisms including alternative model usage, degraded processing modes, and manual override capabilities that ensure system reliability while maintaining service availability despite individual model failures or performance issues. Design confidence scoring including result quality assessment, uncertainty quantification, and decision support that enable intelligent model selection while providing transparency about AI system reliability and supporting human decision-making oversight. Workflow orchestration and process management _ Implement workflow engines including process definition, task coordination, and execution monitoring that manage complex AI processing while maintaining visibility and enabling optimization and troubleshooting of multi-step AI workflows. Design data flow management including input preparation, intermediate result handling, and output integration that ensure efficient information movement while maintaining data quality and enabling traceable processing workflows. Create dependency management including prerequisite handling, resource coordination, and timing optimization that ensure proper workflow execution while minimizing delays and optimizing resource utilization across multiple AI processing steps. Implement error handling and recovery including workflow resumption, partial result preservation, and alternative processing paths that maintain system reliability while minimizing impact from individual component failures or processing errors. Result integration and output synthesis _ Design result combination including weighted averaging, consensus building, and intelligent fusion that integrate outputs from multiple AI models while maintaining accuracy and providing coherent results for business decision-making. Implement conflict resolution including disagreement handling, priority assignment, and human escalation that address inconsistent AI outputs while maintaining system reliability and enabling appropriate oversight and quality assurance. Create output formatting including standardization, presentation optimization, and user interface integration that present multimodal results effectively while maintaining clarity and enabling efficient user understanding and decision-making. Design result validation including consistency checking, quality assessment, and confidence reporting that ensure output reliability while providing transparency about AI system performance and enabling appropriate user trust and reliance levels. Scalability and maintenance architecture. System growth and evolution planning _ Multimodal AI architectures must be designed for scalability and evolution that enables adding new models, updating existing capabilities, and adapting to changing business requirements while maintaining system stability and performance standards. Modular architecture and component independence _ Design loosely coupled architecture including service isolation, interface standardization, and dependency minimization that enable independent model updates while maintaining system integration and avoiding disruption to other components and capabilities. Implement containerization including Docker deployment, Kubernetes orchestration, and microservices architecture that enable flexible model management while simplifying deployment, scaling, and maintenance of complex multimodal systems. Create API abstraction including consistent interfaces, version management, and backward compatibility that enable model replacement while maintaining client application compatibility and avoiding disruption to users and dependent systems. Design configuration management including parameter storage, environment handling, and deployment automation that enable efficient model management while maintaining consistency and enabling rapid deployment and configuration changes. Monitoring and performance optimization _ Implement comprehensive monitoring including individual model performance, system integration health, and overall workflow efficiency that provide visibility into multimodal system behavior troubleshooting. Design. While. Performance. Enabling. Analytics. Optimization. including and bottleneck identification, resource utilization analysis, and optimization. Recommendations that improve system efficiency while maintaining service quality and enabling cost-effective operation. Create alerting systems including threshold monitoring, anomaly detection, and escalation procedures that ensure rapid problem identification while enabling proactive maintenance and minimizing impact on system performance and user experience. Implement capacity planning including growth projection, resource forecasting, and scaling preparation that ensure system scalability while maintaining performance standards and enabling cost-effective expansion as business requirements grow. Model lifecycle management and updates underscore. Design model versioning including change tracking, rollback capabilities, and testing procedures that enable safe model updates while maintaining system stability and ensuring quality assurance throughout the update process. Implement A/B testing including traffic splitting, performance comparison, and gradual rollout that enable safe model deployment while measuring impact improvements before full implementation. And ensuring create training pipeline integration including automated retraining, performance monitoring, and deployment automation that keep models current while maintaining quality standards and enabling continuous improvement through updated training data. Design governance frameworks including approval processes, change management, and documentation requirements that ensure responsible model management while maintaining quality standards and enabling efficient change processes and regulatory compliance. 8.5 Performance monitoring and optimization, ensuring long-term AI system reliability. Comprehensive performance monitoring framework. Long-term AI system reliability requires sophisticated monitoring that tracks technical performance, business impact, user experience, and system health while providing actionable insights for optimization and enabling proactive problem prevention rather than just reactive problem solving. Multidimensional performance measurement underscore. AI system monitoring must capture performance across multiple dimensions including technical metrics, business outcomes, user satisfaction, and operational efficiency while providing integrated views that enable holistic system optimization and management. Technical performance metrics and analysis underscore. Implement response time monitoring including API latency, processing duration, and end-to-end transaction timing that provide visibility into system performance while enabling identification of bottlenecks and optimization opportunities. Design throughput measurement including request processing rates, concurrent user handling, and system capacity utilization that ensure adequate performance while enabling capacity planning and resource optimization for growing usage demands. Create accuracy tracking including prediction quality, error rates, and model performance that ensure AI systems maintain business value while enabling model optimization and identifying degradation that requires attention or retraining. Implement resource utilization monitoring including CPU usage, memory consumption, storage requirements, and network bandwidth that optimize system efficiency while ensuring adequate resources and identifying scaling requirements. Business impact and value measurement underscore. Design business metrics tracking including conversion rates, user engagement, process efficiency, and revenue impact that connect AI system performance to business outcomes while demonstrating return on investment and value creation. Implement user experience monitoring including satisfaction surveys, usage analytics, and behavior tracking that ensure AI systems serve user needs while identifying improvement opportunities and maintaining positive user adoption and engagement. Create process efficiency measurement including time savings, error reduction, and workflow improvement that quantify AI system benefits while supporting business case validation and enabling optimization for maximum value creation. Design cost-benefit analysis including operational cost tracking, efficiency gains, and resource optimization that ensure AI systems remain cost-effective while enabling business justification and supporting investment decisions for system enhancement. System health and reliability assessment underscore. Implement availability monitoring including uptime tracking, service interruption detection, and reliability measurement that ensure consistent system operation while enabling proactive maintenance and minimizing business impact from system failures. Design error tracking including exception monitoring, failure analysis, and root cause identification that improve system reliability while enabling rapid problem resolution and preventing recurring issues that affect user experience. Create data quality monitoring including input validation, processing accuracy, and output quality that ensure AI systems receive reliable data while maintaining prediction quality and enabling early identification of data-related problems. Implement security monitoring including access tracking, threat detection, and compliance assessment that maintain system security while enabling rapid response to security incidents and ensuring regulatory compliance and data protection. Predictive analytics for system optimization. Proactive performance management and optimization underscore. Advanced monitoring systems use predictive analytics to anticipate problems, optimize resource allocation, and enable proactive maintenance that prevents issues rather than just responding to problems after they occur. Anomaly detection and trend analysis underscore. Implement statistical anomaly detection including baseline establishment, deviation identification, and pattern recognition that identify unusual system behavior while minimizing false alerts and enabling rapid response to legitimate problems. Design trend analysis including performance trajectory monitoring, capacity forecasting, and degradation prediction that enable proactive optimization while supporting capacity planning and preventing performance problems before they affect users. Create correlation analysis including cross-metric relationships, cause-effect identification, and system dependency mapping that provide insights into system behavior while enabling optimization and troubleshooting of complex performance issues. Implement predictive alerting including early warning systems, threshold prediction, and proactive notification that enable preventive action while minimizing system disruption and maintaining optimal performance through anticipatory management. Capacity planning and resource optimization underscore. Design growth modeling including usage projection, resource forecasting, and scaling preparation that ensure adequate capacity while optimizing costs and enabling efficient resource allocation for anticipated growth and changing requirements. Implement dynamic resource allocation including automatic scaling, load balancing, and optimization algorithms that adapt to changing demands while maintaining performance standards and controlling operational costs through efficient resource utilization. Create cost optimization including resource usage analysis, efficiency improvement identification, and cost-benefit optimization that minimize operational expenses while maintaining service quality and enabling sustainable long-term system operation. Design performance benchmarking including baseline establishment, comparative analysis, and optimization target setting that enable continuous improvement while measuring progress and identifying opportunities for system enhancement and optimization. Machine learning for system optimization underscore. Implement ML-driven optimization including performance prediction, resource allocation optimization, and automated tuning that improves system efficiency while reducing manual management overhead and enabling intelligent system self-optimization. Design intelligent alerting including pattern recognition, false positive reduction, and priority optimization that improve monitoring effectiveness while reducing alert fatigue and enabling focus on genuinely important system issues and optimization opportunities. Create adaptive thresholds including dynamic baseline adjustment, seasonal pattern recognition, and context-aware alerting that improve monitoring accuracy while reducing maintenance overhead and ensuring alerts remain relevant and actionable. Implement optimization recommendations including automated analysis, improvement identification, and action suggestion that enable proactive system enhancement while reducing manual analysis time improvement and enabling continuous performance. Continuous improvement and system evolution. Long-term system optimization and enhancement _ Maintaining AI system performance over time requires systematic approaches to continuous improvement that address changing requirements, technology evolution, and growing organizational sophistication while preserving system stability and reliability. Performance optimization cycles and methodology _ Design regular optimization cycles including performance review, improvement identification, and enhancement implementation that ensure continuous system improvement while maintaining stability and minimizing disruption to ongoing operations. Implement optimization prioritization including impact assessment, effort estimation, and value ranking that focus improvement efforts effectively while maximizing return on optimization investment and ensuring efficient use of development and maintenance resources. Create testing and validation procedures including performance testing, regression analysis, and impact measurement that ensure optimizations improve system performance while maintaining reliability and avoiding unintended consequences or degradation. Design rollback capabilities including change tracking, backup procedures, and restoration processes that enable safe optimization while providing recovery options and minimizing risk from optimization efforts that don't achieve intended improvements. Technology evolution and update management _ Implement technology refresh planning including platform updates, tool upgrades, and architecture evolution that keeps systems current while maintaining stability and ensuring compatibility with changing organizational requirements and technology standards. Design migration strategies including phased transitions, compatibility maintenance, and risk mitigation that enable technology updates while minimizing disruption and ensuring continued system operation throughout upgrade processes. Create evaluation frameworks including technology assessment, benefit analysis, and adoption planning that guide technology decisions while ensuring upgrades provide genuine value and align with organizational objectives and resource constraints. Implement change management including stakeholder communication, training updates, and support planning that ensure successful technology evolution while maintaining user adoption and minimizing impact from system changes and improvements. Knowledge management and organizational learning _ Design documentation systems including configuration records, optimization history, and lessons learned that preserve system knowledge while enabling efficient maintenance and supporting knowledge transfer for system management and enhancement. Implement knowledge sharing including best practice documentation, problem resolution tracking, and expertise development that build organizational capability while improving system management efficiency and enabling effective troubleshooting and optimization. Create training programs including technical skill development, system knowledge transfer, and optimization methodology that ensure organizational capability while maintaining system management quality and enabling effective long-term system operation and enhancement. Design institutional memory including decision tracking, rationale documentation, and historical analysis that preserve system evolution knowledge while enabling informed future decisions and avoiding repetition of past mistakes or suboptimal approaches. 8.6 Deployment pipeline development from prototype through maintenance, production, comprehensive deployment pipeline architecture. 2. Successful AI system deployment requires sophisticated pipeline development that manages the complete journey from initial prototype through production deployment to ongoing maintenance while ensuring quality, reliability, and business value throughout the system life cycle. Development and testing pipeline design _ Effective deployment pipelines begin with robust development and testing procedures that ensure AI systems meet quality standards before production deployment while enabling efficient development cycles and maintaining code quality throughout the development process. Continuous integration and development workflow _ Implement version control including code repository management, branching strategies, and merge procedures that enable collaborative development while maintaining code quality and ensuring proper tracking of changes and development history. Design automated testing including unit tests, integration tests, and system validation that ensure code quality while enabling rapid development cycles and providing confidence in system reliability before deployment to production environments. Create build automation including compilation procedures, dependency management, and artifact creation that ensure consistent deployment packages while minimizing manual errors and enabling reproducible builds across different environments and deployment targets. Implement code quality enforcement including static analysis, style checking, and that security scanning maintain development standards while enabling efficient development and ensuring code meets organizational requirements for quality and maintainability. Environment management and promotion strategy _ Design environment progression including development, testing, staging, and production environments that enable safe system evolution while providing appropriate isolation and ensuring proper validation before production deployment. Implement configuration management including environment-specific settings, secret management, and parameter control that ensure consistent deployment while maintaining security and enabling customization for appropriate different environments and requirements. Create database migration including schema updates, data transformation, and backup procedures that enable system evolution while maintaining data integrity and ensuring safe database changes throughout the deployment pipeline. Design infrastructure as code including automated provisioning, environment replication, and consistency management that ensure reliable deployment while reducing manual configuration and enabling rapid environment creation and management. AI-specific testing and validation procedures _ Implement model validation including accuracy testing, bias assessment, and performance evaluation that ensure AI models meet business requirements while maintaining quality standards and ensuring reliable performance in production environments. Design data pipeline testing including data quality validation, transformation verification, and integration testing that ensure reliable data processing while maintaining accuracy and ensuring proper system operation with real-world data sources. Creative B testing frameworks including statistical design, traffic management, and results analysis that enable safe model deployment while measuring business impact and ensuring improvements before implementation. Full production rollout and implement performance testing including load simulation, stress testing, and scalability validation that ensure production readiness while identifying potential bottlenecks and ensuring system performance under expected usage patterns and peak loads. Production deployment and release management. Safe and reliable production deployment procedures _ Production deployment requires careful orchestration that minimizes risk while ensuring smooth transition from development to live operation with real users and business-critical requirements. Blue-green and canary deployment strategies _ Design blue-green deployment including parallel environment management, traffic switching, and rollback capabilities that enable zero downtime deployment while providing immediate recovery options and ensuring minimal impact on users during deployment processes. Implement canary deployment including gradual traffic increase, performance monitoring, and automated rollback that enable safe feature deployment while measuring impact and ensuring quality before full release to all users and production traffic. Create feature flags including toggle management, user targeting, and gradual enablement that enable controlled feature release while providing flexibility and enabling rapid response to problems or performance issues during feature rollout. Design deployment automation including scripted procedures, validation checks, and success verification that ensure consistent deployment while reducing manual errors and enabling rapid, reliable deployment processes across multiple environments. Monitoring and validation during deployment _ Implement deployment monitoring including real-time performance tracking, error detection, and user impact assessment that ensure successful deployment while enabling rapid identification and response to problems during the deployment process. Design health checks including system validation, functionality verification, and performance assessment that confirm successful deployment while providing confidence in system operation and enabling automatic problem detection and response. Create user experience monitoring including performance tracking, error monitoring, and satisfaction measurement that ensure deployment success while maintaining service quality and enabling rapid identification of user impact from system changes. Implement automated rollback including trigger conditions, restoration procedures, and notification systems that enable rapid recovery while minimizing impact from problematic deployments and ensuring system reliability and availability. Release communication and change management _ Design stakeholder communication including release notifications, feature announcements, and training updates that ensure proper preparation while building support and enabling successful user adoption of new features and capabilities. Implement user training including documentation updates, training materials, and support resources that enable effective feature adoption while minimizing confusion and ensuring users can benefit from new capabilities and system improvements. Create support procedures including help desk preparation, troubleshooting guides, and escalation processes that ensure adequate support while enabling rapid problem resolution and maintaining user satisfaction during transition periods. And design feedback collection including user input gathering, issue tracking, improvement identification that enable continuous enhancement while building user engagement and ensuring system evolution serves user needs and business objectives effectively. Long-term maintenance and lifecycle management. Sustainable system operation and evolution _ Long-term AI system success requires systematic maintenance procedures that keep systems operating effectively while enabling evolution and improvement in response to changing business requirements and technological advancement. Operational maintenance and system care _ Implement routine maintenance including system updates, security patches, and performance optimization that keep systems current while maintaining reliability and ensuring continued operation within organizational standards and security requirements. Design backup and disaster recovery including data protection, system replication, and restoration procedures that ensure business continuity while providing rapid recovery from failures and maintaining data integrity and system availability. Create monitoring and alerting including performance tracking, error detection, and notification systems that enable proactive maintenance while ensuring rapid response to problems and maintaining optimal system performance over time. Implement capacity management including resource monitoring, scaling procedures, and optimization planning that ensure adequate performance while controlling costs and enabling efficient resource utilization as system usage grows and evolves. System evolution and enhancement planning _ Design enhancement cycles including feature planning, improvement identification, and development scheduling that enable continuous system improvement while maintaining stability and ensuring enhancements provide genuine business value and user benefit.